personalities with us today. On behalf of the House, it gives me great pleasure to now felicitate our respected dignitaries who have been kind enough to grace this occasion with their presence. तो समय है हमारे समारोह के विशिष्ट अतिथियों के सादर अभिवादन का। मैं अब निवेदन करूंगी श्री एच ए पाठक सर से कि वे आए और शॉल एवं फ्लावर पॉट द्वारा हमारे रिस्पेक्टिव हीलिंग वर्क्स आईएसपी एंड चीफ गेस्ट फॉर द ओकेजन श्री दिव्येंदु घोष सर जी का स्वागत करें। थैंक यू सर। अब मैं श्री शैलेंद्र कुमार सर से आग्रह करती हूँ कि वो हमारे आज के गेस्ट ऑफ ऑनर एक्स सीईओ आईएसपी डीएसपी एंड एएसपी श्री ए कमलाकर सर का स्वागत करें। You shall work at your name. Now, I would request the Bhavan sir to use them to please welcome ED Project Sri Sujit Mishra sir with presenting a shawl and a platform. Sir, please. I would request Shailendra Kumar sir to please welcome Indian and Shri sir with a shawl and a platform. Sir, please. आप तो लैपटॉप है क्या कर रहे हैं ठीक है मैं निवेदन करती हूँ श्री एजे पाठक सर से लैपटॉप उधर लगा कि बाद में ले ले काम कर लेना इसमें बहुत फायदा है तभी टीवी में सपोर्ट नहीं कर पेन टेप ला देगा दो छोटा छोटा वाला ये वाला आने से घर से घूम कर जा लेकर जा है ना किधर चलना है किधर वहाँ पे तालियां बज रही हैं। मैं आग्रह करती हूँ अब श्री शैलेंद्र कुमार सर से कि वो ईडी एफएनडी श्री आर मुखर्जी सर का शॉल से स्वागत करें। This is invited sir to welcome officially DHR Shri Beauty Singh sir representing a shawl on the platform. Sir, please. Please guard of those ladies and gentlemen. Now I will request Shailendra Kumar sir
who is welcome CMOIC Ministry Dr. Sushant Singh representing Shawl platform.
চেঞ্জ করতে হবে।
अब मैं निवेदन करती हूँ श्री सोमनाथ खड़े सर से कि वो इस स्टेज पर आए और हमारे आदरणीय सेक्रेटरी आरओसी डॉक्टर सुशांत दत्त का शॉर्ट ब्रेक पर स्वागत करें। Shailendra sir, Pathak sir, and Somnath Dey sir for doing the honors. Now, I would now request all of you to please take the seat in the first row of the auditorium. I request Shailendra sir and Pathak sir to score the please.
Sorry. समझ में ही है ना। समझ में ही है ना।
So moving forward to the program, now I will invite Shailendra first. While please coming for the welcome letters to get it. Studies. The home will start. Second, see Nibrand Africa, Director in Charge DSPC, the additional charge of Director in Charge ISP, DSP, and ASP, joining us online. Sri Dipindu Bosa, Executive Director of SAIL-ISP Burnpur, and PKS of the inaugural session. Respected Sri A.V. Karnataka, sir, XCO, ISP, DSP, and ASP, and guest of this edition of RMC. Assistant Executive Directors of ISP and Kulti, Citizens of ISP and CGM Kulti, Dr. Esther, Secretary RMC, Senior Officers of the Special Plan, invited here, distinguished participants from state religions, R&D and consulting organizations, and reputed national and international manufacturers and technology suppliers, members of the branding committee, friends, ladies and gentlemen. It's my distinct privilege to extend a warm welcome to each one of you to the 2 years rolling cooperative communication hosted by Speak over the next 2 days. Today, we are honored to be joined by experts from various speed plants, including BSP, BSL, DSP, ISP, RDP, SSP, and AFC, as well as participants from Tata Steel's plants in Jamshedpur, Naluganagar, Parapur, Meramandali, and Kamaria. We also welcome representatives from JSW Steel's Vijayanagar, Dolby, and Seven plants, JSPL's Angul and Patatu plants, NMDC Steel at Nanganar, Vitek Steel Plant of RIN, Hisar Steel Plant of GSF, and AMS Hajira. The presence of MECON, SET, RDCS, and SET Corporate Office further enriched our discussions and collaborative efforts. Additionally, we are delighted by the overwhelming participation of leading manufacturers and technology suppliers also, including Messrs. General India, Messrs. SMSB, L&T, Infinite Time, Walter Hoover, Hydraulics, Kimberly Clark, Behavioral Engineering, Something here, Calcrisha India, Associate Engineers, Loctite CM, Sony Rubber, Bharat Roads, and many others. Your esteemed projects combined with the collective expertise of ISP's ruling milking promises to make this gathering highly interactive and insightful. Burnpur, an industrial hub nestled in the heart of West Bengal, welcomes you with its natural beauty and well-planned towns. A crucial contributor to India's steel industry, Burnpur is known for producing high-quality steel that serve diverse sectors. The moderate and pleasant climate further enhances the charm of your region. Fortunately, this is present incident. We deeply appreciate the distance since many of you have traveled and explored our French places for a comfortable and enjoyable stay in Burnpur and Asansol, Twin City. Rest assured, every effort has been made to make this event a memorable experience for you. The primary focus of this ROC meeting is performance improvement of flat and long rolling mills. Our discussion will center on addressing operational challenges, implementing techno-economic enhancements, improving product quality, and advancing rolling technology for both flat and long rolling mills. This forum provides an excellent platform to share innovative solutions and experiences benefiting mills across the industry. Moreover, it serves as an avenue to exchange insights on actions taken to improve key techno-economic parameters as well as the dimensional and surface quality of the products. Modern rolling mills are equipped with cutting-edge automation systems, reflecting the ongoing digitization of our industry. Operating and managing these new units demanded paradigm shift in skills and expertise. This forum is an ideal space for exchanging experiences in handling advanced state-of-the-art facilities. In essence, the rolling mills operating committee meeting is a vital interaction platform where engineers, technology suppliers, researchers, and consultants come together to collaboratively address operational challenges and drive progress in rolling mills. We are coming together as a unified community of rolling mill operators, experts, and equipment manufacturers to share our ideas, experiences, and best practices in mill operations. The RMC embodies the perfect blend of competition and collaboration, where industry leaders, rolling mill operators, and equipment manufacturers unite not just to showcase their expertise, but to collectively push the boundaries of excellence. This collaborative platform enables us to learn from each other's successes and challenges across various types of rolling mills, fostering innovation and continuous improvement. By engaging with mill equipment manufacturers, we also explore cutting-edge technology and solutions tailored to our operational needs. While each of us strive to achieve the best in our respective mills, it is the exchange of insights and learning from one another's challenges that we drive industry-wide innovation. Here, competition fuels the drive for excellence, while collaboration ensures that knowledge and advancements benefit the entire ecosystem. The unique synergy empowers us to strengthen our capabilities, embrace technological advancements, and contribute to the larger vision of Atmanirbhar Bharat, making India's rolling industry more self-reliant and globally competitive. So this knowledge exchange, we are collectively working towards a stronger and more independent steel industry, enhancing efficiency, reducing dependency on external resources, and building indigenous capabilities for a sustainable future. In conclusion, I once again extend a warm welcome to each of you. Many meetings serve as an invaluable opportunity for learning, collaboration, and technical enhancement. Wishing you all a productive and enjoyable stay in Burnpur. Thank you.
Thank you so much, sir, for proposing the welcome address, and welcoming all the dignitaries, participants, manufacturers, and sponsors. Thank you, sir. So now, moving further, I would invite Secretary RMOC, Dr. Shishant Rath, please come on the podium and present the RMOC report. Sir, please.
Hello, good morning. On behalf of RMC Secretariat, I welcome Sri Anirban Dasgupta, Director in charge BSP Cell, with the additional charge of Director in charge ISP, BSP and ASP, who is joining us online. Sri Dityendra Ghosh, Executive Director Works, SAIL-ISP Burnpur, and Chief Guest of the inaugural session. Sri A.B. Kamlakar, CEO, and guest of honor of inaugural session. Executive Directors of ISP and full team. CGMs of ISP, senior officers of ISP, and delegates from different steel plants and units across India to the 58th Rolling Mill Operating Committee meeting for the financial year 2024-25 being hosted by ISCO Steel Plant from 14 to 15 February 2025. Rolling Mill Operating Committee was formed in the year 1974. In the beginning, there was participation of SAIL, Tata Steel, and Mekon. Now we have participation from rolling mills of SAIL, Tata Steel, JSW, JSPL, RINL, Mukon, JSL, NMDC Steel, AMNS, Vedanta ESL, and Mekon. Friends, ROC meeting is not a conference. Its main focus is implementation of short-term and long-term ideas after returning from this meeting based on the learning from the experience of other sorts. So for that, we have a special exercise on formulate our recommendations during the concluding session. Participants of each SOP will have to identify at least new short-term and long-term projects which they are likely to implement in their plans. A recommendation sheet is available with the session managers. So participants are requested to update the recommendation sheet after each session. Which secretariat will periodically follow the progress of the recommendations. Dear participants, ROC is a forum for exchange of information, operating experience, ideas, and views among engineers and working in rolling mills of different steel plants of the country. This also helps to provide a communication channel among rolling mill engineers of different steel plants. ROC also creates a platform for social connections among engineers of different steel plants for mutual sharing of expertise and experience. Also, engineers from different plants get opportunity to visit the organizing plant and get intelligence about systems and practices. ROC Secretariat is thankful to ISP for hosting the 58th ROC meeting. Generally, during ROC meeting, we decide the venue of the next ROC meeting. I request the participants of steel plants to discuss with their competent authority to hosting the next ROC meeting. The host plant gets an opportunity to nominate more participants for the meeting and gets more knowledge than the other participating plants. In this 58th rolling mill operating meeting, total number of participants is 123, including 43 participants from ISCO steel plant, some of them are in the organizing committees. There are in total 79 participants from different units of SAIL, eight participants from different units of Tata Steel, 12 from JSW, 7 participants from JSPL, 5 from JSL, 4 from RINL, 3 from AMNS, 2 from NMDC Steel, and 2 from Mekon. I will share the contact details of all participants shortly. There will be total 53 presentations scheduled in this meeting, out of which 42 numbers will be presented presented by the participants and 11 by technology suppliers invited to the meeting. Out of the 42 presentations, there are 20 presentations on flat rolling and 21 from long of self rolling. The presentations include various topics, including improvement in productivity, quality of products, improvement in techno-economic parameters, data analytics, and AI applications in rolling mills. The Secretariat of RMC of Rolling Mills Operating Committee compiles economic parameters like rolling rate, meal availability, meal utilization, specific heat consumption, specific road consumption, etc. of different rolling mills and share them with other contributors. As a principle, we share the collected techno-economic data only with those clients who have shared their data to the RMC Secretariat. This year we have participation from 42 different rolling mill shops. We have received techno-economic parameters of 41 mills and we will share the data among all the 41 mills soon. I want to mention that a WhatsApp group named ROMC is working since 2015 in which 359 engineers from different steel plants across India are members till date. So we discuss different issues in this forum. I will add all the members who are attending this meeting. On behalf of the ROC Secretariat, I once thank all the dignitaries and participants of 58th ROC meeting. I hope the meeting will provide a great learning platform for all participants. Thank you all once again.
Thank you so much to Dr. Sushant Ratsa for giving us insight on this committee, motivating the participants for mutual sharing of the expertise to be implemented in the future. Thank you so much, sir. Now it's time to listen to our respected leading works and chief guest for this occasion, Sri Diptendu Ghosh Sarji, for his words of wisdom and for his words of motivation for all our participants. So please.
Good morning, everybody. Esteemed guests, distinguished speakers, delegates of the Rolling Mills Operating Committee, R&D and consulting organizations, Indian and international manufacturers, technology suppliers, ladies and gentlemen. It is an honor to have the presence of esteemed rolling mill experts from various steel plants such as Tata Steel, JSW Steel, JSPL, Jindal Stainless, and SAIL. We are also privileged to have our distinguished keynote speaker, Sri A.V. Kamlakar Saab, our ex-CEO. The operating committee on rolling mills was established to create a platform for operations of different rolling mills nationwide to exchange informations, experiences, ideas, and perspectives. The primary goal of the committee is to facilitate communications among various steel plants. Currently, the committee includes rolling mills from integrated steel plants along with RDCIS, SET. Members of the committees are dedicated to enhancing their operations and processes by sharing knowledge and learning from each other. Through collaborations, they can identify best practices and innovative solutions that benefits the entire industry. Over the next 2 days, we will delve into latest developments, challenges, and best practices of rolling mill operations. who will share knowledge on topics such as advances in rolling mill technology pertaining to both long and flat models, enhancing rolling mill performance, quality control and assurance, strategies for maintenance and reliability that encourage each of the participants to actively participate, share the contribute to the rich exchange of ideas. Your insights will help shape the future of rolling mill operations and drive our industry forward. Thank you all for being a part of the important gathering. I formally declare 58 rolling mill operating commitment. Make this event a great success. Thank you.
Thank you so much, sir, for the inaugural address and talking about the best practices and innovative ideas for the industry in rolling mills operation. Now, moving ahead with the program, next is the turn of our keynote speaker, a leader bringing expertise of building, nurturing, and leading businesses. He has worked extensively in rolling mills, is a prolific metallurgy engineer, is providing consultancy to several manufacturers right now and is present on several boards. Let me take the opportunity to our esteemed guest, our guest of honor.
When this in the operating committee, I was discussing with thinking it is impossible, but somewhere in other plant, this is a regular practice. What Divenuji was telling, you you discuss with your peer not only the your good practices, but also your problems. We generally shy away that we don't want to tell our problems for other people. We always say, yeah, हम बहुत अच्छा करते हैं. But what is the problem with you? You just share with this team, maybe it is a flat or long. Then you will find very good solution. So this is the one request I just wanted to make with the participant. And another request to Rajji that whenever you are presenting this RMOC feedback here, you just cite certain examples like how the plants are benefited by this platform. Some example. So that people are motivated to attend this program very seriously because they are coming from distance like JSW, JSPL, SPL, INL. I heard soft reduction first in this RMOT meeting from RINL colleague of the task. I was not aware of the soft reduction in the task. So this platform is a very good platform and the challenges before the rolling mills right now. What I feel with my experience, number one is the cost of production because we are in the competitive market. You can say garden variety product of TMT which is produced by the primary or the secondary producers. But the cost again is a governing factor for the market. So cost of production is very important. So you have to discuss what are the losses in your process. When I was a project manager of Universal Railway setting up in Bhilai Steel Plant and I was in Germany with the our colleagues with the SMS and I was just seeing the layout and I asked them where I will keep my covers. And then he said, what is this cover? I was astonished to hear the word cover. No, in our way no cover. And we used to produce nearly 2 to 3% covers in the plant. What is the acceptance level? They say 99%. And it's not possible. It is hardly 80-85%. So they why there won't be any rejection in our mill. So we have to reach to that level in the mills. The rolling mill because there is a rolling mill platform. So we have to work for that. We have to, which is a dream for today. But you will see now the rail mill. I have seen someone from rail mill is here. You are. So
Now the URM, we are achieving nearly 90%, 92%. It was a dream initially that we will not reach around 80% or 85%. Now it is 95. Sometimes it is we are getting 96%. So this is how the things are moving ahead. So how to minimize the losses, how to improve the yield, contribution will our that is very important for the product mix, which has to be deliberated in these sessions. We have to work on the mill availability. We say we have a fixed delays and some other delays, but now everything comes into a delay. So how to improve our mill availability? That is another challenge. Quality of the products. It is in the Six Sigma, they say it is measured in the ppm, not in the percentage. We are measuring the percentage. Our rejection is 1%, 2%, 3%. But Six Sigma says it is a ppm, parts per million. They talk about the parts per million. That is the rejection percentage right now. So we have to target those things so that our will profitability will increase. I am really thankful for the ISP to hosting this program because this is a very apt time in ISP. We are going for a big modernization. So particularly in the flat area, we are going for a modernization. So our team, our ISP team, should talk to all the platform manufacturers here. What are the concerns there in their mills so that we can take care in the project formulation stage so that the entire benefit will come to the plant. So I wish this program a great success and I wish the participants will benefit from here and they will have a good takeaways which will help benefit in turn the organization and the individual because this is a very good learning platform. Enrich your knowledge, your expertise. Thank you. Thank you.
Thank you so much, sir, for your encouraging words and highlighting the importance of RMOs in meeting. Uh, now, moving forward, it's time to listen to uh, the Rafting College, Bandas Gupta, sir, AIC, ESP with additional charge of ISP, DSP, and ASP. So, due to official exigencies, sir, couldn't join us personally, but we are thankful to sir for taking time out of his busy schedule and joining us in virtual mode. So we are eagerly waiting to listen to your words of inspiration. And I would request you, sir, please kindly address me.
Thank you very much. A very good morning to you all. My morning to the
Audible?
oh, thank you. So a very good morning to all, and welcome to Burnpur. And I'm really sorry, I must apologize at the outset that I couldn't be there personally because of various reasons. Anyway, I'm there with you. Uh, and so the chief guest of the function, Sri Dityendu Ghosh, ED Works of ISP Burnpur. Guest of honor, our Sri Edi Kamlakar Saab, executive directors, chief general managers, and delegates from SAIL, Tata Steel, RINL, JSW, JSPL, MANS, and NSL, and other, and our partners, our vendors, our technology suppliers from various companies. And my ladies and gentlemen, it's indeed a pleasure to address you. And ROMC, or for that matter, any of community meetings which we have, is to share knowledge, to learn from each other, and to collaborate. Although some of us may be competitors, but we are also collaborators. Goal is same, to improve the steel industry, the Indian steel industry will be highly competitive in the global market. As we know, friends, that the global market is very competitive. India is also seized with imports, falling prices, international prices. So, as our guest of honor Kamlakar Saab told, we have to be highly, highly competitive. Cost of production, that would be one, which will kind of insulate us from all kinds of global imports. If we are strong and our cost of production is very, very competitive, the threats of imports also come down. So we'll have to work on that front. And the rolling, the finishing mills, being a end of the supply chain of the rolling mills. So convert into highly efficient and high quality products will be our target. Innovative in terms of product quality, leaner chemistry, so that we can get the same mechanical properties with a leaner chemistry and be highly cost competitive. Energy efficiency, as we know, we are all facing a global threat of wind emissions, make rolling mills highly energy efficient. The role of the efficiency of the reheating furnaces, hot charging, followed by high yield, almost zero cobbles, very high acceptance and quality standards. So that with the minimum material consumption, we produce maximum quantity of products. I'm also very happy to know when Mr. Our Secretary shared that ROC Rolling Mill Operating Committee already has uh, a WhatsApp group which is about a decade old. I think it has happened since 2015. I was telling, as you was telling, with more than 300 subscribers and members. That's an excellent thing which you have started, and so that we come to know about each other's progresses, innovations, and can adapt in other plants also. Uh, we are so there. I think the role of digitization and AI will also play a major, major role. So I would request the participants to share among themselves the digitalization efforts which have been made in their respective rolling mills. Because this is going to be the edge, the competitive edge which we have, and we can really be highly competitive internationally. So with this, I'm very sure that a lot of, I think about more than 40 papers from the various rolling mills of about 41 rolling mills which are participating uh, will be deliberated in the next 2 days, followed by excellent presentations from our technology suppliers. We always are very eager to learn from them, to know the latest developments in the area of rolling and finishing, which will help us. And as was also mentioned by Kamlakar Saab, that ISP is embarking upon a new expansion plan where they are going to add another 4 million tons of capacity, the existing capacity. So very exciting times for ISP, and ISP also will be venturing into flat products. So far they were into long products. So, and with the proposed hot strip mill, they will be entering into the area of flat products. So very exciting times, and ISP would be one of the steel plants where both long and flat products would be there in the product mix. So I will request my ISP friends to learn more about the flat rolling mill aspects from their colleagues in other steel plants, interact with the vendors, and all of you. And at the end of this 2 day seminar, or 2 day workshop, operating committee workshop, I'm very sure that lot of implementable points would come, which you can go and implement in your respective plants to overall improve rolling mill efficiencies and product quality. So I once again welcome you all to Burnpur. Have a pleasant stay. I'm very sure my team from Burnpur will take excellent care of you, and you'll all enjoy these 2 days here in Burnpur. Thank you very much. All the very best.
Thank you so much, sir, for gracing this occasion by your distinct presence. and you motivated us in aligning all of us together for a common and a major goal of producing efficient and high quality products. Being energy efficient also, you talked about improving the techno-economic parameters also, and majorly the role of AI in our improving processes. Thank you so much, sir, for your words of wisdom and motivating all participants and facing these occasions. Thank you so much. Now, moving ahead with the program. Sirs, your vast experience and leadership have always been a source of inspiration for the industry. We are truly honored to have you all here. It's time to present a memento to all our dignitaries. So we'll begin with the memento giving ceremony. First of all, I request Shri H.N. Pathak sir to present a memento to our respected ED Works ISP and Chief Guest for the occasion, Shri Hitendra Ghosh sir. Huge round of applause in the Now I request Shri Sanindra Kumar sir to present the memento to our guest of honor, our ex-CEO, ISP, DSP and ASP, Shri A.V. Kamlakar sir. तालियां बजती रहे.
Present a memento in the insurance features. Okay. Wow. Sorry. To answer, it present in writing to EDN clear basis. Subjects.
Now I will request Shri H.M. Pathak sir to present a memento to our ED colleague Shri Anil Kumar sir. Now I request Shri Shailendra Kumar sir to present a memento to ED FNA Shri Alok Mukherjee sir.
Now, I will request Liaison Bhagat sir to present the moment of which any major scenario section. Now, I would request Shailendra Kumar sir to present the moment to CMO IPM Energy Operating Transfer. Sir, please.
Now I will request Shri Secretary Sir to present a memento to our Secretary ROC, Dr. Sushant sir.
Now, thank you, sir, for doing the honor. Now, moving towards the building of this session. So, I would invite Shri Vijay Patil, sir, CGM USM, to propose a vote of thanks to this wonderful candidates. Sir.
Good morning. Respected Sri Anirban Gupta sir, Director in charge BSP SAIL, with additional charge of Director in charge ISP, DSP and ASP, who has joined us online. Sri Jitendu Ghosh, Executive Director Works, SAIL ISP Burnpur, and Chief Guest of the inaugural session of 58th Rolling Mill Operating Committee. Sri A.V. Kamlakar sir, ex-CEO ISP, DSP and ASP, and guest of honor of the inaugural session. Executive Directors of ISP, CGMs, Dr. S. Rath, Secretary, RMOC, other senior officers of ISPO Steel Plant, and invited guests. Distinguished participants of the RMOC meeting from different Indian steel rolling mills, R&D, and consulting organizations, reputed Indian and international manufacturers and technology suppliers, organizing committee members, friends, ladies and gentlemen. It is both a privilege and an honor to express my heartfelt gratitude as I stand before you to propose the vote of thanks for the resounding success of the inaugural session of the 58th Rolling Mill Operating Committee meeting. Our sincerest appreciation goes to the esteemed dignitaries who graced the occasion, generously sparing their valuable time amidst their demanding schedules. A special thanks to Sri Anirban Das Gupta sir, Director in charge BSP, SAIL, with additional charge of Director in charge ISP, DSP and ASP for his insightful address, shedding light on the current and future challenges in the rolling mill operations. The success of the event would not have been possible without the unwavering support and guidance of Jitendu Ghosh, Executive Director Works, SAIL ISP, Burnpur and Chief Guest of the session, whose inaugural address set the tone for the entire meeting. Our heartfelt gratitude extends to the senior dignitaries of ISCO whose presence and support added strength to our objective. We are indebted to the steel industry and technology suppliers whose overwhelming response made this gathering possible. A sincere thanks to delegates from various parts of country joining the RMOC meeting for sharing their experiences. A special acknowledgement to the press and media for covering the proceedings, ensuring the reach and impact of RMOC meet. Our appreciation also goes to the technology suppliers for their support in sponsoring the events. We not only remember you for your technological contributions, but also for your generous hospitality. Thanks to all senior officials of ISCO Steel Plant, RTCIS, committee members for their tireless efforts in organizing this event. The grand success of the program is a testament to your dedication. We are grateful for the support and assistance from different departments of ISCO Steel Plant, without which this event would have not been possible. Last but certainly not the least, my sincere thanks to each one of you, whether directly or indirectly involved, for your contributions that led to the overwhelming success of the event. Thank you one and all.
Thank you so much, Mr. Bhagat sir, for posing the vote of thanks. As we work together today, we have unique opportunities to leverage our collective expertise, exchange ideas, and explore new strategies that will strengthen our operations and contribute to the overall success of SET. So your participation here reflects the commitment of each organization to not only achieve the excellence in production, but to support the development of a more sustainable, innovative, and resilient steel industry.
The discussions we will have today and tomorrow will undoubtedly pave the way for continued progress, ensuring that we stay at the forefront of this ever evolving field. Once again, I welcome you all and thank you for your time and valuable contributions. I look forward to the insightful discussions ahead on the opportunity to work collaboratively towards a shared vision of success. Thank you once again for your presence and continued support. We are truly honored to have you all with us. Now, I will request everyone to rise up at their place for SAIL anthem.
You all. So now I would invite you all for hiding at the dining area. We will start the parallel sessions by 11:50. The session on flat products will be held in this auditorium, and the session on long products will be held in the hall. That was the right side of the session.
স্যারকে ডাকুন না, স্যারকে জেলে অপারেটিং করছে
Dining.
দুটো ইয়াতে ফটো দিতে হবে, চেঞ্জ হচ্ছে না ফাইলটা, ফট করে কিছু ফটো লাগিয়ে দেবো লাইভের মধ্যে। স্যারকে ডাকুন না, সাম্বল কিছু নিন স্যার কাছে, ডাকুন না স্যারকে।
Good morning.
আচ্ছা অভিয়াস হ্যাঁ অভিয়াস আছে লোড করছি এতে কি লোড করতো না না কোন থেকে হ্যাঁ
And we can start this. I request Mr. sir to please raise your hand. Yeah, thank you. Mr. Himanshu Ranjan from KSK. Mr. Pankaj Singh from KSW. Mr. N. Prashant. Mr. Jitendra Kumar from
কথা বলি দাদা
CSL.
তো বটেই আগে থেকে না বলে
Mr. Jitendra Kumar from CSL.
লাও লাও ঠিক আছে কি সফটওয়্যারটা কপি ডাউনলোড করো দেখো তোমার পায়ে লেন্থ আটটা আছে 7-8টা লাগাইলে লেন্থ আট চলে এসছে তো
Mr. Jitendra. Mr. S. K. Swain from SAIL-ISP. Mr. Ankur Sethi from GSL Hisar. Yeah. It is my pleasure to welcome you all to this insightful session on flat rolling mills, a crucial component of modern metal processing and manufacturing. As a part of the rolling mills operating committee event, this session aims to foster knowledge sharing, innovation, and best practices in the operation and optimization of flat rolling mills. Black rolling mills play a vital role in producing high quality metal sheets and strips used across major industries from automotive and aerospace to construction and consumer goods. With advancements in technology, automation, and efficiency, the landscape of rolling mill operations
এই
is evolving rapidly,
পেটটাকে বলো ব্র্যান্ড
presenting
করবে
challenges as well personally. Today we are privileged to have with us experts who will share their life experiences and strategies for enhancing productivity, quality, and sustainability in flat rolling mill operations. We encourage active participation, discussions, and the exchange of ideas to make this session truly enriching for all of us. Once again, I extend a warm welcome to each of you. Let's make this session a productive and engaging one. Now I request Mr. Manish Singh to please present and
1000 দে দে
share us with his insights.
আচ্ছা আচ্ছা ঠিক আছে चालू আছে हेलो टीवी चला के लड़का ना ठीक है रुक हम देख
I would request Mr. Manish to
ना
raise
ठीक है रुक 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 हम देख रुक
forward state
कॉल कर
Mr. S. N. Gupta sir from Turkey.
কি হয়ে গেল চালু করে দিয়েছি ছাড়ো না ও হয়ে যাবে চলো হ্যাঁ হয়ে যাবে না ওটা পজ করে রেখেছি আর কেন আমি চালাই দেবো থাক না এটাতে দুটো লিঙ্ক আলাদা আছে তো ওটা পজ করে রাখা আছে কোনটা এখন তো ভিতর বাইরে চলছে ওটা তো খতম হয়ে যাবে না মানে এটা চালু হবে না দুটো একসঙ্গে চলবে দুটোই শুনবে সে তো বেশিক্ষণ নেই দুটোই খুলে দিতে
He has what is a large experience of among sales cars. He has done leave from Cebu.
কত মাস চলবে
He has joined TDS
ডাইরেক্ট লাইন এটা তো বুঝতে না এটা ডাইরেক্ট ক্যামেরা তো এই বাইরেটা
and then he was elevated at the front of the participant TDS. Further, he joined 20 as TJ Works in 2022. Thank you for the time.
हो गया लैपटॉप लगाया
ওইটাই দিয়ে দিচ্ছে সবাই
In the presentation, there will be a presentation and the time limit for doing is 10 minutes. 8 minutes for presentation and 2 minutes for question and answer. May I call Mr. Neeraj Jha of PSM. He will be giving presentation on game and ultra game platform. Mr. Neeraj Jha.
Yes, good morning. Hello. Yes. Good morning, all of you. And as I got the opportunity to share or exchange knowledge, ideas about the thin and ultra thin flat rolling. We have at Tata Steel, we have facility of 6 high reversing cold rolling mill. There are 3 cold rolling mills of 1 meter width, another is 1.250 meter and
and one is 1.35 meter means. By the help of this single strand reversing mill, we can produce thin and ultra thin material while agenda is gauge effect. Second, we need gauge control basics and flatness control basics. Basically, जो frictional compressive states only elastic flow affects regulator from okay. Gauge effects, control basics, and flatness control basics. Frictional compressive stress opposing plastic flow affects a greater portion of the thickness. Thus, more of the rolling load is required to overcome friction, giving distinctive frictional hill for thin material. When the strip is thin enough, when the strip is thin enough, the rolls can touch outside the strip with roll flat, roll bending. This is known as closed gap rolling. Closed gap starts somewhere between 580 500 to 18 microns. Depends on the mill design. Gauge control is closed gap rolling trends. Pressure control gap control.
हाँ खोल लो बिट्टू कैमरा दे देना पूरे लिए
What is the primary difference between thin and ultra thin? We are considering as 500 to 200 microns is considered as a thin and 200 to 80 macros that can be produced that is considered as ultra thin or low carbon steel.
चलो कौन सी चलेगी लाइट चलेगी ना खाली बस प्रीवेडिंग
Size,
खाली प्रीवेडिंग तो
double rolling, vertical diameter, roll
आएगा
roughness.
पेन ड्राइव में खाली प्रीवेडिंग पेन ड्राइव रेडी रखो ना बाकी तो काम कर हेलो तो दो को पेन ड्राइव रेडी कर ठीक है कम होगा आ ओकरा में कोई फाइल मत डाल प्रीवेडिंग स्लाइड्स
Roll by this is the
देख लीजिए ठीक है
input the the fact and in the neutral point neutral point especially at the neutral point where the strip speed and the roll speeds are become equal that point is neutral point. Thinner gauge rolling practices, each mill has its own rigidity, bearing types, width, roll size, and it's still likely to respond differently from other mills. Quality requirement also vary. Therefore, while the same basic principle of thin gauge rolling apply to all the practices must be adjusted to suit local conditions. The operating parameter which have a major influence on quality, productivity, and recovery can be discussed under two broad categories. Fixed parameter, those which cannot be changed during operation. Variable parameters, those which can be changed by the operator during rolling. The, the friction hill is standard. Fixed parameter, The rolling load must overcome three components. First, ठीक है. The loading load must overcome three components: yield strength of the input material, work roll hardening of the input metal, and friction. Factors that affect the magnitude of the load include yield strength of the input metal, amount of work hardening of the input metal, percentage reduction, draft, input minus output thickness, coolant lubricity, friction between the rolls and the strip, coolant lubricity, work roll finish, entry and exit tension, roll flattening.
Only one hand help me conclude.
These are the rolling passes, full rolling 65 to 85%. Reset operating parameters, roll ground on camber, and roll lubricant formula. Variable operating parameter, roll pressure, roll lubricant volume, temperature, and pressure. Strip tension, work roll bending. There is a word forward slip is the percent difference between the work rolls and circumferential speed versus the strip adjusting speed. Value as high as 40% in light with rolling. In a strip rolling, the speed has strong effect on friction, increasing speed draw more lubricant into the roll bite, decreases friction, decreasing friction lower the height of friction is so reduces gauge. Importance of flatness in logging. If the tension in the strip is only carried by the flat portion across the width, loose areas do not carry tension unless the tight areas are still. Wood flatness is very critical for beam pipe. Getting better flatness in the file, digital and non-wedge profile, can be very better. Flatness in file, that was the stop profile compared to the new methods. Yeah. Okay. Thank you. If you next time.
इसमें change किए
Yes. हाँ हाँ रोलिंग डिफरेंस है जो हम लोग जो .50 जो रोलिंग कर रहे हैं .50 से लेकर के .20 थिकनेस तक जो है वो हम लोगों का थीम के कैटेगरी में आता है
वो समझ गया आप रोलिंग में क्या डिफरेंस करते हो ओवरकम दिस टाइमिंग एंड फ्रिक्शन को
या
वो खाली पॉइंट
यस उसमें ये है सर हम लोगों का जो सीखा है रिवर्सिंग मिल में जो स्पीड जो है सबसे मेजर है 1400 एमपीएम का स्पीड है और जब हाई स्पीड में हम चलाते हैं तो उसके साथ जो
A very good morning to everybody. I am Sagar Dwar and I represent Bhilai Steel Plant, Universal Rail Mill. And I am very proud to say that I make rails for my country. Today's topic for presentation would be rolling world's longest rail. Why is rolling world's longest rail so important? Why is length of the rail so important that we have stressed it so much that rolling world's longest rail is what we have taken as a project? We will see as the presentation proceeds. Contents of the presentation would include a brief introduction of SAIL Bhilai Steel Plant, Universal Rail Mill. We will see some of the performance figures of where the rail is produced. Along with the rail rolling process flow, we will look at some of the challenges that we are facing right now and solutions that we have come to face to overcome the challenges. Also, we will discuss few of the topics that we have taken as a project for way forward. Steel Authority of India Limited, as we all know, has a legacy of almost 70 years with in-house R&D, strategically located steel plant and a very diversified product mix. We have placed ourselves as market leader for almost 70 years now. And February especially marks a very special day for SAIL because 66 years before hot metal tapping started in Bhilai Steel Plant, 66 years ago. Of the various steel plants that we have 5 integrated steel plants, 3 special steel plants. We have a research and development for Center for Steel and Center for Engineering and Technology. Apart from making steel, we have always been giving back to the society in terms of corporate social responsibility, and in last 10 years, almost 600 plus crores have been invested into giving back to the society, of which almost 130 crores have been given in the last financial year itself. Coming to the unit of coal, where more profit can be there. Without steel plant, we have India's three producer and a party award for world's largest producer and the supplier of coal. Apart from one side, winner of coal, PM profit for best. In fact, we are having wide range of products as well from this age of 25 important to the sector. Every you all you the training, help in making rates for the nation. You are great. You are the training goal itself of producing rails of 130 meters plus. With a weight of 1.2 million also have capacity. Different types of rails we have sold so far, and currently there is production of rail that is called Piece 1. Apart from that, we have also released another rails for the nation of safety. In the last decade of coaching, Suvarna have started its provision. We have 20% plus with the line. We have practiced in line. In terms of quality, also they have seen very good improvement. They are working day in, day out to give them kind of very quality to the nation. Yeah. So if we are speaking of holding chocolate trade, our current 130 meters. 130 meters plus is considered to be the longest train in the world. And that component, as you can see, has slowly increased. And today, it stands at around 4% traction. Only 75% it is correct for. Why? So that's actually important to produce. No, even the water is consumed. That is absolutely. Let us look at the flow of rail making. We received room from SMS that is but yes, the 35 years stop it. Calling around is starting to like capacity. And we are looking after 15 and 10 years old. Also operating country. Currency. We are talking about countries that we have used. Some of the best practices that follow and the key commissioning line. Like specific to street representation. So this is the calculation of free cash and it has in totality. So this is the overall layout of the plant. The plant is capable to hold 2.2 million tons of water times against 24 million water wells in the output is a large water.
Distributions is written over here. So we keep reaching the point that we have a meter base together to form a 2 meter base. Doing 130 meter base of that, whether it was we have heard the for maintaining the maintenance of the so it is capable to build advanced science and skills also. It is very low maintenance and environmental friendly. Next, we have a tensile length of 60 tons capacity potential brake, scale braking, so that space can be created for the fishing age. We have a four eye box in terms of 100 meter length. This is reachable size quickly, also capable for high silicon and liquid skills. Then we have a surface inspection system that I will be taking talking in subsequent slides. Next, we have a 5 stand 6 high universal ground with maximum force capacity of 3000 ton and maximum speed, rolling speed of 40 mpm. So before going into the speed breakage events, since the plant is relatively new and having started its production from April 2023, so there are certain challenges and learnings that I wanted to share, which we have experienced, and I am sure many of us would have gone through this commission journey, would have experienced at their site. Some of the practices can be implemented directly in other plants also. So first challenge is to have a zero incident. It is very important to have an incident-free commission for obvious reasons. Uh, for that, it is very important to ensure that the material construction is as per the protocols. We have a correct operating procedures, we have the action plan. The correct communication channels are established. Coordination within team is taken place, and last but not the least, we have a competent manpower. So, to ensure all these, we have a very systematic approach at Tata Steel to pre-startup safety. So, since commissioning happens at different stages, so there are three startup checklists available with us, which ensures that all these points are taken care at different stages. So we have one checklist which caters the trial from equipment level till whole trial, and then we have it is a brief checklist consisting of around 29 points and ranging consistent domains related to quality protocols, quality assurance. Then we have work permit, positive isolation, then we have a pre-startup safety review. We call it process PSSR for the hot trial, which is a very exhaustive list consisting of around 110 points. So I'm happy to announce that we had zero incident at our site during the commissioning of PLDC and also around 110 PSSR approvals we had to take during this commissioning journey. Next is having a competent manpower, which is most crucial to success of any commission. So we had a very unique challenge because most of our employees were freshers, and since there was limitation on interaction during COVID, we had a it was a challenge for competency building. So we used that time to ensure or to rather build strong theoretical background among the operators. Every operators have the knowledge of how part of the operation. We use the time to make them understand why part of the operations. Next, we have next is very important to have a brake material. So for PLDSM, the most important consumable is roll coolant, which impacts the rolling and also product quality. So we had options from various suppliers and also types of roll coolant oil. The slide is not changing. So what we did is we had taken help from our research and development team. They studied on all the roll coolant. They studied on various performance and parameters, and then only after their approval, we selected based on the performance and the results. So I think same can be applicable to other consumables which are critical to quality and process. In fact, are moving forward with the weight and taking it outside. If you're normal cutting side. So, coming to the street breaking events, I think the worst which can happen in any plant is forward or street breakers. So, it is very important to get to the root cause, take action, and prevent recurrence of the event. So, this is overall trend chart of the breakages and fuels during commissioning. total 10 number of incidents happened, with a delay accounting to around 5,000 minutes. So we are very fortunate that since last April 2024, we have not faced any such events. But if I could summarize the root cause, so we had two due to because of the we didn't know the correct procedure. In two was correct procedure was not followed. We had one due to equipment failure, transformer failure, three due to logic issue, and two due to material design. Since the time is very limited, I would be touching upon only two cases. This high speed street is occurred in stand 4. So it was due to rolls fall. You can see from keypad trace that there was hunting in the roll force and the differential roll force. When we further investigated, we found that one of the nozzles, which is there for the cooling of IMR and backup roll, got clogged, which led to the overheating of the roll and then final solid. So when we searched for the source of the rubber material, we found that it was there from the heat exchanger, the plate type heat exchanger, which is there for the cooling of the roll coolant. Now, one more observation that we had, this type of wear and tear was only visible in the roll coolant inlet and outlet. It was not there in the water inlet and outlet, even though the material is same. So we had contacted the supplier. So they had taken sample from our plant, the whole coolant sample, and they have concluded that maybe it is because the coolant is not compatible with the type of rubber material which is used in the heat exchanger. So now the action we have taken is it is very important to check the compatibility of material with any media. We have removed the rubber clips in consequence to OEM. And also we have planned to replace the rubber clips in the next maintenance cycle. We have started the nozzle inspection during every roll change. If any nozzle is blocked, we get it clean and only then we start our production. One more interesting thing happened was that even though rolls fall occurred and there was hunting in the differential root cause, but operator did not react, even though the time was around 9 to 10 minutes during which this hunting occurred. So when we have developed this, we have developed a rolls fall detection system. It is a inbuilt detection system. What it does is, since the rolls fall will cause hunting in the force and differential root cause, based on the amplitude of the this hunting and also the frequency of the hunting. So since it would be it would happen at a fixed frequency. So based on frequency, the system will analyze data and let us know which role it is. If it is within 10 plus minus 10 plus 10 range of any role, it will generate an alarm to the system and operator will take further action. So this is the next page, which street break is occurred in stand one. During the commission, we have a cold trial phase and we have a hot trial phase. In cold trial, instead of AC, we fill 10 lakhs to water and we sterilize the rolling mill. Then in the hot trial, we do the clean and sterilize the mill. So there is a difference of around 20 to 25 days between these two trials. What happened was the speed break is ordered in the first trial itself, and that too in stand one, this is very abnormal. So when we checked the EBA trace and the condition of this tube, we could found that speed break was due to the high humidity. Now the reason is very interesting because the whole coolant was idle for around 20 to 25 days. So if the system is idle, it has a tendency to generate high bacterial growth. Now, to counter this bacterial growth, heat shock was given in the system. If you see the reaction, it is very susceptible to the temperature. The equilibrium part of the certification reaction is very susceptible to the temperature. So when heat shock was given, it created a reversible chain reaction basically. which led to the increase in carboxylic acid and the acid number increased drastically. One more thing happened during the time was that since magnetic separator was not okay, there was high iron fines in the system. So when these two, carboxylic acid and then iron fines are there in the system, they have tendency to form iron soap, which is relatively having high lubricity. So generally we maintain below 0.25% of iron soap, but the number went to around 0.91%, which is very high. And this was the reason of this speed breakage. Now, what actions we have taken is, since we are using cationic tank for roll coolant, it is very challenging to maintain the roll coolant parameter because of the higher number of start stop during commissioning. So the key thing that we do is recirculation once a day. It is very important to not let the bacterial growth in any part of the roll coolant system. And also we have fine tuned the parameters such as temperature, pH, conductivity, iron, and all. One of the most important parameters that we have tuned is the cycle time of magnetic separator. This is very important because iron fines and pH has very much role to control the ESI of this cationic type roll coolant, which can further impact the rolling. So the key learning is that during commissioning, if there is cationic oil in the system, it is very much susceptible to parameters getting out of limit. So it is very important to maintain the parental within specific limit that can be done daily management practices. So daily management practices should be very effective in maintaining this organic type of growth. Next. So these are some of the practices that we follow where we use data and analytics to make the operations effective and efficient. And also it is primarily it helps operator and making their life easier. So the first one is surface inspection system. So we have high definition cameras along with the analytics. It is installed at the exit of the field. And so it is equivalent to continuously monitor district because of the high speed. So what it does is it automatically detect defects and classify, which helps operator to make decisions. So you can see in the right part of the slides that lamination, which is of high fidelity. So operator will either stop, slow down, or pass based on the simulation. And since we have multiple SIH as different locations, which can compare with each other, so that the database can be created, which can be useful for the analysis. Next, we have a path management. So the roles which are in direct touch with the strip are very critical to quality because we have to maintain the condition. Otherwise, many defects will get generated from the system. So generally, during the audit, what we do is we go to the site, we take photograph, and then come back to the system and maintain an Excel and take action. Basically, take action after that. So the system is basically accessible through both system and this mobile. And some of the advantages of this system is that in case of any high severity deviation, this will give auto trigger to the O&M team for quick action, auto report generation and circulation to all concerned. And also we can sort role wise, zone wise, if you want to track the journey of any role, how it has deteriorated or the condition has changed over time. The next we have is intelligent quality management system. So it is very important to control the process parameter within specification if you want to have a defect-free products. So this is a kind of a system-based daily management practice for quality control. So we have selected around 30 plus critical parameters across the line. And what it does is we have defined specification limit for all the parameters. And in case any parameter gets beyond specification limit, it auto triggers alarm to the concerned person so that timely action can be taken and any deviation accounting to deviation in the process parameter can be avoided. This is all that I wanted to share. If anyone has any query, please let me know. Thank you. Thank you. Thank you. Using data analytics and case system. We have questions from audience.
I have a two or three types of questions. First one is you have you do the inspection. It's a nozzle. nozzle or fish diameter?
We just spray the roll coolant and check whichever nozzle is clogged, and then we either do the coating or remove the clogged material.
Okay, and another, you have developed a system for the roll detection, spot detection system.
Yes.
What is the basic, fundamental or principle of that system?
So whenever there is roll spot, it will have a cyclical kind of curve, either in the differential tension, roll force, or differential roll force. So we have all the data through EBA.
Okay.
So the system continuously gets the data from the EBA and monitors the cyclical, if any cyclical nature is there in the system. And it matches, if there is any frequency, first of all match with the current roll diameter. And if it is within the 10 plus or minus 10 range of the current dia, it triggers an alarm to the operator that one of your roll is going to fail or fail. So that the speed breakage event can be avoided.
That can be correlate with the insensitivity of the row. Maybe the row is insensitivity and the diameter will oversee, and that can create a say weakness.
But it will not there for every roll. No? The roll eccentricity control we have in the stand one. That is a different thing. But for spoilage, there would be like hunting, abnormal hunting in terms of amplitude. You can see in the chart also.
Hunting of differential tension.
Anything, either differential tension, roll force, or differential roll force, anything can happen.
Sir, I want to ask one thing that in every shift, how much street breakages you are facing nowadays?
We have not faced street breakage since last April 24. So it was there during commissioning because most of the parameters are not stabilized. But hopefully, fortunately, we have not faced since April 2024.
Not a single street break.
No.
Okay. And one more thing, maximum reduction percentage you are gaining.
So for commercial quality grades, we can achieve a reduction of around 78-80%. We have tried till 82% also.
And reduction in the same time, how much reduction percentage?
75 if it is dull mode, then reduction is not there. It is only for the roughness transfer from the rolls to the street. But if it is in bright mode, the reduction is around 15 to 70%. So the roll force is around 700 to 800 tons for the bright roll mode. Rolling.
And defects you are क्या क्या डिफेक्ट्स आपको वहां पे भी पाते हैं अपने मील में?
जैसे सर ने बताया था अभी रिपल के बारे में, तो whenever we roll let's say 0.4 and 0.3 mm of sheets, bright rolling or dull rolling, we have a ripple at the drive side of the mill. That is not visible in the shape meter graph, but it can be seen through the camera. So operator, instead of checking the shape meter roll, he visualizes and sees the actual rolling and then take action. Thickness gauge and shape meter we have not much complaint. In DP steels, it is little bit difficult to control the shape. That we are still stabilizing, but in other grades, we have not faced any such problem.
रिपल्स को कैसे कंट्रोल करते हैं जब आपके ऑपरेटर्स देखते हैं कैमरास में? तो
so drive side अगर रिपल आ रहा है तो operator will do the leveling. So we have a provision of leveling, controlling the whichever high rope is going to basically कौन से राइट साइड और लेफ्ट साइड से अगर रिपल आता है तो उसके अपोजिट साइड से हम लोग लेवलिंग देता है ताकि वो गैप और खोल सके. रिपल इज बिकॉज एक्स्ट्रा रोलिंग हो रहा है, उस एक्स्ट्रा रोलिंग को हटाने के लिए वी नीड टू ओपन द गैप.
एसपीएम में कभी हम बनता हुआ दिखता है क्या आपके जब ये फर्दर प्रोसेसिंग में आगे जाता है एसपीएम में?
तो एक्चुअली कैल इज जस्ट कमीशन इन दिसंबर, सो आई विल नॉट बी एबल टू कमेंट ऑन दैट. बट अभी तक ऐसा कंप्लेन नहीं आया. Whatever we have rolled till now, we have not received any complaint of any harm. So all these 0.4 and 0.3 we send it to our Angul plant. So maybe once in a month or twice in a month we get a complaint of this ripple type of defect.
के लाइन में तो शायद लिमिट हो जा रहा होगा, लेकिन एसपीएम में हमको दिखता है कस्टमर कंप्लेन नहीं कर पाता क्योंकि उसको हम पे दिखता है, लेकिन ये जो बिजनेस का कंप्लेन कई कुछ कस्टमर्स करते हैं हमारे.
Okay.
काफी कम स्लाइड है।
फॉर्चुनेटली हम लोग को ऐसा अभी कंप्लेन आए हैं, सो वी हैव ओनली रिसीव्ड कंप्लेन फॉर आवर अंगूर यूनिट व्हिच इज रिगार्डिंग रिकॉल. So we roll around maybe say 15,000 tons of this thinner coils. Maybe in 1 2 coils we receive complaint from the owner. So okay.
Do you face emulsion leakages related issues in your stance? Because we have talked about bacterial growth, and about bacterial growth, apart from temperature, what other measures you take?
Bacteria will grow. We have a catalytic type of growth rate. Okay. So it is very unstable. Whenever there is no agitation in the system, the oil and water will separate, and the oil will have tendency to form bacterial growth. The most important thing to avoid this is, even though we have shut down in the plant, we do the circulation at least once a day. Avoid that the idle roll coolant having idle in the system. So the most important thing is having circulation once a day at least. This is what we have learned, and fortunately, this problem is not reoccurred since last, I would say, 1.5 years.
Okay, but same thing is here also. We are facing too much emulsion leakage to large extent. So, do you comment on that? How to
Emulsion leakage, we are not facing much to it. Maybe you need to see or review your maintenance practices, how frequently you monitor the gaskets and all.
What is the average rolling hours you get? Average rolling hours in a stable plant.
We have not the full production because our downstream lines are not ready. This line is ready to roll around 180,000 tons of production per month. But maximum we have gone only to 65,000. So implementing all that will take a lot of time. But whenever, out of 30 days, we are able to complete this 60 or 65 tons in mostly 8 to 10 days. The rest of the time we are able to.
So the plant is not now 100% in load.
No, because we are waiting for the downstream. CAL and CGL are yet to be commissioned. CAL is commissioned just in December. And the CGL, we are expecting it to be commissioned in maybe September, October this year. So once these two lines are stable, then we will be getting opportunity to get to the maximum.
Okay.
Excuse me. I have one question here. Here.
Yeah.
Yeah. See, you mentioned about the surface inspection system.
Yeah.
My question is, it might have already pre-ordered with certain defects library, right? Do you have a provision to add new defects in the library? Do you have?
Yes.
So that
So every once a while, so we have an operator who is dedicatedly placed for this particular job only. So he inspect each and every defect of each coil. And whenever certain new types of defects arises, based on his experience or based on discussion within our team, we classify that defect and that gets into the master set of samples, which is then used to classify and identify next set of defects.
So this system has come along with the main itself.
Yeah.
Who is the manufacturer? Who is the OEM?
It is partially from Germany.
That's good. Thank you.
So it is around. It takes around 2 to 3 years to build a defect library. It's been 1.5 years, and also when we get to the like maximum throughput, then we will be able to make it library. But it has
Keep on listening from my boss. So what do you do to have so much better result in yield, especially your optimization, how you do it, optimization, how you cut, how much length you cut in your shear? Can you give some information on that?
Yes, sir. From last 3 to 4 months, we are facing lots of problems to get the desired yield. Due to, as I am already saying that after 2018 and 20, alloy steel rolling is much higher. Grade mix alloy steel rolling is much higher. So that we are facing lots of problem in due to defect lab defect. We are facing lots of problem in CHQ grades, especially borons, SAE 4140, SAE 5140. For fastener grades, we are facing lots of problem due to lab. So slowly we are on the way to eliminate these defects. Like in 14 mm, we are facing lots of problem due to lap. So we have changed the stock size in 14 mm, and now the lap defect is totally removed from 14 mm, and same as for 6.35 mm. So also we have
Point kind of it. How does it give you effect of this your load changing? How can that
So all the holes are in directly contact with each other and also they switch. So whenever there is a gap, so at that point of time there will not be a transfer from high rope to the string. So the abnormal data of roll force is there at particular point of time.
So how can you detect that it's a point contact or a point load?
So it is there for the range of time. So
You have a load sensor and then a sensor at the edge.
yes.
Then how can you just suppose it's in the center or in the somewhere down the edge? So how do you detect that part? You know, it's not here. You know how it's on.
Guide or 4 roll guides?
double roll guides.
Okay.
Sir, I have seen that you have having garret facility.
Yes.
That is from which size to which size?
20 mm to 25.4 mm.
Okay. Actually, in RINL also we are having garret. Means in that drum, some marks are formed. For you also, those marks are coming.
Yes, sir. Last year we have lots of rejections across approx 400 to 500 metric ton due to scratch marks in garret route. So slowly we have put some double roller guides or triple roller guides in the garret route line, and now from last 4 to 5 campaign from the month of January we have a zero rejection in scratches.
No, that guide name inside the drum some marks are formed or not?
No. We have not get any marks from inside of the drum.
Is in that stiffeners are there? Sometimes marks are formed.
No, sir. We are not getting any marks from the drum.
Thank you.
You need to stop the mill, you need to inspect, or if the don't come through, then you will.
Excuse me, sir, we can have discussion in the lunch. Actually, we have only two positions here, and four are there.
So we can talk to it.
Yes.
Thank you.
Thank you. May I call Mr. Pankaj Singh from GS Division. He will be giving presentation on distillation in cold rolling mill.
And we don't have anything of it. Contribute circuits and maybe my name is Pankaj I'm from Vijayanagar, KSWC, and I'm going to present the distillation in CRM because we have two units of CRM. One capacity of 1.9 million ton, and second one is 2.3 million. I am basically drawing from CRM, that's why I'm going to present distillation CRM. We don't have a specific of water. This is the index. Our presentation will start with the Vijayanagar Ministry and the detailed water presentation, and the third one is the time to end slide. We will talk about the digitalization and third the base cases in the CRM. In fact, looking the challenge in Vijayanagar location, we develop a integrated plant with the eco-friendly India's largest steel plant. This is the material flow from raw material to final product of the cell. So all are same quantities, so no need to explain each and every unit because we know that what is the iron ore and the coal rolling or media. We have a wide range variety of product, and that's why JSW is calling it a one-stop solution for the automated product. We are supplying the 980, 1180, DK, stores, and non silicon, steel, geo, non-geo, everything we can supply from the design units. Details about the presentation, digitalization. Digitalization is the leveraging the technology to enhance the efficiency, productivity, and the customer satisfaction. Basically, we are dividing digitalization into three categories. First one is digitalization. Before going to the digitalization, we understood the word.
Automation हो रहा था और जब हम लोगों ने वो चिप्स का माउंट बनाया था तो हम लोगों को वो लैब दिख रहा था. डेट मीन्स कि और वो लैब का डेप्थ देख के हम लोगों को पता चल रहा था कि ये इनसाइड द एनटीएम है. तो अगर कॉइल्स के बीच बीच में लैब बन रहा है, डेट मीन्स देयर इज अ फ्लैटरिंग इन एनटीएम, इनसाइड एनटीएम. तो जब वो फ्लैटरिंग, जैसा कि आप वो सैंपल्स में देख रहे थे, जहाँ भी वो वैसा वैसा ओवर प्लिंस बन रहा होगा, वहाँ वहाँ पे वो फोल्ड होके चिप्स जनरेट कर रहा होगा। तो सो डैट हम लोग इसको इम्प्लीमेंट किए थे एंड द रिजल्ट वाज वेरी गुड ऑन दैट स्पेशल ग्रेड।
और ये रोल आपका ड्रिवन रोल है या स्टेशनरी रोल है? ये
स्टेशनरी है, वो मेटल के साथ ड्रिवन होता है।
Thank you, Mr. Kumar, once again. Now we'll have a next presentation from SAIL-ISP by Mr. Shiv Kumar on the increasing TC ring life in BR.
शिव कुमार, मैं R&D मिल स्टील प्लांट में लोकेशन के साइड से। हम लोगों ने एक मॉडिफिकेशन किया था, हमारा रिंग बहुत ज़्यादा क्रैक हो रहा था, स्पेशली ड्यूरिंग रोलिंग 16 mm to 20 16 mm and 20 mm. So we modified branding scheme of our TMT. This project is all about that. Brief जानकारी है कि during 7 MT Modex expansion ये लगा था and executed by Daniel. We have some different profiles. This is simple layout. We have single furnace, then we have descaler, and we are facing problem in descaler also. We have 3 sections: roughing mill, intermediate mill, and finishing mill, and then it gets divided into 2 lines. Central line is we use for more than 25 section. Normally we do roll in the lateral line. We have a 6-pass BGB and then all pinching arrangement, then dog house, then tail tracker, double twin channel, cooling bed, and then it goes to our bundling area. This is some technical parameters. This is production graph. We started our mill in 1890, and our time we have now we have surpassed our rated capacity. Presently it is around 0.97. Our rated capacity is 0.9 million ton. We have exceeded this in last year. This is our defects rejection. This is our yield, and this is month of this final. We have these grades. We have facility to produce 8 mm to 60 mm, but wire mill has been decommissioned. Now we are using only lateral line. We take pride in providing a steel in all these plant projects. Our problem is currently our plant is we put sale TMP, then product make mechanical quality, license number, and trade. We put all those things on our. Due to this, in 16 mm and 20 mm, 16 mm and 20 mm, we gets broken ring like this. And usually during 3 shift operation, one time it gets broken. And every time it gets broken, around 2 hour delay, 2 hour mill downtime. These are the cracks generated. So we did analysis on that, and this is our branding pattern. We found wherever here, can you see airline mark here? जहाँ से भी ये टूट रहा था, वहाँ पे जहाँ पे ब्रांडिंग चालू हो रहा था, वहीं से ये टूट रहा था. वहाँ से क्रैक जनरेट होता था, it gets propagated to collar, and over time gets broken. So this is our CNC program. We use this program later. Our branding arrangement is
change that. So the downtime reduction and enhance the life of that equipment. In CAL and CGL, because the material after PLSM goes to the CAL and CGL, we have a 2 unit of CAL which have a capacity of 0.95 million ton. CAL is a continuous handling line, and the one is a CGL, and then we can produce a GA, GI both product, and the capacity of CGL line is 0.4 million ton.
The CG Caroline, we develop a system dashboard, energy dashboard system where we have a system which collects the each and every parameter of the power and the system we can analyze. The third one is the dashboard for the CRM to develop Power BI and it's a user friendly and free of course. Which also we have collected the each and every data because we mostly seamlessly we are working on the Excel sheet. And now we have a technology to adopt and convert in automatic accessing. So we have this kind of a system. And another is automatic robot. And the video analytics is nothing but the AI feature video analytics which captures the 50 with any violation. Smart access control, automatic for the barcode centralized monitoring system. Entire monitoring system is like now Carbon Chemical CGL have only one unit of maintenance team and they can't go every time to check each and every parameter. So we have developed a centralized kind of war room and the operator can sit there and he can monitor the each and every parameter of Carbon Chemical and CGL. And the smart notification system, now in busy life, everyone is working in the mobile phone. So we have developed a system to notify on a mobile phone regarding the line stoppage, product production, PPH, and the other critical parameters. So slide by slide, I'm going to one or two slides. So because this is the various. So here the sensor, vibration sensor kind of installation. Before we are going to measure the manually, now we have installed the system, and the system will gives a stored in a cloud. Cloud will analyze the system and send to notification to the operator to take a decision quickly. In CRF, we install 500 sensors, and the data is from 22 to 24, and we have saved 626 hours. So what is the benefit in this project is the easy to adopt and scale, the efficient projects and avoid unplanned downtime, improve MTTR, MTBF, and the faster ROE calculation, the return of investment, and enhance overall safety by mitigation and managing the fish. Till now we have installing 32 plants and 1400 around machine heat lines, 643 IoT based devices installed, report now is generated to 900 and report and the total hours we have checked in now is 3800 geosec. In the centralized monitoring system, we have a carbon system and serum to now we have before it was a decentralized control system, lack of coordination and the delay in response time. So now we develop a system to control in a single room. Power BI, before we collect the data from images and doing an excessive job. Now the system, Power BI system is installed. It's a free of cost and develop interactive report to understand easily. You can see such type of report we are developing on a daily basis. Automatic barcode scan system is a video, small video to understand how it's working. In this video, small sound.
Now, this is the before condition where the person used to scan the barcode manually. Now, this is automatic barcode scanner. When the cloud places a point in the station, the barcode scanner will get a trigger and it will automatically start scanning the barcode. Completion of the scanning is indicated by green lamp. Now the coin is ready for dispatch.
Similar kind of bar experiment system we have installing each and every gate of inspection, like after PLDCM, after CAL, after CGL, after packing and the dispatch. Now another video we are going to play here is a smart
which optimizes productivity, safety, and quality. Let's quickly control bicycles and incidents. It's about an innovative solution for trying to ensure that every worker is accurate, necessary personal and technical. What sets the industrial AIoT system apart is its real-time monitoring capability. With features like PPE detection, to recognize the presence of essential PPE, detection of unauthorized entry, that's access control through geofencing, like violation of designated walkways, crossing vehicle pathways, or railway tracks. For white use violation, by people at danger zones, people counting and entry and exit at designated areas, local alert to orders to avert potential accidents during vehicle crossing. The system provides instant alerts to supervisors, like local alerts to store, alert to command control station, and email alert to area in charge, allowing for immediate intervention. So the intervention system, yes, automated reaction, workplace incidents, and injuries. The generated reports provide us with a comprehensive overview of safety compliance within our facilities. The system's advanced analytics allow us to observe trends over time, identifying areas of improvement in performance. This real-time data empowers the safety officers to make informed decisions for you. Industrial AI working solutions in place. We are not just meeting industry standards, we are setting new benchmarks for working safety. JSWC, better safety, better every day.
The next project, like theme lubrications, is already discussed about that. And another is the road consolidation system. This is the step diagram of road filling system. We have a two tank one and tank three. Tank two is only maintained for missing pipe and one is for banking fluid. So we install up to sensors to control the same what the actually display in a local panel, then PLC. PLC will control the actuator to add oil and water. Now, this much saving we have made from this. It's a mobile notification. Robots, logs, energy dashboard. Energy dashboard is nothing but all energy is controlled in one panel. So this is the project. This is the end of slide, and the world is moving toward the digitalizing. To meet the Indian revolution, we have to start thinking innovation. Start with the digitalization. The industry is around the 40% we are using digitalization.
Thank you, Mr. Kapoor, for sharing your various initiatives in digital transformations to your code. Thank you.
Thank you so
Any
much.
questions from audience?
Yes. To avoid the big problems. Because when the system is give the reports, this equipment is going to break down. So you got cut off and change that equipment. If it not, then that will convert to the breakdown. The PLL, PLL, road breakdown or the clear failure. There is a major CD, another is the team with the system. And the third one is the Bidal 6. How Bidal 6? Is because Bidal 6 is rotating the motor, the gearbox. We have installed the sensor on the gearbox in the motor. And to clear the data. Yes, absolutely.
Okay, thank you. Now,
Who was implementation partner for that PP monitoring system?
not recall the name of that. Because we can find the in number of AI-based camera, and all AI-based camera can do this job. No, Mr. Engage service, isn't it? Yeah, yeah. I'm not recall that. Okay, inside, right? I will.
Okay, now we move to Mr. Prashant or DSO Gandhi. He will be giving presentation auto dual tension strategy to avoid risk making in auto system.
So the first slide is regarding the process flow diagram. First, we'll start with the reheating furnace. So reheating furnace is of 5 France, having a capacity of 450 tons each furnace, and it is having a roughing mill, 4 high, and 7 finishing mill stands. And in finishing mill 1 to 4, it is having a pair cross, and 5, 6, 7, it is having a cylindrical. And coiler, we are having 3 coilers. Go to the next slide. So the major issue which we are facing is the wet making in IF rate. So after checking all the parameters, the measuring instrument was is IM, integrated measuring system that is from Germany. So in the gauge, no wet making was observed. After physical inspection, it was found that after 122, in between 120 to 150 meters, making of about 5 to 8 mm has been observed at after completing the coiling. So the next, after checking the gauge and calibration, we found that there was no error or any something fault in the weight gauge. And in consumer side, we got the customer complaint also that around 5 to 8 mm netting was there after 120 meters. So after seeing, we have go to the next slide. So main thing was that weight making cannot be monitored online as there was no weight measuring device at the town coiler site. So after that we reduced the mandrel tension. But even after that, after reducing the mandrel tension, also the necking was around 4 mm, 5 mm like that. So one logic has been implemented. In the total 3 coilers are there. When the strip head end used to reach the DC1 guide, where one HMD is there, laser 501. So once the strip head end used to reach the laser 500, the mandrel tension from 100% it drops down to 70%. And when the strip head reaches the mandrel, and when tension bit is created, again gradually the tension used to increase from 70 to 100. And the time difference, the time which is taking is around 6.3 to 6.5 seconds period is there. So after that, after implementing this dual tension strategy, the necking which was previously it was around 5 to 8 mm, and after implementing this around 1 mm like that necking has been observed. So this is the modification which we done in the HSM2 sites. And go to the last, yeah. And in the bottom you can see that the dual tension from level 2 itself, when the IF grade used to come, the dual tension
that display is there on off, and the operator can see that it has been the dual tension strategy is on. So after that, the customer complaint also regarding this IE upgrade, we have no customer complaints and quality was also nice. That's all.
Okay, thank you. Any questions from the audience?
Oh yeah, IE only. Yeah. Same.
Hello, I have a question. What was exact tension value before and after? The percentage is clear. How much was the manual tension? The value in the tension.
Manual tension.
Value.
Value was around for maximum we used to roll 3 mm sensor. So manual tension was around 16.
How much it was relieved after this? This is only implemented in IF.
Only in IF only.
Yeah.
Only in IF we are facing the problem.
So how much was before? How much was the tension before and after? At the head end, the manual tension value. How much?
From 16. From suppose we consider 16 Newton per atmosphere as 100%, it will drop to 70% from 100 to 70. And again, when the mantle when wrap is there, when tension bit generates, then it will gradually increase and hit to 100.
So in I upgrade all sections.
Yeah. I upgrade all systems.
Thank you.
Thank you, sir. I would like to call Mr. Jitendra.
Thank you.
Thank you for your evening guidance. Now I would like to call Mr. Jitendra Kumar from SAIL-ISP.
ये वर्क भी कर रहा है क्या?
Okay, you can start.
Okay, thank you. Good morning, everyone. Today I will be presenting on the upgradation of the DCR mill products, focusing on how we improve quality, efficiency, and market competitiveness. This presentation will cover the current challenges, proposed improvements, and the monetary benefits of the upgradation. We have primarily improved quality and reclassify our steel grade, and hence we are generating additional revenue without investing without capital investment. Right now, we are generating approximately 1600 per ton of the pig, and annually it becomes approx 7 to 8 crores. So this is the background of the presentation. Now I am moving to my slides. We have DCR mill in Bogaro Steel Plant, where coils are received passed by four high thin stand rolls to impart the desired mechanical properties on the steel. Here we process coils within thickness 0.35 to 0.80 mm and width 876 to 1000 mm. Before processing in DCR, while coils are passed in care line, that is continuous cleaning and annealing line. This is divided, continuous cleaning line is divided into three zones. That is alkali dunk tank for degreasing the coils, electrolytic cleaning tank for cleaning, and spray rinsing tank respectively. This cleaning line increases of brightness, and when we did reflectance test, our coils are getting results in within 96, 97, 99% reflectance. After cleaning line, coils will go in any section. There are three sections: heating section, cooling zone, soaking zone, and cooling zone. In heating section, we raise the sleep temperature to modify its microstructure. In soaking, we raise the temperature to approximately 750 degrees Celsius to achieve uniform mechanical property. In soaking zone, gradually reduces the temperature to prevent defects and improve surface finish. Through continuous process, product quality is much better with homogeneous properties, mainly mechanical property, along with better age. That here we can avoid age luminous. And अर्लियर भी हम डिस्कस कर रहे थे फर्स्ट स्लाइड में कि यहाँ पे हम लोग प्रोसेस करते हैं 0.3, 0.4 टू 0.6, 0.7 और इसमें एज वेरिएंस का कंप्लेन ज्यादा आता है, लेकिन हमारे स्केल रूट का फायदा ये है कि यहाँ पे एज वेरिएंस काफी हद तक एलिमिनेट हो जाता है. सो इसका बेनिफिट हमारा ये है. इसमें हमारे चैलेंजेस ये था कि पीसीआर मिल में जो हम प्रोडक्ट यूज कर रहे हैं उसमें रिफ्लेक्टेंस हमारा एसपीएम से बेहतर था. एसपीएम का रिफ्लेक्टेंस जनरली 85 टू 95%, 98% तक था, जबकि इस मिल का रिफ्लेक्टेंस वैल्यू हम फर्दर देख सकते हैं कि 95.8 से 99.7% में रेंज किया है. डिफरेंट डेट्स पे हमने मल्टीपल पल्स टेस्ट किया. केमिस्ट्री हमारा काफी अच्छा था. सीआर2 के रेंज में कार्बन इन द रेंज ऑफ 050 टू 080, मैग्नीज 0.15 टू 0.28. लेकिन चैलेंज हमारे लिए ये था कि इसको हम लोग सीआर1 ग्रेड में पास कर रहे थे. हम जब हमने टेस्ट करके समझा कि हम इसको इंप्रूव कर सकते हैं सीआर2 ग्रेड में और हम लोग एडिशनल रेवेन्यू जनरेट कर सकते हैं. तो हम लोग इनिशिएटिव लिए कि रिफ्लेक्टेंस टेस्ट, मैग्नेटिक टेस्ट एंड फॉलो अप विद द सॉफ्ट. रिफ्लेक्टेंस टेस्ट assess the brightness, mechanical test to ensure hardness, strength and elongation. मैकेनिकल टेस्ट में हमने पाया कि CR2 ग्रेड के लिए हमारा 240 से बिलो होना चाहिए था YS एंड UTS शुड बी बिलो 370 MPa. लेकिन हमारा जो रेंज कर रहा था उस वक्त 253 टू 283 YS एंड UTS 375 टू 420. तो हम लोग इसको CR2 में पास नहीं कर पा रहे थे. हम लोग इसमें एक इंप्रूवमेंट किया. फर्नेस के टेम्परेचर्स को हमने इंक्रीज किया. हम लोग देख सकते हैं कि हमारे पास 3 सेक्शन है: हीटिंग जोन, सोकिंग जोन एंड कूलिंग जोन. हीटिंग जोन कंसिस्ट ऑफ जोन 1, 2 एंड 3, जहां पे टेम्परेचर हमारा इस मॉडिफिकेशन से पहले 500 के रेंज में था. 500, 550 के रेंज में. हमने उसको 620 के रेंज में लेके गया. जोन 1, 2 एंड 3 का टेम्परेचर. सोकिंग टेम्परेचर जोन 4, 5 एंड 6 में जो इलेक्ट्रिकल हीटिंग इक्विपमेंट्स बेस्ड है उसको हमने 750 के रेंज, लगभग 750 के रेंज में लेके गया, जो कि प्रायरली 720 के रेंज में था. उसके बाद हमने इंप्रूवमेंट पाया. एक इंप्रूवमेंट, ये इंटरमीडिएट इंप्रूवमेंट था जिसमें हमने 16 कॉइल टेस्ट किए, जिसमें 6 कॉइल्स हमारे CR2 के रेंज में आ गए. 10 कॉइल्स अभी बाकी थे. UPS हमारा अटेन कर चुका था. YS एंड इनोवेशंस में अभी भी प्रॉब्लम था. फर्दर हमने जोन का टेम्परेचर सेट किया. इसलिए आप देख सकते हैं जोन 1 में 495 टू 525 था. इस मॉडिफिकेशन के बाद हम 570 तक लेके गए. जोन 2 में 620 तक एंड जोन 3 में 640 के अराउंड. सोकिंग टेम्परेचर प्रीवियसली 740 के रेंज में था, जिसको सबको हमने 760, 770 के रेंज में लेके गया. एंड हमने पाया कि हमारा फिर हमने 16 स्क्वायर टेप्स किए और सारे का इनोवेशन में काफी इम्प्रूवमेंट था। 40% तक की इनोवेशन हमने पाया। यूटीएस वाईएस इनोवेशन सारे रेंज में थे। And after that, we reclassified this grade into slab from this financial year. And this is the important slide of this presentation that monetary benefit in this financial year. We already got extra money, 5.75 crore, without investment. And second, ये जो डायरेक्ट बेनिफिट है, इनडायरेक्ट बेनिफिट हमारा ये हुआ टेम्परेचर चेंज करने से हमने स्पीड बढ़ा पाया अपना क्या लाइन का। तो आप देख सकते हैं कि प्रोडक्शन जो हमारा 2022-23 में 30,000 के रेंज में था, 23-24 में भी 30 के रेंज में था। इस बार जनवरी तक हमने 36,000 टन बना लिया है और एक्सपेक्टेड है 43-44% तक इस इनिशियल में हम कर लेंगे। तो ये इनडायरेक्ट बेनिफिट है जो हम प्रोडक्शन बढ़ा लिए, टेम्परेचर एडजस्टमेंट से स्पीड बढ़ाए, एंड दिस इज द डायरेक्ट बेनिफिट in the form of monitoring. Thank you.
One questions. Okay. Thank you. May I call Mr. S.K. Swami from SAIL-ISP? He will be giving presentation on elimination the delay due to the true roll gearbox bridge failure at training RSP. Try to be as fast as possible.
सर हमने आरएसपी से ग्रेडिंग से हमारा तरीके से तो हमारा से वो एक लागत चाहिए इसकी पर कंपनी से टर्नओवर 1 लाख करोड़ से ज्यादा है। हमारा विजन है कि रेस्पेक्टेड वर्कर्स कॉर्पोरेशन डिलीवरी एजेंट्स बिजनेस क्वालिटी प्रोडक्टिविटी प्रॉफिटेबिलिटी एंड कस्टमर एक्सपेक्टेशन आरएसपी 65 करीब 65 ईयर ओल्ड प्लान है, जिसमें हमारा प्लेटमिल का प्रोडक्शन कैपेसिटी 4.5 मिलियन टन हॉट मेटल, 4.2 मिलियन टन क्रूड स्टील, 4.3 मिलियन टन सिल्वर स्टील। और आप टाइटल ऑफ केस स्टडी is a delay of control gear was reached so हमारा मटेरियल को स्लाइड देखते हैं। स्लाइड से स्लाइड पकड़ने से 1200 सेकंड में बंद होने के बाद ड्रिलिंग के लिए नींद आता है, हरकत से उसके बाद हरकत से रेगुलर प्रीवेट जैसे प्रोसेस से गुजरते हुए
डिस्कस के लिए चला जाता है, जिनसे मैंने से कस्टमर को रिक्वायरमेंट के हिसाब से हम लोग डिस्कस करते हैं। ये हमारा मील में हमारा एक प्रोसेस स्टार्ट है। हमारा जो मील है वो सबसे इम्पोर्टेंट पार्ट है, क्योंकि हमारे पास एक मील है जिसमें कोई भी कहीं भी प्रॉब्लम होने से हमारा पूरा प्रोडक्शन उसमें हार्मफुल होता है। तो हमारा मील 3.1 मीटर कोर है, रिवर्सिंग टाइप मील है, जिससे 3.4 मीटर कोर है, रिवर्सिंग टाइप मील है। तो यहाँ पर 12 हमारा मील में 12 ग्रुप रोल है, जो गियरबॉक्स 1 2 3 का माध्यम से कंट्रोल होती है। गियरबॉक्स 1 और 2 दोनों आप दो रोल को रिकॉर्डिंग 1 आइडियल रोल ऑपरेट करते हैं। गियरबॉक्स 3 डिलीवरी साइड में एक 4 रोल को ऑपरेट। हमारा जो ये जो मील है सबसे हमारा जो मील है वो ऑपरेट प्रेडिक्ट करने के लिए दो रोल का हेल्प लेना पड़ता है, तो यूज डायरेक्टली हमारा बढ़ता है, इसका आउटपुट देगा। उसका आउटपुट या असेंबली जो है वो कभी कभी ज्यादा स्पीड की है, जिससे करके वो कभी कभी पूरा गियर में इसका डैमेज भी होता है। ये हमारा प्रॉब्लम था। तो एजेंसी का जो रिलायबिलिटी को गूगल में रिलायबिलिटी को हमारा प्रोसेस को इंप्रूव करने के लिए उसका रिलायबिलिटी बढ़ाया हमारे लिए बहुत जरूरी था। तो भाई इसके चलते हमारे ऊपर क्या क्या इम्पैक्ट हो रहा था, हमारा प्रोडक्शन लॉस हो रहा था, लिक्विडिटी नीड इन्फ्लेशन को अच्छी मीटिंग करने का सबसे बड़ा है, बार बार प्रॉब्लम होने से इन्फ्लुएंस बड़ा पड़ा था। सर इस प्रॉब्लम को हम लोग एनालाइज किया। इसको एनालाइज करने के बाद हमको ये पता चला कि हमारा जो मीट है वो गूगल गियर बॉक्स है, उसका जो गियर फ्रेम है वो एक ग्रीस का ऊपर रेस्ट किया है, जिसको कंटिन्यूस लोड आने की वजह से उसका वो तीनों साइड में उसको स्ट्रांगली होल्डिंग किया गया है। बैक गियर का बीच में इसका नीचे में टिपिकल स्ट्रेस कंसोल कोई होल्डिंग पार्ट नहीं होता है, नहीं होता है। इसलिए आपको धीरे धीरे वो डिवाइस का जो वॉइस होल्डिंग उसको क्रैक करके वहां से डिस्प्लेस हो रहा था। उसके चलते हमारा पूरा गियर भी डैमेज कर रहा था। सर उसके बाद हम लोग प्लानिंग से हमारा डिले और 3 बार वो ऑकर हो रहा है, उसका ध्यान उसको डाटा को कलेक्ट किया। लास्ट ईयर 22-23 में हम लोगों का 2 बार होके 23 घंटे का मीटिंग हुआ था। प्लस लेकर हमने 18% हमको मीटिंग सुन लिया था। हमारा फाइनेंस लेने को लेकर तो 1 घंटा हम लोग को करीब करीब 5.1 लाख का लॉस हो जाएगा। तो 30 घंटा में हम लोगों का 118.19 लाख का लॉस हो रहा था। इसलिए हो सकता है कि इस प्रॉब्लम को हम लोग 100% एलिमिनेट करेंगे। रूट कॉज हम लोग को पता चलने के बाद हम लोग को उसको डेवलपमेंट सोल्यूशन के लिए उसको हमने क्या बहुत सारे सोल्यूशन हमारा आया। हम बहुत सारे सोल्यूशन 4 नंबर सोल्यूशन एक आया था हमारे पास कि हम लोग जो बीच का पर हम प्लेस करते हैं वो बीच को सिंगल पीस कर देने से हमारा प्रॉब्लम पूरा रोड वहां पर डिस्ट्रीब्यूट होगा, कोई प्रॉब्लम नहीं होगा। लेकिन वो हमारे हाथ में नहीं था, क्योंकि बाहर एजेंसी से एक्सटर्नल एजेंसी से उसको हेल्प लेना करना पड़ता है। तो 5 नंबर सोल्यूशन का हम लोगों ने डिस्कस किया। इसका जो रैकेट है उसका प्रोफाइल के हिसाब से दो 20 मिलीमीटर प्लेट को अगर उसको सेट करके उसको होल्डिंग कर देते हैं, तो वो जो बैक गियर का जो स्पॉट था वो प्रॉब्लम में सही हो जाएगा। और वो बैक गियर का उसमें कोई प्रॉब्लम नहीं आएगा। जितना रोड होगा उस हिसाब से उसको वो रोड वहाँ डिस्ट्रीब्यूट हो जाएगा। सर हमारा सोल्यूशन लेने के बाद हम लोग को इसको डेवलपमेंट कोचिंग कोऑपरेशन के लिए बात किया, उसको प्रेजेंट किया। उसके बाद में हम लोगों को उसको एक मामूली ट्रायल इम्प्लीमेंट से अप्रूवल लेटर मिला, उसको ट्रायल इम्प्लीमेंटेशन किया। फिर 11-10 2023 को हमने उसको रेगुलर इंक्रीमेंट किया। उसके बाद सर हमारा जो प्रॉब्लम हुआ था 20 था लीगल था, हम उसका करीब 1 साल उसको अप्लाई किया। 1 साल के बाद हमें जितना टाइम हुआ कि गूगल 20 के प्रयोग करते कोई भी नहीं हुआ नहीं हो पाया। अगर सेटिंग सही नहीं है तब लोग the new development tried by 118.7 crore का profit was full for. Thanks to all the audience.
Very well, Roshan. And I would like to call last representation Mr. Ankur Sethi from JSB, sir. Thank you, sir, for giving experience.
सपोर्ट नहीं कर रहे तो बोल लैपटॉप चला बोल लैपटॉप
लैपटॉप नहीं चलाए
तो बोल वीडियो प्ले
Sir,
नहीं हो
please
रहा
try to get the main points.
था ना ना पेन ड्राइव लेगा ना चेक कर देखो पेन ड्राइव लेगा
This taking the few slides
वीडियो डिलीट है ना पेन ड्राइव लेगा ना ये जरूर फॉर्मेट चेंज कर दे पेन ड्राइव मार दूंगा
to study from Jingle Stainless. And here on behalf of Hopi Jingle Group, he has commemorate established by Shri Hopi Jingle. It has been majorly four units. Jindals are limited, JSW, Jindal Stainless, and Jindal Steel and Power Limited, acknowledged JSPL. These are the subsidiaries. Few national landmark projects where we have Jindal Stainless has contributed. That is taking these sites. Some of the capacities. I'll be highlighting this that we are Jindal Stainless is the world leader in the coin banks and the brake street. We are the world number one.
But हम लोग इंसान है ना और 5 to 6% India में लोग निकाल अपन राइट 20 होता है 60 होता है
Coming to our implement projects, first of all, we have done three projects. First of all, is NDC chemistry to improve quality. In this in this project, we have worked upon the pitting problem in our low nickel austenitic steels. These are the examples of pitting and scale pits problem. The probable reasons are multiple, but we
कौन सा
have
वीडियो है
worked upon the low strength
साई बोल के
material
लिखा है
or
फोल्डर
high
SAI
temperature and material operated by other
ये
side
नहीं
of laser contributing.
फोल्डर नहीं ये फोल्डर साई है क्या नहीं फोल्डर
Actually,
फोल्डर
in this we have
हाँ
increases nickel
ये
percentage
वीडियो
from
नो 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 नो
8% to
ये
1.5% to increase the strength of the material.
ऊपर वाले जो
Maximum
पीपीटी है वो वीडियो दिखा रहा है पीपीटी है
transfer amount of
ये
change
चलाना है ना
in
हाँ ये चलाना है ना हाँ हाँ यही चलते रहेगा जैसे अपने पास खाली पेन
elastic
ड्राइव है क्या कुछ भी नहीं होना चाहिए उसमें
changes that we have
कोई
in the
खाली पेन ड्राइव
hanging
चाहिए कुछ भी नहीं होना चाहिए मैं खाली ये पेश करके डाल देता हूँ
clearly that we 1.9
मेरे पास तो है नहीं
1.5%
मेघनाथ के पास खाली पेन ड्राइव थोड़ी ना सिंगल
4%
तो इसी को डिलीट करना पड़ेगा बहुत सारा डिलीट कितना कर अच्छा मैं देखता हूँ सर
second one is to reduce the carbon footprint.
पेन ड्राइव में प्रॉब्लम होगा या इसमें प्रॉब्लम है उधर यूएसबी ड्राइव नहीं नहीं
We have
रेजुलेशन का इशू होता है
fuel
रेजुलेशन का भी इशू होता है
or usage can save 3.1 for ton of carbon emission due to low carbon percentage in carbon biofuel as comparison to LNS. These are the percentage of fuel used at our cycle mill. As you can see, we have shown the graphs where the biofuel usage in 2023-24 was only 9.1%, which has been increased in 24-25 to 22.36%. These similarly same this slide shows the same in absolute values, that is in terms of metric ton of fuel use. And this is the month-wise reduction emission of carbon dioxide. This is the same calculation that in 24-25 we have reduced approximately 11,000 ton of carbon emission, and for next financial year we are targeting almost double. And this is our way forward. We have taken trials of few grades in our main heating furnace, and we are going to take the same for other grades also in next financial year. The consumption target we have taken for bio next financial year is 7,000 liters. Coming to our last project, the roll cost reduction at Second. This is we are saving. We have done this work on the specific roll consumption reduction to our linkage rolls by say having saving of approximately 78 lakhs in the financial year.
This is the CPOP. The rolls are supplied at factory and company mills. We receive the ground rolls after the production. Then after water cooling and air cooling, the rolls are ground as per SOP. Then these rolls are get assembled in stocks in state of the production. Then we, for root cause analysis, we done the cause and effect diagram, better known as Ishikawa diagram, given by quality guru Karo Ishikawa. These are the action plans which we sorted out, which will be I explaining in further slides. First of all, handling marks on the road surface. Normally, the handling marks generated due to mishandling. So we have done it through two parts. First of all, the training to the manpower. We the change aware the manpower about the handling mark laws. Various trainings are imparted during flights and during work activities. Last one is the standardization process. This graph shows how the handling mark has been reduced. This is when you are actually achieving zero per daily coverage from 10 megawatts per month, costing 22 to 25,000 each unit. The next one is the we eliminated the cause of generation of surface cracks. What was happening that the nozzle was getting choked, and due to choking of the nozzles, the roll surface was getting heated up, and so we started flushing the roll cooling headers on monthly shutdown. Previously, it was done on quarterly basis. The third action plan was the calibration of eddy current. We have a CNC grinder. So the material cutting was done through the eddy current testing. In case calibration will be out, the CNC grinder will be cutting more and more. So we fix this calibration frequency to 7 days. Increasing the flow rate to ensure proper cooling of the roll. This is the similar behavior which I explained further. The cooling will be proper, the crack and growth won't be generating much. So we increase the roll cooling flow rate from 950 liters per hour to 1020 meters per hour. We have done it just through the overhauling our pumps, cooling towers, right? So increasing duty frequency. We were used to do the ultrasonic testing after each 5 reduction of the roll dia. We increase it to 3 dia reduction. That means we have certified that of 16. Previously we were doing the UT at 12 times in a roll die. Now we are doing 20 times. So by doing this, we reduce the chances of falling in a weight, saving us the production loss and opportunity costs. This graph shows the average monthly savings. We took the average of 6.52, and now we have come up to the average saving of 6.78 lakhs per month. We have already saved 68 lakhs till now, and we will be closing at 85 lakhs in this monthly year. Thanks, sir. Any questions?
Thank you. Question for this.
Yes. Basically, by increasing letter, we increase its strength because increase its strength at high temperature. Okay. So it was we were facing the cutting problem only at the top surface. Actually, we have can you please see what is actually actually we have a furnace guide rope. We have twin stands and both sides wood color furnaces are there. So one guide roll is there to and so that the stick can enter in the boiler furnace. So that guide roll was getting in touch with the strip. So the material was getting braided by that furnace guide roll. So we increase that strength of the material so that it won't get abraded.
What is the material strength of roll?
No. It is the strength of material itself.
But the some customer specification is there. So what will impact of customer?
But it was within range actually. We were using the 0.8%. Now we are going rise up to 1.1, the upper limit of the specification. Okay. Anything else? Yes. Yes. Excuse me. Yeah. Yeah, it is the data from point 0.8 to 1.1 to reach the effect. So, do you take the cost of extra liter was vis-a-vis the effect cost? Yes, yes, we have checked it. Actually, what was happening in case this fitting problem was there, we were do the one additional process we call it as RSRP, re-scaling process. So that cost has been reduced. The additional cost which we were imparting for reprocessing. So that cost has been taken care. Okay, so was not the better solution to reduce the strength of the roller? It's not possible. But the roller will be getting in touch with the machinery while will be hamper over the system. Hello. So, ये और रिड्यूस करने के लिए आप 2-3 चीज़ बताएँ कि आप फीलिंग करते हैं, अल्ट्रासोनिक टेस्टिंग करते हैं, मेडिकल टेस्टिंग करते हैं, जो कि आपको अपनी मेडिकल सर्वर पेन ड्राइव कौन से लेगा था? ये कॉमनी कनोवा टीवी चेंज करना जो ना स्प्लेंडर वो मेरा करने का सोचने का आइडेंटिफाई करते हैं कि आपका जो ये मशीन के द्वारा टेस्टिंग हुआ है पेन ड्राइव पे करेक्ट ट्रांसपोर्ट लेकिन we do calibration on regular basis that's why we have specific product provided by the Canova. So we do calibrate as I earlier explained. हर शिफ्ट में करते हैं आप? No, we do it on 7 days. 7 days में लेकिन जो हम लोग का एक्सपीरियंस है आफ्टर 3 days आप ये कह नहीं सकते हैं कि वो सही है या नहीं. Actually, you have to do this process on regular basis and with experience you will get to know that how many after how many days this celebration are going out. So we have done, we started on the shift basis, then slowly we came to know the 7 days is optimum time. एक चीज और जानना चाह रहे हैं आप रोल के क्वालिटी के लिए या रोल में कोई डिफेक्ट नहीं है उसके लिए कभी आपने हार्डनेस ठीक कर यस हम रेगुलर बेस पे हार्डनेस लेते हैं लैपटॉप पे लैपटॉप का हार्डनेस और SDKs and for other products we do on every grinding. हार्डनेस का जो वेरिएशन है यस जैसे मान लीजिए कभी 3 आया कभी 5 आया तो कितना तक का वेरिएशन आप एक्सेप्ट कर Let me give you example of in our case we maintain the hardness is 75 to 80 shores. This is our standard range and we allow the hardness variation within the value is only 3 shores. Yes, thank you. Anything else?
Okay, thank you. Thank you for giving the games. I would like to request all JP. Please come on the stage. We have momentals for you. Please come on the stage for all the station. Mr. Neeraj Jha, Mansur Ranjan, Pankaj Singh, M. Prashant, Jitendra Kumar, Esther Song, and Anushka Singh. Ankush Sethi. Yes, please. I will look one by one. Neeraj Jha, yes. Thank you. Then Himatu Ranjan from TSC. ये पेमेंट है आपको पंकज सिंह कंपेयर करो विजयनगर एम प्रशांत फ्रॉम DSW जितेंद्र कुमार फ्रॉम सेल BSL SK Swami from SAIL-ISP जो तापमान का जो वेट पर मीटर रहता है 0.3 अंकुश सेठी फ्रॉम JSL Hisar Thank you. Now I would like to call CJ Wire and Bargain, coherent monitor to our system.
तो सर वहाँ पे सर आपका मोबाइल काम कर रहा था तो आपका आपका फीस देखिए सेटिंग ये तो हो जाता है
Thank you, sir. Thank you. Thank you all the audience for participating in this presentation. We have learned outside now. Take the lunch and we will come to meet at quarter.
आप वो बोलने सिस्टम का भी मैं ये बता सकता हूँ लेकिन सो जो हम संपूर्ण नहीं सकते हैं सर वो बातों वो मैं मुझे याद रखिएगा हम लोग वो एक कर नहीं सकते हैं तो इसी में कहीं करके अच्छा है वो है उसमें नहीं है हम लोग फॉर्म के लिए point and hundred they are planning for us. तो गाँव के घर वहाँ पे जो प्रेजेंटेशन आप कौन सी तरह ये पॉइंट ये पॉइंट एक्चुअली नहीं है तो मैं पढ़ने सेकंड एकदम बहुत रही तो दिखा था तो पढ़ने गए हम आगे कभी for example, I was telling this one. And it's very direct from the other, so we don't see it. That's in the future, and photos into the comment. See, just follow what we do.
ठीक है आज बजे वहाँ 6:30 लिखा हुआ 6:30 पेपर लिखा था 6:30 इतना भारी बैटरी है लियोन बैटरी है उसमें कितना बजा वो बाहर का चल
But what a follower कितना है? follower का पैसा कितना है? तो बहुत ज़्यादा है। वो तो बेस्ट में September का मैं ना बोल दे फर्स्ट बोल আমার ল্যাপটপে চার্জ নেই তো আমি দিচ্ছি স্যার ফোন আছে তো কারণ নিয়ে এসো चला के मैं घुसा दूं बड़ा वाला मुश्किल है कौन है पीछे तो बोर्ड है आपका
बहुत करते रहे
यही घुसा यही
बड़ा बड़ा प्लस
पतला नहीं होता, पतला भी आ गया, इतना पतला आ गया, इतना मोटा था
ज्यादा पैसा दीजिएगा तो थोड़ा मोटा मिलेगा, कम पैसा
स्लिप पे जमा से
लेकिन ये वाला जो है ना भैया, ये वाला 2 साल से ज्यादा जो यूज किया होगा, 2 साल से 2 साल से यूज किया
साल में कटोरी
बस, वो चेंज नहीं होता।
नजदी में निकल नहीं होता
जहाँ मुंह कटा
क्या वो जमा, एक बोला जमा करो बीबी को दे दो, उसका ले बेच के कुछ हम भाई कल 2 किलो दी वो हम लोग इतना कटो तो 2 किलो दी करे तो ले ले बर्तन ले लो और तो जूम मीटिंग मीटिंग नहीं आज ही नहीं ऑफ कर दी शट डाउन नहीं करेंगे, सब रहने देंगे। हाँ नहीं अब बांधो कुछ हम भी नहीं कर
छोटा में 10 लीटर पीछे बाहर में वो टीवी लगा रहा है।
तुरंत खा लेना है ना। किधर गए?
वो टीवी लगा रहा है।
उनको फोन कर रहा था बार बार।
रजिस्ट्रेशन हो गया?
हाँ
कब हुआ? अभी हुआ?
हाँ
यहाँ पर हुआ?
हाँ 5-6 जो तो किया
क्या आदमी का?
5-6 जो
प्राइस डिस्ट्रीब्यूशन हो गए थे ना? चलो हाँ? ना ठीक है, ठीक है।
हाँ दिया दिया अभी दिए थे
लाइन में रह क्या चीज में चल रहा है? कौन वाला?
भाई इसमें जो है अब कौन से नाम क्या बाकी
लाइव चल रहा है, क्या चीज में चल रहा
गाने दिए भैया
है? चैनल क्या है?
वही लोग दिया कौन से नाम नहीं मालूम
नहीं है इसमें। OBS स्टूडियो का सुने हैं। I would like to invite kindly to the level of the valuable companies. First, I would like to call Ravi Raman. বলছি এখানে যেখানে সকালে সাড়ে ছিল সেখানে কেউ তো নাই, আর সবাই পেয়েছে ওই সাইডে চলছে, এবারে কোনো সেশন চলছে, শেষ হয়ে গেছে, মানে একটা ছেলেটা জিজ্ঞেস করে যাতে
जो 40 से फिर चालू हो
कौन बस
यहाँ वाला
फिर चालू गाइस?
नहीं नहीं अब क्या करेगा नहीं मालूम टाइम बोला 2:40
2-4 दिन बाद
2:40
हाँ
1 घंटा बाद चालू हो प्रोग्राम
Now, I would like to call Mr. Chandan Kumar MP for the implementation of the productivity in planning. So, how many to join? Yes, yeah. I'm taking not to me. I'm telling you. हाँ कोई गेट पे एक दिन होल्ड हो जाएगी ना? हाँ तो कौन है आपको मालूम नहीं और
राइट होल्ड पे है ना?
हाँ
बहुत चल रहा है ना?
हाँ
इधर क्या दिया है हम लोग?
ठीक
चल चल ठीक होल्ड करो लाइव चलो लाइव बंद है, लाइव होल्ड है, होल्ड करो, होल्ड तो करो, उधर होल्ड करो बेटा स्टॉप बटन दिया हुआ था
हाँ
बिट्टू फ्रंट दे फ्रंट
Now I hand over the paper to one and I give the visa.
Screen profile of the flag. Here we have 7 presentation. This is a very good time. So, क्या sector पेशी? The GM operational presently Vijayanagar. He has experience of 22 years in FSO 1, 2, and 3. And 2 years of experience in project.
कॉल नंबर video
He area of providing the computer excellence. Currently, he will ready to have 3 of our
और माँ निकल तो कुछ बोल
For this is first presentation, improvement cases, digital and sorry, quality issue at silver in NC1, Ravi Kumar.
4 गो टी मंगा लीजिए और हम सोया बस टी लगे मंगा लेंगे ठीक है तुझे सर ड्रोन
Now this presentation
बढ़िया मिलता तब तो
will be done by you only because it's not
वाले
about
खत्म होगा
and he exposed from Islamic or he's in charge of operation from Vijayanagar. So to begin with, this is the basic presentation on the sliver.
गड़िया कहाँ गड़िया सब कहाँ
Sliver can be confused with the seam line. Sometimes it will be like a scab.
कहाँ पे
So this defect, how would we arrive at this defect? What are the things, the observation, online observations we made? What action we have taken? Let us go through the scene presentation on that.
अगर हम अगले बगले में तो टीवी आ जाए तो 4 गो भी सुन ना ये काम का जाकर फिटिंग कर हमारा जाए नहीं पड़ता
So here we have this one is starting to exist. First, EDQC, CSV, and text in code.
फोन कर लिया सब कम फोन कर लिया कोई नहीं मिल रहा है
This is the layer of conflict where we have
ठीक है तू रख व्यवस्थित
section of machine and network downloads.
चंदन कहाँ से जाए जाए
For the 1.2 millimeter. In the retail 92 but in 38 millimeter. Some of the expenses for the HSM one is unique in India and in the world. It is ranking 3.5 million ton with a product mix of narrow. The average weight is about 1200. This is unique weight. So, rolling property, this is for the ASW, highest ever Q1 production and highest ever Q2 production. When I say defect, the defect was observed to be like this. When the rolling was happening, for the downstream rolling, so we have got the feedback that something like this is coming. So, approximately, different patterns seems like related rolling somewhere. The basic idea, defect identification of the interpretation run from 18. See, the cyber, normally the tendency is we are going to throw finger towards upstream. Correct? It is from the caster. Right. So how do you identify that the defect with respect to weight? So it is we conducted the SEM analysis where we have observed that it is only FEO. Whenever FEO is there, still there is about 20% possibility from the caster, but 90% or 80 to 90% possibility from the mill. So that like that, we arrive that defect is originating from HSM 1. So the causes validation, see, normally whenever we have a problem, we have going for a cause and effect analysis where we are validating each causes. So we found that one of the predominant source of influence is before if you see defect, the defect is very dark in nature. So that is happening from the before or ahead of
चारों पेन ड्राइव
treatment.
टीवी नहीं ना पेन ड्राइव प्लस एलजीएफ सपोर्ट कर तो नहीं कर
So one of the correlation which we later
फिर ये
will
अच्छी
correlate and we will show that how it was rectified. So these are the probable causes of C. So we have checked the pass line, coil box inspection was done because that's the coil box mill. And crop share also we were just checking the rollers, any abnormality with respect to rollers. We found that everything was intact. There was no abnormality from the process perspective. We found that
The problem was started after a particular shutdown. So we just gone through the data where data was revealing that after shutdown that defect was more dominant. So we found that stand number one, ahead of stand number one, the guide, the collar height was more. It was more than the cost line. Okay. So that was instead was running to that. So initially what did we do? We have just started grinding and started the line. But later we found that the path line was above. So then we had to break the guide down. After that, the defect was eliminated. So some of the observations that we made, right? So yeah. So this is pertaining to the chemistry of the guide. Later we have validated with that. Thank you. So any questions from the audience? Anything you want to know? Yeah.
What was the position of the slivers? Whether it was on the cake?
It was on the edges.
बिट्टू
It
जब
was
मैं
on the
केस
edges.
किया
Because collar width is
तो सोच भी
180 millimeter on either side.
चल जी
So since the slip was rubbing on that, we were
ठीक
getting
है
on
हम
the
4 लीटर
edges,
मंगवाए
sides
चालू करा दी
from 180 millimeter. The defect was more
केस जाएगा आप
prominent.
जाइएगा ना वो जाएगा
Do you think there will be a whole of male people scans
कोट
on the
उट पर
slivers
चेकिंग में रहता है कोई
from on
दिक्कत है
the
ना उसका
Yeah.
कोट
So if the slide was coming from
कोई
the
दिक्कत नहीं है
center,
उसका
see normally when the slide it is again a top and bottom. If it is from the bottom, there are a possibility from the road as well as from the apron. If it is from the top, you have to see this slide. Wipers are getting rubbed into the roads, which can generate a scratch on the roads and internet is reflecting on the street.
staff or not staff?
So it is for the auto customer that's going to stop the slabs. For normal customers, they know. All auto customers are immediately the slabs are being stopped, especially for the highest critical grades. So then take it to the process.
It is not showing whether it was staff.
No, it was not staff plan. It was normal staff. Yeah.
कैमरा लगा चलो
Then why is not
नहीं लगा
the defect of the slab?
क्या है तो
For validation, we found that the problem was with the ahead of stand number one.
On the micro segregation also. There will be an addition flavor.
No, there was no microfication. The point is it was only new part of the side. So that we have
काम करें
rolled on because the moment if I say slide or pointing towards the upstream, if it's rolled on side, it's on the bay. Yeah.
And which comes like
It is this fiber. It's very broader way of field because field break. I mean, it's most of the time it is pointing towards the casting powder. So we have optimized all the process even with respect to casting powder. But still, it's a challenge when it comes for higher gauges. See, when I say higher gauges, more than 16 millimeter, still it is coming to have a zero slide on that.
One thing I would like to ask,
Analysis. It's only tell us whether it is from the casting powder or it is from the scratch. It's only a scratch. You don't iron oxide.
the troubleshooting beyond that, how you identified that from where it is coming.
Correct. It's very pointed out. Now, see, we had a lot of work done in joint coordination with PDQC and our process team, process control team. We have found that we have gone elimination. So we have seen that first of all, when you see the rubbing type of one, we have just seen the roll was down kind of thing. So we have seen that there was absolutely all rolls were free. Everything was flawless. We have developed a mechanism of checking the across. We will time it to it is going to share the details with you. So, a layman can go and check the aircraft. It's supposed to be 60 millimeters down. You just put that rod, then you'll see whether the aircraft is down or not. Sometimes what happens because of the
From multiples and
yes. That's interesting thing which you have done. And it looks very simple. And even the layman can go and check the condition of the aircraft. Suppose if the aircraft is
approved and there's a possibility that you will rub this thing. So we have done that. Yeah.
How you identified which pass like
It is from the standpoint because see what happened, we have a mechanism of checking the cost line. What we do, we put the bottom row and we do the rod aluminum rod and we just take the upper side. So that time we found that it was just in line with the pass line. So we just wanted to bring it down. We made it down. After that, the defect was eliminated.
Okay, one question. Here.
So yeah.
Yeah. I was saying, how did you arrive that it is F1? Because the spiker which you showed us having iron oxide. Iron oxide can be coming from slab stage, slab corner cracks as well as the scratches in transfer bar are reaching directly. So how did you exactly
See,
one is you have seen the line observation, phenomenon observation. But based on micro, how did you arrive?
No, see, the thing is there are 2 points of concern. One was the slab, and the other one is the process of hot shipment. So we have a PDQC, which we are normally knowing is a packages, and I checked it thoroughly from the because see, we have gone through this clarification. We found that from all aspects it was coming. Then it found it is not possible that it is not from the upstream. Then what? Then it is pointing towards middle.
I had already data analysis apart when I both plugged it.
Yes. So then we have found that we have been gone in detail and we gone elimination method. So we have just pointed out that it is only ahead of the curve.
Was there any internal oxidation in the aerobic effect or it is only scale?
Only the scale.
No internal oxidation.
No internal. Thanks. Anyway. Anything? It was distant areas. It was distant areas, but it was appearing predominantly on acres. Anything else?
Center में भी मिल रहा है
It was not the center. It was the acres, yeah. Thank you. Thank you.
Thank you, President, sir, and Ravi Kumar, sir.
Now, our next presentation is rolling of same hard grade of steel and steel RSP. Thank you, Mohan, sir. Yes.
Very good afternoon, all of you. Hopefully, very interesting. Yes.
Hello. Very good afternoon to all of you. Hope you are very good, nice and sound large. My topic is rolling of ceramic material steel in knee plate mill of circular steel plant. Basically, knee plate mill is a 4.3 meter wide a plate rolling mill. It has commissioned in 2016. Since then, it produced wide variety of steels, around 80 to 90 variety of steel of different width, different sections, different thickness, and different grade. The installed capacity is 1.92 million ton of plates. The expansion plan of around 1.67 million ton of plates in the next financial year. This is the growth chart of our new plate mill. From started, primary distiller, then is a four high reversing mill, then it is goes to secret cooling system where mechanical properties are adjusted. Then hot plate leveler, where plate is leveling is done. If any noodles is there, then it is prepared 1 and 2, where necessary cooling temperature has been maintained. And then it goes to the film cutting area where heavy plates are adhered. And for the thinner sections, this goes to finishing line. In finishing line, we have ultrasound testing machine, double side drilling shear, and dividing shear, and hot plate level. Intermediate there is auto coil cutters, plate marking, and punching. This is the facilities that we have in the new plate mill, hydraulic automated gas control system, roll welding system, and water setting system. ADC is used for the roll properly, roll drilling, the proper thickness we can achieve by this, and roll bending for proper crown and maintaining the speed. And also we have another primary disking, which has a capacity of 250 bar to eliminate the scales that is formed very early. And this is the general layout for new plate mill. We have a thickness of around 10 to 300 meters slab width. Length is around 1200 to 2400. And length is around 2500 to 4100. Maximum tonnage we can roll is 23.7. With the thickness of output is 1.6 to, sorry, 8 millimeter to 100. And length around 6.8 to 15 meter plane. This is the grades that we rolled in the new plate mill. This is my coming to my topic. Head material is the most critical section that we rolled in new plate mill with custom requirement of 8 millimeter plates. That it is a requirement of customers that we need 8 millimeter plates with hardness which is around 250 reaction with well resistant properties, good weldable properties. So it is very challenging for us to roll the SAIL properties of due to for thinner section rolling. And this is the uses of SAIL materials that customers demanded. So compare the liner plates. It's the uses of SAIL material. Normally 8 to 10 millimeter SAIL plates are rolled, but in our mill 8 millimeter is rolled. This is the process out of rolling salad from primary steel making technology, where secondary refining also done, vacuum arc refining, vacuum oxygen refining, and laminating furnace refining. This is all the technology which are done in steel making process. And after casting, it was mother slab was made, and from mother slab to daughter slab was made. From hood, this is transferred to our equipment mill survey site for rolling. This is the process that in our mill. Whenever we roll slab materials, it was charged during the starting of the campaign. That means around 1,000 tons of rolling slab. We normally roll slab material so that the proper crown has been achieved in the road and the temperature has been decided. That is when we roll the slab materials. After the proper rolling has been done, it was normally done 13 to 15 passes with descaling in 246. This is as per our design. We descale it and descale it after that. We proceed for 200 compensation where necessarily instant mechanical properties has been achieved. And after that, it was processed to a hot plate leveler from where it is goes to the fixing. This is the ACS system. What has been said about the plate. This is the normal flow sheet of our craft schedule, which was maintained in new plate mill. This is for 8 millimeter and this is for 10 millimeter. Both this is the flow chart of rolling primary inspection plate, then plate surface. Plate surface is used for to dimensional accuracy. Whenever we have canvas, whenever you have holiness, that detects PSC. PSC system it detects and further action has been taken in the production line. The one side trimming here, PSC, dividing here, marking machine, filing. This is the line flow. In dividing here, we actually as per customer requirement, we divide shear the plates, which is around 15 meters. 15 to as per customer requirement, we shear it in the dividing shear and send it to the customers. This is the sample which was taken by our sample group in the new platform from required yet given type of test, mechanical test, chemical test, whichever test has been done, sample has been got in this session and sent it to administrator. This is the marking machine which was surface marking and as well as edge marking. Both the marking machines are in operation. Along with that, punch marking is there, but in salad material, we do not have any punch specificity is there. This is the surface marking of our plates. Normally in thinner section, there is an issue in variance. So we have cold plate leveler where we process the final plate and to achieve the required variance, to eliminate the variance and to have a proper customer oriented place. The variance very plate and has been processed in cold plate leveler. And it was properly stacked in shipping bay so that no handling damage has been done and it was finally sent to the customer. This is our customers from where from whose destination we are sending the plates. It is the most challenging skill for implement to roll. Which is from 2019-20 we are producing salad materials without telling the customers complaints. Our major constraint was the volunteers and the camper which was generated during earlier parts of 1 to 2 years. After that, we adjusted our working system and now we are 100% customer satisfaction to the market. Thank you.
House is now for open for question and answer. I have a question, Mr. Mohanty. Is it same hard? It is the highest strength which you are going to roll? High hardness?
No, sir. Strength is less, but where resistance, returning the properties, has been accepted to keep the composition and meal parameters one.
Okay. So are you going to do any thermomechanical rolling here?
Yes, sir. Thermomechanical control process rolling has been done here to achieve the mechanical performance.
Okay. You have a concept called multi-cooling, is it?
Which means that
multi-cooling system for the blades? No?
No, sir.
Okay. So recently Anjar plant, one of our group of the plant is installed that multi-cooling for effective cooling and for better properties. So anyway, I'm going to
Actually, sir, we have accelerated control system cooling.
Okay.
Where all the mechanical properties has been applied in the SES system. That is the state of the art new mill, sir.
Okay.
So cooling is never an issue in this new plant mill.
Okay.
Yeah.
Thank you, Vishnu.
Yes. Yes. Yes, sir. Yes, sir. I'm not audible, sir. Please come forward, sir. Please.
Now is audible?
Yes, sir.
Okay, so I'm Nasuna from January, and the this question arises about the cooling system for the fuels. As Mr. Joshi mentioned about liquid cooling in one of the plants. The accelerated cooling system is a kind of cooling system which we call it as extreme cooling 1 and 2. And the third kind of system is installed in the new plate block area. Similar is what Olympic is for the other competition. Just for clarification, I thought of mentioning this. Thank you.
Yes, sir. Actually, Mulpik is used in jingle onboard, where Pleki is there. They used Mulpik system, sir.
It's just the brand name of other competition.
Yes, sir.
What is the maximum strength to produce this plate mill here?
Maximum strength 200 PHN, but various knowledge has been added to improve the wear resistance, reliability. This is the main purpose of that. In thinner section, actually, customers demanded 8 meter we need, but we need with manageable units with this type of mechanical properties, so that they can use it in their fields. So, at least 200 PHN, 200 to 250.
Are you supplying anywhere to wind, offshore wind,
Offshore wind everything. No, sir. Till now they are not working on that. Thanks, sir. I think on this, sir.
actually not that knowledge here about the cell heart different. Our next is from you like Mark actually tell like
Good afternoon to Nanda Krishnan here. Uh, Today I am going to showcase the two improvement cases that we have done over the last few months. The first one is the monitoring of the UC, and second one is the reduction in the amputative grinding. Before going to the presentation, I would like to share some few information about the plant. In fact, in the PDF. So this is our HSM process flow. So in phase one, we have 3.5 MTPA. So the last financial year, we have achieved 3.7 MTPA. And in the phase two, HSM process is going on. So we have commissioned the new furnace in the month of December. So right now we have 5 MTPA. And in the next financial year, by the middle of June, we will commission our fourth reheating furnace as well. After that, our capacity is about 6.3 MTPA. So right now we have three heating furnace and we have the rougher. We have two rougher and rougher one is too high and rougher is too high. And after that we have the heat holding cover. In this first treatment plant we don't have coil box. We have the heat holding cover and after that the crop shear and we have the finishing which is 7 stand 4 high loading. And after that the ROT and then 3 down coilers. This is the basic process flow of our test component. Next slide, please. So this is a typical main features of some Kalinga. Some of the major points is we have the flat cross mill arranging F1 to F4 stand, which will give better profile and the flatness. And we have the long ROT, which is around 103 meter long and use high strength grades. And we have the reheating furnace which is of capacity of 350 tons per hour, which is the larger dimension, with about 13 wheels, so we can able to accommodate larger slab length of up to 12 meter. And also by that we can able to actually coil weight also close to 40 tons. And so these are major features of the HSM plant. Next slide. So coming to the safety is also one of the key areas for the Tata Steel always. So this is one of the problems that we face with the reheating furnaces. So we have gas pipeline systems for the supply of the this gas to the reheating furnace. So during the time of shutdown or any maintenance activity, we used to isolate our gas lines. So, as per our standards, we do closure of the wall, which is present in the gas line. In addition to that, we do the water sealing of the furnace, which is to fill the water in the gas pipeline and ensure the overflow. So, what is the problem that we face due to several problems? The overflow of the water is stopped due to some of the reasons. Okay. So, due to that, there is a safety issue that was raised whenever we isolate the gas lines. So current existing practice was we used to check the overflow at a certain regular interval, which is as per the our standard. But what we have, so we have to involve the manpower, so which is also a concern from us. In between this interval of time, there is some chances for the overflow water which is getting stopped and the operator does not aware of it. So this is the main cause for this problem. So we thought we have to do something to eliminate this problem. So next slide. So what we have done is that we have installed a flow switch in the UC overflow line. Okay. So once the shutdown starts, once our isolate the gas lines, okay. Once the water sealing is done, then the flow switch will become healthy. Okay. So once the flow switch will become healthy, we have done some modifications in the HMI furnace operator conversion screen as well. So once the isolation process started, once the isolation process is completed, the operator will select the UC overflow monitoring selection. It is provided in the HMI. So he will select it and the flow switch will become healthy. So in case of any reasons, if the flow switch become unhealthy, next slide. Next slide. So in case of any issues due to the overflow of the water become less or there is no overflow, so immediately the pop-up message along the pop-up message and there is a footer which is provided on the control room. It immediately goes indicates that there is some problem in the UC overflow line. So immediately the operator has to do the place and take some necessary corrective action to take care of it. So this is the first case. And second case, so as you all know, for hot strip mill, the roll cost is one of the major leverage to reduce the conversion cost of the hot rolled coil. So in the last financial year, we noticed our unpredictable revenue, which was higher, which is especially in our Japan stand. Okay, so we used to have the high chrome road in the last financial year in Japan stand. Later we switched into hydrogen road as well. But the cost, so we notice stand based and protective branding, and it is basically higher in the control stand in the data as an indicator, especially 49% before this problem. Exactly. So we want for an analysis. So the major root cause is the mill due to the mill issues, especially after the COVID. So what we have noticed is that after we open the mill takeout door, the cracks which is getting generated, which is of the higher number as well, but as well as the crack depth is very higher, it's resulting into lot of unprotected grinding, especially the crack depth is which is about 1 to 3 mm. Next slide, please. So we have done the analysis. So as you all know that during the time of COVID, the temperature of the ball which is higher, which is in contact with the road, which is also increases the temperature of the road. So due to the thermal shock, the thermal crack is getting generated. So we have done some simple solution which was more effective. Next slide, please. So what we have done is that we have once the COVID happened in the mill, so we have applied the quick stop. So once the quick stop is applied, we have kept the anti-peeling spray, which is anti roll by cooling for a few seconds. For example, almost for 30 seconds we kept on. So this will effectively reduce the temperature of the roll, not the temperature of the bar. Okay, so that way we are reducing the thermal shock in the road. After that, we implemented this logic. We noticed that the crack depth is significantly reduced. And the so that's I think in the 1950s. And from that, so we can, after this implementation, we can significantly reduce our unproductive bending percentage to significant level. So later on, we have implemented in the same modification in the other F2 as well. And obviously, we have not implemented in certain grades. This is a more successful crack on cooling. That's all. Thank you.
Thank you, Mr. Uday. Kumar, you have pointed out two important things. The first is the gas line safety. It is very important. Any conventional hospital is doing this, but still, the many challenges is the isolation part. So that is the reason I know positive isolation. Have you installed goggle wall there in your line?
No, we have not installed because the reason is the mark which is not able to. Because goggle will be very effective once the gas is very clean. So we have analyzed it, but we have not incorporated because of the mark percentage.
But please go to that because that is one of the proven, the wall where all latest hot springs are going to be integrated with the goggle wall.
Agree, sir. But the goggle won't be effective if the mark is perfect.
So we have these organization units have come now. It is going to make the gas clean, so that would help you as a board.
Sorry for your
Second point is this. Yeah, it's very interesting that you're making anti-fail sprays on to reduce the roll temperature, which is going to save your life. That's good. Thank you, Mr. Uday. Thank you very much for it. So now, house is open for questions. Any questions?
So the railway will get into the unit
Okay,
project
thank you.
where use special funds which are made to level finance, data margin getting and they are not in the bottom of
What such one works like shipping code, how can you back to the workshop? It's just a normal roadway pulley only. But for few sprays, so that normal spray which is on the bike. Okay. That's it, nothing more. Nothing specific. It's not. It's helpful in terms of reducing the damage. What is it? You have service, the temperature indicator raises the height of the it will cool the slippers only. Yes, it will cool the slippers only. It's not much. Okay.
now what no but so upon a whole lot the road
So is it an extra header which is asking for? No, normal roadway pulley. Nothing else. It's a normal roadway pulley. Yes, we are ensuring keeping the roadway pulley kept on for future. Nothing else. That's it.
where curvature of the way
It's a
our next master call this from Tata Steel Meramile. For other point of right for ascertaining the digital properties that we like it. And they can able to use the virtual machine tools. And if there is even a small spot where material remains unwritten, the police have to test it. So then why prone to high system and the forcing and loading for system to optimize.
Yeah, good afternoon all.
My name is Namaskar and the
Tata Steel Meramile or shipment.
no,
So my topic for today is key modifications and advantages that Tata Steel implemented in RHF to device.
different types of engine based on the application. For example, here we the design of
So this is our process flow diagram of our HSM.
they are prone to high acceleration and
Here we have in Tata Steel Meramandali, we have around three reheating furnaces of 300
high
capacity.
power and speed.
Along with two roughers, is R1 is too high, R2 is 4 high, and we have a heat holding towers. Earlier it was in the initial days, this mill was using one box, but at present we are not in a position to use a box, so we will micro position. We have a cross here and also an finishing stacks along with three down colors.
And for example, we analyze the
Usually in Tata Steel, we circle of RX once every 8 years or 10 years. So in the Tata Steel, after the takeover of this plant by Tata Steel in 2018. So we had a planning, there was a long planning to go for this event. As this mill was commissioned in 2010. So in 2024, we had gone for the revamp of our reheating furnace. So in that, the major changes means the scope of mechanical, electrical, and mechanical has been increased. So the major changes by mechanical were done in states, water trough, into line. Major was the mixed gas pipeline complete replacement.
These guys get a virtual analysis of the product
In refractory way, I was known for using changes. So earlier, the protocol with the drip lining, so one for plastic refractory and lot of changes, the refractory materials. And these people also they gone for some modification.
So I just wanted to briefly explain why we have gone for the major changes as compared to the revamps takes place in other plants. So earlier we used to have this, most of the people might be saying this kind of phenomenon in the steel parks where the calculation takes place in the steel line ports. So in this you can see in the down below we have a detailed drawing where we have actually put in the port. So usually in the filter states we had the diameter of 140 mm, the diameter fixed state post, wherein wall thickness was around 20 mm. The inner line's diameter was around 77. So it was, we were hardly having around 10 mm of pulling. So usually early the water quality was not being maintained by the state and for right now it was provided after the takeover. That is why a lot of calcination was observed. So due to this, we were having a lot of seed leakages due to pipe bulging, rupture, and the scarcity of water. And then we have gone for SS wire sheets in the mobile post, where we usually have leakages at the earth level. So this is usually in the commissioning stage. This part is usually insulated with the wire rope, but later on it keeps on detaching over the years and due to the space constraints, nobody takes care of this part. So there, due to the moisture accumulation, the post starts leaking and wall thinning tendency. So that is why we have gone for this wire sheet. There was one more modification, major modification where the feed riders we usually had this super lega alloy or super alloy material in recuperative preheating and heating zones. And in the soaking zone, usually the rider material is of Umco 50. So in the major observation in this super lega material was whenever the super lega material comes in contact with high temperature in the combustion zones. So it's the wear and tear is more. So we have seen this observation over the period and took a decision to go for the replacement of these riders and change the MOC of the super lega material with Umco 50. So with the earlier design, we had super lega in preheating and heating. So we have changed the material of these riders from super alloy to Umco 50. And then we had addition of burners in preheating zone. In zone 1 and 2, both addition there were two burners in top preheating and bottom. As in environmentally, this the furnace length is around 57.1 meters because this is mostly designed for 80-90% of the hot zone. The capacity of the. So with this we had improved the heating capacity means we have enhanced the heating capacity. There was a major change in our gas pipelines. Earlier, our gas pipelines were designed for URW pipe with the thickness maximum thickness of 45 mm. And as environmentally, we are using the created gas. It is one of its kind in mostly in I think in India. It is one of the furnace gas for the combustion in heating furnace.
So there we usually had the erosion, wall thinning, ruptures, and mixed gas pipelines. So that is why we took a major decision to go for changing of the material. We have discussed with our supplier to convert this ERW pipe material to either stainless steel or cotton steel. As stainless steel being the expensive material, so they have suggested to go for the cotton steel. So with the cotton steel, we have even gone for the higher thickness. For above 300 mm, we have gone for up to 10 mm wall thickness pipelines. And we have also installed the explosion class, which was not designed in the earlier supply. So these are the special features in the gas line. And in plastic refractory, in the refractory, the major change was changing the brick lining of the sidewalls to plastic running mass. And there was a major change in even in this furnace. The recuperative zone roof was built with the ceramic module, where the ceramic module holding plate was designed by the OEM was for 3 mm and plain structural steel IX2060 kilo. So that again we usually had the detachment of ceramic modules due to the ingression of the game as the recuperative zone length is short in this furnace because of the length issue. So usually we had some flame ingression or heat ingression in that recuperative zone roof and then the modules were getting collapsed. And due to that we were forced to take shutdowns. So again we have gone for the major change in this area. We have converted the roof module holding plate from MS with plain structural plate IS2062 to ASI 304 material with enhanced thickness from 3 mm to 5 mm. And even we have some issues with the ceramic modules where again there was a mixture of pyroblocks and pyrofold material was being used. So due to that, there was no proper bonding, nor the composition complete. So now replaced all the pyrofold blocks to pyro blocks. So these are the major changes for the blacks. Because we have gone for the travel thing, ICW was there was also an addition of bypass backflow meters. Earlier it was installed with a single battery. Now because due to the failures, as these batteries are fitted directly into the pipeline, so we don't have any option to isolate this line and replace the batteries. Only during the RHS shutdowns we were forced to change. Otherwise there was no option. So at present we have gone for standby backflow meters where we can switch over due to the if there is any failure in the flow meter, the running flow meter, we can change over to the standby flow meter. And this is the changes what we have done in mixed gas piping. Earlier in the soaking zone we were not because this furnace was not designed for a manhole in the soaking zone. So in this design the furnace so we were usually going making some shape of from heating zone to the steam zone. So in between there is doghouse. So now we have gone for installing one maintenance zone in the city where we can have direct access to the zone hardware. So these are the changes what we have done. Minor changes only. That's all for my presentation. Any questions can be asked.
लगा दिया तो लगा या
You have added two burners in the heating furnace. Who was the supplier of that?
ODM is Innova.
Okay, have you consulted before addition? Who has done, whether it was done with Innova or
It was done by
what are the points you have considered before installing? Conditions. What are the conditions you
condition. See, because the furnace, as the furnace length is 37.5 meters. This is basically this kind of furnaces are designed for more than 80 to 90% hot charge, as the length is less. So this was earlier designed for complete hot charging. But due to the change in the market strategy, so we are forced to do the cold charging. We have to increase the cold charging percentage. Those cases we have to increase the residence time to heat the cold slabs into inside the furnace. So that is why to enhance the heating capacity of the furnace, we have introduced this additional furnace.
You have mentioned condition. What is this? What does this mean? It means you don't use condition. You have mentioned that advantage enhance heating capacity of RHF and production. Conditional. It means you
No, enhance the thermal, the rolling rate, yeah. Actually, with this addition, the furnace are supposed to be re-rated for 330 tons. Actually, earlier design is 300. With this addition of two burners, it will be 330 tons. But due to the restrictions of the chimney, so we can go for the heating enhancement of heating capacity, or in some conditions we can go for the higher rated capacity. So there is some restrictions in the chimney flow.
okay.
Is there any question? Yeah. Yeah.
What is it?
Sir, it looks like that good job is done for the shutdown and event of the furnace. You have taken care of many design flows you have attended maybe, with respect to your production philosophy. So, how many days you took to change all these things?
Yeah. This complete revamp was scheduled for 79 days and we completed in 78 days.
Good. And you mentioned about this gas creator. So, is it the part of original design or you added later on?
No, it was a part of the old design. We have not gone for any change of the gas preheater, but we have changed the material of the gas pipeline.
So you are using the mixed gas. With what CV?
Mixed gas CV is 2000.
2000. Okay.
Any questions?
Sir, what is the percentage of hot charging or cold charging nowadays?
At present, now TSM we are going for around 30 to 35% of hot charging and around 40% of warm charging and the balance is cold charging. So you can say that around below 0 to 250 degrees we call it as a warm and above 250 we call it as hot and direct will be above 650.
Thanks, Mr. Maro. So he has covered two important things. One is the skip maintenance. So the very essential part of heating furnaces, where the water quality plays a vital role in that. So I will just give a recommendation. So where Pyrotech is one of the party from Bangalore, they are supporting for the flushing of the line, skips cooling system. So which has benefited both HSM1 and HSM2. That is point number one. And the gas preheater is one of the thing which I think is only in Tata Steel it is running. I don't think we need what is one. You can cover very equal to the operation is concerned. And the third part is this augmentation of the furnace capacity, as is like I said, like installation of the burners in the BD. So it's similar concept which we are going to do for HSM1 where capacity is being enhanced from 250 tons to 95 tons. So thank you, James. Thank you very much. I'd like to just tell one thing. What you said about chemical flushing. So in Tata Steel already there is one miner which is doing this kind of things from last 10 years. So I think it is a proven technology. Okay, maybe the supplier is different. So I think it's they call it a golden chemical. The material is different. Yeah. One more series, no? What are the key parameters of water mass speed cooling? Any ranking that you have increased the life by maintaining the parameters of the water cooling. So what are the key parameters? See, before the takeover of this plant by Tata Steel, earlier it was run by Bhushan Steel. So I don't know the exact. There is a say that during that period, the furnace ICW was maintained like normal DCW water. So in those days itself, the calcination took place and the layers were started forming. When the Tata Steel taken over the plant, immediately after 1 or 2 years, so they started bulging, leaking. So after that, Tata Steel also restored this thing, and we also explored, and we took the consultation from OEM, the required parameters. But usually the OEM prefers for DM water that cannot be maintained in India. And it is also difficult to maintain those kind of parameters. So usually we go for around PS of 8, less than 8 for the safer side. We want to go to the normals. Others, it will be around 200. Chlorine, chlorine. Chlorine in the water. Chlorine. Yes. Chlorine is around, I think, maybe from around 35 to 40. Mm. Thank you. Anyone else want to say? Thank you. Thank you. Our next presentation is from JSW Dolby, Ranjit R. Mr. Ranjit R. Good afternoon. Thank you, RMC, for giving this opportunity to present this topic. Myself, Ranjit from JSW Dolby and working with Electrical and Operations Department. The project to present here is the real-time mapping of run-out motors in CSP mill area. So this is the main layout CSP mill. We have two furnaces with a sewer area, and then we have deep cellar, and six finishing mill stand, and then we have a cooling area, and three and two boilers. The main area here is our ROT. We had a major revamp of our automation system in 2014, which was done by Technology Lab. Before this, what was happening is that if there is some scratch mark coming in the rolled mill coils, which will be detected by the proper sensor head, which is after the laminar and just before the coil. What will happen is that sometimes there are 240 round-table motors. If due to some motor failure or bearing down of the rods itself, scratch will be produced. And once this is detected by the parasitic, the operation team will inform mechanical and electrical department. So it was a very tedious task for the both of the maintenance department to go physically verify from where this scratch mark was produced. Mechanical team will physically, mechanical operation will physically inspect the 240 around table in the field, and E&A department will go to the our DBs, and we have to individually open our DBs and to find out which motor has failed. And this was the main pain area. And by that time, almost 4-5 slabs might have been rolled. Because when we hold slabs, then we will be in a condition where we have to chopping the slabs. So again, MTS slabs might have been produced. So this is a real-time monitoring HMI dashboard which we have created after 2014.
In 2014, what we did was, when the automation design was happening, we revamped the whole ROP along with the Simacode monitoring system. So by providing Semacodes and CTs, we were able to bring back the current monitoring of the individual 240 motors into the HMI dashboard. Although I am only saying the main pain area was laminar ROT table. Right now in our CSP mill only, we have incorporated that to our ERT and thresholds areas also. So we have all the run table waters from the English section of the mill to the down corners we have now in the dashboard. In this dashboard, you can see the individual numbered motors along with this current, and here you can also see some red dots which are shown. And this basically indicates that the particular role has been switched off due to some problem or requirement need. So this dashboard is available in our automation department, and similar physical code is being provided to the mill pulpit also. So suppose quality individual if he reports that some scratch mark is coming, immediately the operating person can see that from which road, particular road, this scratch mark is coming, because the motor which has been switched off will be provided by this red dot. So this is immediate identification of the problem. This is the wiring diagram for the schema codes. From each, we have the DB in which we will having 10 motors, and for the 10 motors we will be having individual cities for the 10 motors, and the individual city output will be connected to the SEMA code monitoring system. And from this SEMA code, for the 10 SEMA codes, this will be connected via Profibus, and this Profibus cable will be taken back to our one centralized CPU, which is CPU S7300 PLC. This is the revamped ROT DB, and each DB has 10 motors, and the top and the bottom is the last is the CP monitoring system, which monitors the three phases currents, and this feedback is given to the SIMO code using flat band connectors, and the SIMO codes are individually connected in series by Profibus cable and through back to the CPU. This is a current trend which shows the actual running current, and these spikes which are showing seen are the when the slabs are poured and the ROT is being accelerated. Suppose some motor is taking abnormal current, then we will have a live trend of this, or we can even go back and view the recorded trends. We can easily identify out of the 10 motors which motor was taking higher currents. This is another HMI dashboard. In the same dashboard, you have so many pages. Because this is we have much more possibilities. We can develop these HMI in whatever possibilities we can. These are some of the possibilities which we have developed. This is for one inverter section. One inverter section has 10 motors. That means 10 motors in 1 dB, and each motor will be labeled, and it will show the current. And the one problem which we when we installed this thing was which we had only developed one XMI in which 240 motors were shown. The first layout which I have shown you. There was problem was that we can easily identify which motor has tripped. Suppose 30 number row has tripped, but we don't know how in this 30 motor, with this 30 motor which under which inverter section it comes. So then again, a little bit of time was again taking. So again, this HMI was developed in which we will again identify from out of which inverter section the particular motor comes. So if one of the motors trip, then the particular inverter in which the motor exists, it will be blinking red, and we can identify which inverter section has got the problem. This is similar another kind of dashboard in which the 10 motors are given, and the individual and average current total current will be given in that. So group 1 inverter 182 amperes. That means that the total current of the 10 motors in that particular. And this blinking tab indicates that which motor in which inverter section. And here what we have done logic is that along with this identifications, we have also written some logic in the PLC that although we are having the three phases of the currents of this motor, so we have done some logic. We have provided 40% of phase unbalanced currents. If RY be any phase unbalance, it happens above 40%, then particular alarms will be set. And if this particular unbalance happens for more than 50 or 60 times, then there will be a counter which will be set, and this will again give a message that this particular motor, so this phase unbalance has gone above 60 times. So then during the next break or shut or possible breaks, we can just go and identify that motor, and we can see whether the motor bearing has some problem or the hole has any issue. So this also gives us a predictive analysis that if something happens like this, it will not go into ultimately producing scratch. This for this we have applied for patent in 2019, and it has been awarded to CSP Milliande. This patent is with CSP Milliande. And these are some of the benefits. The main benefits are that, right, I am already mentioned the time, the physical time for which the identification of the problem, like it has been reduced. And another thing is the personal safety. The individual persons have to go in between the rolling and check the laminar cooling, and that is a major safety concern. And these two have been eliminated from this. And also because we know that there is very imbalance happening in that system, there will be the system will already give a notice so that we can check before that system completely fails. And there are much more possibilities in this. You can have your own logic developed so that each one can benefit according to their own needs. These are some of the things which we have done. So maybe in some other plants they will find some more users so they can develop their own logic. Thank you.
Thank you, Mr. Ranjit. It was a really unique an idea. Till now, the ROT is facing because see, none of the hospital has got this facility. Only Dolby has implemented. We have taken this idea for our mills because the last COE, Kola for internal cluster of meeting, this idea was shown, presented. This is one of the unique idea where all hospitals should have this because it's a big challenge to keep ROT roads healthy because more than 200, 300 roads are there. So in order to maintain that, it's a critical. If you have the system, it is going to give us the trigger that yes, this particular road is a problem. Where we can directly go and attack that particular road. Thank you, sir. It's very useful information. Thank you. So question and answers for the house.
So the satellite will be provided in the control room or where? Who will monitor it?
I think there are two dashboards. The central CPU is in our E&I department, and where our shift persons and our team control rooms are located. There is one dashboard, and one dashboard this was the first installation, but then we noticed that sometimes when our field operators are in field, then we will not be able to monitor it. So we again provided one dashboard in the quality pulpit also. So mill and quality pulpit, both pulpits. So now it is in front of the operator. So we can see this.
Before going to the failure, so with the trend of the current, can you able to predict it?
Yes, yes.
We have identified.
Once the motor trips on overcurrent, then obviously that. But before that, if there is any phase imbalance, so suppose there is a jamming in the road in the motor or in the motor bearing itself, then it will take more current during the acceleration. Okay, so then there is a provision of phase imbalance and overload also. So we have provided the FLA is 11 ampere. So if it goes above 20% of FLA, then again an alarm is triggered and it will give a pop-up. For this particular inverter section, this motor there is an FLA overload. So that also will trigger that this particular motor is telling.
Just for my better understanding, so before this monitoring, after this monitoring, any with respect to the downtime, it's like any data you have, any should say.
I have not got any data yet, but the main thing is that without this, the main problem was that the identification time. See, once the MTS is reported, it will take almost 15 minutes to go and physically check all this. And during the running process, it is impossible to go and check. So in between this gap time, you have to check. So again, 4-5 slabs will be ruled. So again, MTS production is stopped. And if you downtime the milk for 1 minute hour, so the portion production 37,000. So then again, if you calculate about this by 10 minutes of downtime, then also it is 3 lakh rupees.
Okay, thank you.
Thank you.
Our next presentation is from SAIL-ISP, Mr. E. Manoj Kumar.
कितना बंद कर निकाल मुझे नहीं
I'm Vimal Small, and my colleague Krishna Kumar. We are from Salem Shipyard. We are here to give some insights and implementations what we have done in HR Mazana, CRM, pertaining to small problems. So, this is a roadmap of our presentation, and I will start with how working with. So initially the code only code CRM has been commissioned. The announced September 1981.
बोल कैसे
Because
कल
hot on extra 30 minutes only.
जब कैमरा लग हाँ लग तो बहुत
So,
बहुत ज़्यादा
printing has to see. So, do you know any like this for methodology? So initially, ASC has been supplying them to slabs, business slab. Then after months, then we were able to supply slabs to the here. So these are the various facilities at Salem Steel Plant. Hello. These are the various facilities at Salem Steel Plant. The SMS, hot rolling mill and cold rolling mill. And so our carbon 90 unit. So this is a hot rolling mill overview. So we're having immediate colors as well as four heights and working mill and a second mill, laminar. So this is the various like technical parameters in RHF. It is icons for working beat, and this you can see discharging temperature, everything. In total 56 balls. So I'll give brief description about all the units in HRF, and I will come to the problem voltage. And this is the primary descaling unit, and this is roughing mill. We have this is also mill unit, and these are the capacity of electrical motors, the uppers as well as edges. And usually from roughing mill, we used to produce the mass per, and its thickness is around from 24.5 to 25.5. So the thickness is maintained, and weight correction will be taken place here. And before entering into the finishing mill of second mill, so there is a crop shade unit. It cuts the head as it is said. If any tamper exists, it will take it out. And this is the second mill, and this is the finishing mill of our hot rolling mill. And there is four high reversible with two parallel furnaces are there. So usually maintain a temperature of 950 degrees for carbon steel, and for stainless steel we maintain around 1000. And HGC is there, and CVC, AGC, and RAC thing. Different meters for HGC. Things in the house. And two X-ray gauges for thickness measurement has been employed. One at the increasing and other at the exit side to measure the thickness in each process. So this is the automation system. And now actually some latest like these we are commissioning new models over there. So the commissioning is going on now.
वाइट कर दिया था उसने चुकल कर दिया
This is a laminar cooling. Only for carbon steel rolling we use a laminar cooling. So we will maintain the temperature of around 600 degrees for most of the carbon steel pipes. For stainless steel, only one or two bags will be open to maintain temperature around 70 to 800 degrees. So finally, this is the round color unit.
And actually, this is a major problem we are facing recently. This is the grade 409 year grade. This is the grade usually we supply for Indian Railways and IRNCK 409 IRNCK. So remaining like we roll this grade for different wings from 800 to 1275. So for in wider widths, there is no issue, like there is no major issues. But while rolling the coil for 800 gig, then we find like camber generation in each and every coil. So usually in wider ships there is very less or no camber generation. As the width gets reduced, as it will go to the narrow coils, there is a huge camber generation we have seen. So even the customer complaint is there, like the D1 minus D2, the value, the diagonal length, the difference value is much higher. So in order to circumvent that, so we have changed many parameters. Finally, we arrived at this. So we reduce the RAC gain. Instead of from 75%, so we made it to 50%, and we decrease the side weight guiding and central distance. So, even that is earlier it was around 80 by 100, guiding was around 80, and centering was 100 mm. And we reduced it to 70 by 90. And mass path acceleration time also we decreased from 25 seconds to 12 seconds. And we strictly maintain the width around plus or minus 3 mm. Usually, width wise we can find it in, or we can have only in second width. So whenever the width is going above this, then we will tell the roughing mill operator to alter the width to reduce it. So we can reach the width, so that the proper width is maintained. And with these series, we will be able to the damage of what
देख लीजिए सब
issue. In other words, so there is a huge using camera, and while calling use there are the hanging piece so even that got reduced. And there is no complaints from customers regarding the D1 minus D2. It came down to 2 to 3 mm. So, more number one coils which are hot, should spread to customer directly. Either hot rod coils goes directly or go to the APL line and it goes to customer. So, more number of number one coils to be able to produce. So, material wastage has been reduced and coal coils also has been reduced. Copper got reduced, coal coils achieved. For the near cycle times, shifting the vertical approach is the right side of operator side. It is shifting and it is hitting the vertical approach and it is getting covered. All these things got reduced with those changes. Next one is insights of CRM as well as implementation statements.
हाँ सर मैडम चला दो तो टेंशन है शायद तुम्हें टेंशन लिया ऐसे क्या
Our program is complex. It's executed with coil with lines and manually furnaces, 3 conveyor and picking lines, 2 sales servers for the high, and 2 sleep hustles, some slitting and shearing lines and coil blanking line. In addition to the common number one finish as told by my partner Manoj, 2D filters and wide range of uses including number 3, number 4, number 8 filters, mirror finish. And we also do a rolling of pattern definitions such as moon rock, checker, honeycomb, and such definition. One of the problems we have done several critical improvement measures to improve products and performance of the CRM. And one of the improvements which we have done is replacing our traditional mechanical short flow control valve in our short lasting machine of aluminum picking line 3, which was originally supplied by our OEM Messrs. DISA, by a magnetic type, now moving parts type short flow control valve. The original valve had a lot of moving parts, such as the valve is being operated open and closed by a pneumatic cylinder. like of print and bucket using steam onto the bearings. And stroke length of the piston rod of the pneumatic cylinder is controlled by an linear motor. This is also having a lot of moving parts. But any one of those parts fails or stuck up, the actual torque flow what we are dealing with proper stick surface without any scales or something, we are unable to achieve. Because of that, we have to reduce the line speed and run it with the reduced capacity, which will thereby affect our productivity. So what we did is we ventured in the market and contacted one of the parties was supplying such type of magnetic valves which doesn't have any moving parts. It is the torque is held by a permanent magnet and by partially demagnetizing, we were able to give a supply partially demagnetizes and gives the record flow, sheet flow to the fuel estimation. Now we are able to run the line at the rated speed of 14 meter per minute for a 4 thickness of 409 grade, whereas previously we were only able to achieve line speed of 10 to 11 meter per minute. So there is an approximate increase in production of 20 to 30%. And one of the issues we are facing, but we are tackling by the use of OEM spares is our scale breaker in handling in team line 2. It is like a kind of a wet type scale breaker. Where a lot of bearings, bending rolls, leveling rolls are incorporated in that, and it is loaded by three hydraulic cylinders controlled by a move bar. The thing is the spares which we are currently buying, we are only buying from the OEM, Germany, and it's which is very costly. Actually, it is costing around a crore per year to maintain the scale breaker. If at all anyone else is having such type of scale breaker, where some cheaper alternatives which give almost the same productivity or better performance, it will be helpful for us. This is a forum, so I am asking help on my peers. So thank you, sir.
Thank you, Mr. Manoj and Prasanna. See, you have covered one important aspect of camber. So you have adjusted the guides closely in order to control the camber. So that is one thing. It's a unique practice where any thought people brothers try to operate the guides very closer. So maintenance aspect of it, they think that the liner wear is there, no, the liner is a burden for them, but no. They have to achieve the quality guides that will be offered in a very close manner to control the camera. Thank you.
Also, it's something we mentioned that and
I think we have, yeah, it's a good idea. Thank you. Any questions from the audience?
Thank you, Manoj Master. Our next presentation is from SAIL-ISP. Sir Amit Kumar Singh. From SAIL-ISP, Mr. Amit Kumar Singh.
यार सामने में सीसीटीवी के नीचे में दो हल्का हल्का टीवी है, ठीक है? एलजी का। हाँ, तो एक वाले को रस्सी मारेगा, देखो रस्सी मारेगा। और चेक करो वो चीज़ ठीक है तो टीवी है देखो। ठीक है? हाँ, टीवी लोड करो कम करो दी, लैपटॉप लोड। लैपटॉप भी लगतो, एचडीएमआई के भी कन्वर्टर लगतो, एचडीएमआई दोनों सब लैपटॉप लोड लगता। ठीक है? तो फिर टीवी रेगुलर लोड करो फोन करो।
Thank you, everyone. I am Amit Kumar from CRP, Cooperative Bank. I am here to take here on the topic of optimization of fiscal cost from forward accurate and care condition monitoring. I will discuss here some case studies of the diagnosis and condition monitoring. This is the overview of steam pathway. This is a single stand for high loading mode, and the HR point from SHM is processed through the couple pickling line randomness. After that, it is processed through the hydrogen and steam furnace, and after that, for vapor addition, it is processed through the steam pathway, like providing toughness to the seat and shape control.
and regional mechanical improvement in mechanical properties. This is the salient feature of steel pathway. We have various product grades and as well as different product grades of thickness varying from 4.25 to 2 mm and weight range is 800 to 1560 mm. Uh, our production capacity is total 0.86 million ton. Here we run well in the two modes, elongation mode and force mode. This is the graph between the uh, machine reliability and maintenance maturity. We can discuss the maintenance maturity at various levels. The level one is the reactive type. It is traditional method of maintenance in which we do the maintenance on the failure. And level two is the plant maintenance. It is being done for the availability of equipments for efficient utilization. And level third is the preventive plant maintenance. In this matter, we do the preventive maintenance to avoid faults, failures like wear out of the machine parts. And level four is the proactive approach of the maintenance. It is the condition-based maintenance. We monitor the condition of the equipment on regular basis and accordingly we take the corrective action. And level five is the advanced version of maintenance. In this maintenance, we use the use of artificial intelligence and collecting information from the Internet of Things, actuators, transducers, and sensors, etc., and analyzing this data with the help of machine algorithm, and we can find out the design related issues and we can solve the problem accordingly. This is the condition-based maintenance workflow diagram. It is the same way. We install the sensors to monitor our equipment on a real-time basis, collect data, and we analyze the data and take corrective action to rectify the issue. And also before this, we compare our baseline standard also so that we can find out the where is the fault. This is the advantage of using condition-based maintenance. When we do the condition-based maintenance, there is the we can avoid the premature failure of the equipment. We can save money on spare parts. Workers are safer because we can avoid the catastrophic failure, and it also strengthens the reliability of the equipment. This is the case study. Actually, we were facing issues of high vibration in the mill stacks. The mill stacks, little bottom work roll is driven in steel pathway, and it is coupled to the universal shaft. So the critical point is the pedestal unit where we were facing the high vibration. So the vibration why it is matters. We know that if we avoid the vibration, there may be premature failure may occur, component failure, and it hampers the production also. The influence is directly related to the production. If it may fail early, so there can be an unplanned downtime. We know if there is a more downtime, then production also it will be affected. These are the source of vibration. We analyze all the source of vibration like misalignment, unbalancing, mechanical rudeness, or faulty bearing. After analyzing all these points, we came to conclusion
that what is the root cause of the vibration. It was the, this is the part, wobbler part. Inside wobbler, there is a boost and feather key. When we dismantle the part, we found that the tolerance of these uh, part has been increased. Once the tolerance has been increased, there is a wobbling effect on the road side, and that vibration is propagated through the pedestal. So once we control the tolerance limit, when we bring the tolerance limit within the standard range in the range, then the vibration level has been drastically reduced. This is the we have online vibration monitoring device, and this is the data. We are collecting data on real time basis on day-to-day basis. This gives the clear indication when the degradation of the equipment is about to take place, and then we take corrective action before the failure is. This is the another case study. This is the anti-clutter ball equipment is being used in the ski pathway. It is raised by the two pneumatic cylinders to contact with the stick while rolling in order to avoid the fluctuation. So, in this case, we are facing the issue of this cracks on the piston. Due to this cracks, there was internal leakage that because of this actuator was not working. So we plan to modify the system to rectify this issue. This is the pneumatic circuit diagram. Actually, this equipment is operated by a pneumatic cylinder, and pressure was given in rod in also to move it down. And frame weight and along with roll is enough to move it down the cylinders. So extra pressure, what we are doing, we remove that pressure. We started using it as a single acting cylinder. So the mechanical shock which was coming at the dead end position of the piston, which was creating cracks on the piston, it was completely eliminated. And also in the solution, we we provided a stopper. Before the dead end, we provided a stopper uh, to prevent it completely go to completely dead end position. Before 5 mm, we stopped the actuator. And alignment of base also has been checked. Along with that, we modified the piston. We modified the pin. This pin was actually in the frame where radial and axial load were coming. Radial load were taken by the hook, and for axial there was no provision. So we provided the boost along with the provision of lubrication so that axial load also may be taken place. And third case study is this is the uh, filter in steel carbon. Its function is to tilt wire from high vertical position to high horizontal position. There are two hydraulic actuators for the tilting of the wire, and we are just two of this kind of crack on the barrel, breakage of bolts, etc. So after this, we find out the solution. We took preventive actions for eliminating this kind of issue. Uh, there we check the alignment of the actuator. In anyhow, the actuator clearance part, if it gets mismatched, so there will be additional load on the because two cylinder we are using. One is imparting additional load on the other. So there and also there must be a synchronized movement of the actuator. In order to make synchronized movement, we regularly monitor the air condition of the both the actuators. And this is the advantage of doing condition-based maintenance in terms of profit. we can see here the total cost will be optimum only when we do a optimal level of maintenance. If it is too high, the cost will be too high. If it is too low, then the cost will be too high. So overall conclusion is that we should do the maintenance the optimal way so that we can get the maintenance cost at lowest. And this is directly proportional to the our profit of the organization. So optimal level of maintenance must be ensured in order to get the optimal profit. Maximum. Thank you.
Thank you, Vishnu. Your last slide is really very informative rather.
Yes.
Yeah. The last slide which you have shown that will break your point between preventive and the breakdown maintenance. Yes. Just throw some light on reliability maintenance. Have idea about reliability maintenance?
Reliability.
Yeah.
Yes, sir. We do when condition based maintenance. We take corrective actions before the premature failure. This will increase the reliability of the. So I think this is the corrective maintenance we do that is exactly equal to the reliability.
But have you ever looked at any gain in respect to hours of saving or percentage utilization with these case studies?
Yes, sir. This failures were occurring repeatedly. So once we get this all this modification, this failure completely removed. The cost of the equipment is very high. It is in terms of the lakhs. I think it will be a 10 to 40 lakhs around. If we cover all the equipment. So that is around maximum saving is around 50 lakhs is saving.
Okay, thank you. Any question from the house?
Any questions?
Thank you, sir. This was the last good question of question. Now I would like to invite Vidya Pankaj sir to conclude this.
First of all, thank you for this great knowledge sharing session. So we have started with the quality issues from Vijay and Nikhil's in March. Then we rolled, we heard about sail hard, the separation of the grades. And we have touched upon process safety, which is a very key aspect of any offshore well. Where we have discussed about the installation of the sensors to monitor overflow in the gas line isolation. Then we have seen the enhancement of leaking furnaces, the life of a modification. This is one of the key aspects of any hot ship, we should take it as a positive note. But we have learned from Takashi where, after 8 hours of furnaces, we have to take down and we have to go for the revamp. Because what is happening is I put in our own example where, we've grown our capital repair. And because of that, the unexpected breakdowns of the furnaces which are leading to a breakdown of items and trees is roughly impact about 20,000 tons of production. So it's very huge in terms of the loss. Then coming to the real-time monitoring of the RO, this is one of the unique idea where I request all hub shipment to take it as a point of concern and please implement it on very and affordable. We can implement it with very effective way of saving the quality as well as the time. Then coming to the improvement measures of hard rolling mill and cold rolling mill and for sale. So that is also very useful information to control the camber through the guide. But see, there are some camber you have to control through the clearances. You have to optimize the clearances to the stand. So that's what will help you. Because I think there's a very small mill, there's a mill we can talk about 2 meter wide mills where that the camber is very critical. So during that time, you have to have a mechanism of that. Then we have seen the vast upgrades of skill paths where reliability maintenance, predictive and preventive maintenance, breakthrough points were discussed. And very useful information and big round of applause for this entire team. Thank you. Thank you very much.
Now this is time for felicitation to our presenter. This felicitation will be done by Vidya Pankaj. So I will recall the name of
JSW Vijayanagar team, Rajkumar, Haldi and team, please come on.
Yeah, I call Mr. Agarwal for that.
Please. Now, MP Mohanty sir and team from SAIL-ISP. P. Uday Kumar from Tata Steel Kalinganagar. A. Manoj Kumar from Tata Steel Mera Mandli. Next team Mr. Randeep R. Next is Ranjit R from JSW Dolby. Please give round of applause, please. D. Manoj Kumar from SAIL SSP. D. Manoj Kumar and team. And last one, Amit Kumar Singh from SAIL BSL. Now I would like to invite Shailendra Kumar sir, our CFO, to facilitate our sessions here. Please give a round of applause. Thank you, sir. This is the end of session 2 of the. Thank you. Thank you all. Thank you.
Then the tea break of 10 minutes, then we'll start the lessons.
पॉज कर दे इसको
मेघना तो नहीं बेच रहे हो तार के साथ
ये तारू है ना की बात
दुकानदार और वो डालो तो कोई लेके रखती कोई नहीं
Hijo de qué conducta. Vamos a dejar. Si ahora es con línea de poner la oleada.
हाँ
¿Qué para? ¿Qué son los
ये साथ रहता
Más खराब किस्मत खराब
कोई ना महीना अच्छा हाँ महीना तक बैठे रहो कोई फायदा नहीं
Going to start the next season of our career.
वहां देखा ना क्रिकेटिंग वाले लेके रखो
For the next season, I request Third chairman, say Bhavan and Chandan Kumar, he is the rapporteur of this. I request Chandan to start this.
Take a seat. We are going to start today's last session of flat rolling area. In this session, total 8 products, 8 presentations. And this session, the last session is chaired by Sri M. Bala Nagaraju sir. He is completed masters in metallurgy from IIT Burnpur and worked at Tata Steel for 25 years in quality assurance of cold rolling, hot rolling, galvanizing lines, and new CRM. Currently, he is working as TQM and quality assurance area of JSPL Angul. And he also is associated with plate mills, bar mills, HSM and CRM, galvanizing line and color coated lines. Now we are going to start our first presentation, which is presented by Sunil Mitra, Mr. Sunil Mitra from Sales. Mr. Sunil Mitra from SAIL-ISP.
स्टार्ट कर दिले
हाँ
आस्ते चलो ऊपर से कोई मारता तो बोले बोले सही रहता है नीचे पे मारता नहीं
मैंने तो कुछ ना कोई आया पहला लोग के
Good evening to all. I welcome you all to my presentation.
Needs to there
Three sessions continuously back to back. Thank you for being here.
ना वो तो कबे गए थे
Good evening. Today I will be giving a presentation on exploring basically the impacts and effects of super-accelerated cooling on high-strength global wide steels and plate mill plates of high steel. What led to this? The current scenario in the steel market. The steel makers have become very competitive now. New facilities are getting operational time to time. Steel prices are going down day by day. Profitability is decreasing.
लड़का
Demand for quality steel
मॉल
is
करने रहता है
increasing in the market,
तो
and the customer, as we know, is becoming very demanding.
रहते
They are wanting tailor-made products. Demand for quality product is increasing. Quality norms are getting stringent day by day. Customers are seeking customized products as per their demand. New products with high quality at low cost is the buzzword today.
क्या कर रही थी
So, Bhilai Steel Plant was commissioned in 1983. So, in 43 years we have spent. And now certain packages are coming, mainly focusing on the quality.
यहाँ लगा था हम ये 5 मिनट का
The
बाहर
super accelerated cooling system
कौन
will basically
मेहनत है
optimize the minus aspect.
फिर हम लोग आए
Anything of super cooling system, EMCP, thermomechanical control process is the great refinement. The strength of the material, what we are exploring is from great refinement. Improves properties by great refinement. Control on parameters during hot rolling. Control on parameters during cooling. And try to avoid the offline heat effects, which increases the expensive. What brought the need, as I mentioned,
Plate mill of dry steel plant is having laminar cooling. Presently, we are having laminar cooling, and the product what we are getting is controlled cooling. Now, when we are going to this cooling, and maximum what we can get from the laminar cooling is above 20. If you don't get above 25, we are not getting properties, design properties.
अभी आया
The cooling properties to plates thicker than 28 mm and low alloy steels are high tensile boiler qualities and DMR. That's we are not meeting the requirement of the market. The laminar cooling has become ineffective. Even plates not requiring normalizing after rolling have to be done to get the desired property. You have to normalize. That is the additional load what is coming to our. Super accelerated cooling will definitely give a uniform cooling, and the requirement of low temperature cooling and high strength plates, which is constrained in plate mill. Plate mill, the maximum load what we can apply in the finishing side is 4,500 ton only, which with our as compared to our other competitors, as I mentioned that it's a 1983 mill. The efficient water cooling mechanism of the proposed supercooling will facilitate an achievement of high structure, giving ferrite and barite to improve the strength, toughness, and buildability as required. And the last is the demand for high strength plates have increased for the building structure, bridges. The production of these plates are becoming very difficult because the constraint of low separating force. The maximum roll separating force is, as I have mentioned, is 4,500 tons. These are the disadvantages of the existing system, laminar cooling what we have got, produce control cooling. The poor cooling rate. Hardly we are getting from 12 to 30 degrees per second for nominal plates up to 60 to 20 mm. Non-uniform cooling, the top surface and bottom surface temperature difference is there, which further leads to warpage of the plates. And we have not got a very good leveler, and a new package leveler is being also proposed. Inconsistent level of flow, top and bottom surface temperature difference is there. Desired grain size and microstructures are not achieved with the laminar cooling. And thickness range, which is allowed, is only 40 to 20. Beyond that, we are not getting that effect. Now, what we have desired and what will be advantages we'll be getting after having this super accelerated cooling system is the cooling rate will be very fast and the rate of heating is also so 180% quality. Uniform cooling, enhancing plate toughness, superior strength, and improved durability. The grain size and microstructure achieved will be as demanded by declared by the supplier will be maximally barring that the temperature will be achievable. Thickness will be from 80 to 40 mm. And production of high strength plates with low roll separating forces and with low alloy steels. This super accelerated cooling is done, but still we have not designed the changeover of our stands. The stands will be still having the roll separating force of 4,500 tons. The classification of TMCP is its temperature control cooling. These are different types of operations during rolling operations. Thermomechanical control process, direct quench and auto temperature, and super cooling system. Comparative microstructure. The first one is the as roll condition. When the finishing roll temperature of the product is normally air cooling is done, and that's the microstructure what we use. For the TCR temperature control rolling, and the last one is the TMCP. What will be achieving finally by the super accelerated cooling, the fine grain structure. The process will be comprising of the reheating of the slabs and the reheating furnace. You have got 3 reheating furnaces, all are pusher type. And
Rolling of slab to desired thickness, controlling the temperature during loading. This technique saves us from rolling at finishing at lower temperatures. Online water cooling of rolled plates and subsequent air cooling of the plates. The methodology behind this is will be achieving ferrite grain size, volume fraction will be a consistent base, distribution of these will be proper, laminar spacing in the ferrite is being will be decreasing, size and distribution of precipitates and dislocation density will be. This is a comparative of the ferrite grain size and properties. As the grain size reduces, it will enhancing the properties. And the the ferrite grain size versus the yield strength. Superaccelerated cooling and the grain size, it will refine the ferrite grain size, increase the inter-granular ferrite nucleation sites, decrease the ferrite grain growth rate, uniformly distribute the ferrite grain of ferrite and ferrite. This is the same thing of the theoretical concept of accelerated cooling, where niobium precipitation will be using for distribution of nucleation. Niobium precipitate prevents obstinate grain growth, and that itself reduces the transformation. And as we can see in the time temperature transformation diagram, PTV diagram, if we replace our cooling rate where we pass it the nodes of the 2.7 PTV diagram and go into the Banach section. And it is all fine stuff. Carbon isolate particles maintain time oscillate grain size and microalloy takes into solution which can be improved process. Once in the improvement below the required temperature about 900 basically, when we are not having a super extended cooling, we have to go to the 870 to 850 degrees centigrade temperature, finishing rolling temperature. That will have a margin of say going to 900 plus, 910 plus. And strain-induced precipitates of niobium carbon is sufficient to prevent reflection before the next pass, also providing reflection sites. Regarding the accelerated cooling, increase the strength in the product both by refinement of the structure and by generating smaller and more effective microalloying particles. Now, how we are going to develop the superaccelerated cooling in Bilai steel plant? The Bilai steel plant is a 3,600 barrel length. Maximum what we can roll over here, the width is 3,600, 3,200. It is designed to roll plates of thickness 8 to 120 mm and the input slab size of 3 depending upon the caster. We have got 6 casters in SNS2, steel weighting top 2. And the maximum size what we have, the thinner size is 250 into 1800. And the grades what we are handling is mild steel, boiler quality, high tensile, and naval DMR grades. The rolling process, there's different stages of the rolling process. The slab conditioning by scarping and grinding. The hot charging we are not scarping, we are taking directly from the caster. Preheating of slab in the furnace at desired temperature. Rolling of slab to desired thickness at rotting and finishing stand. Control of temperature of plates during last finishing pass at finishing temperature, which after the super accelerated cooling we can be achieving say 900 plus, 910 plus. Online water cooling of plates by cooling devices after finishing and rolling at lower temperature. Subsequent air cooling in the cooling beds. For the slab conditioning, slabs are conditioned by scarping or grinding before the preheating. Preheating to remove surface defects such as non-metallic inclusions, longitudinal cracks, spider cracks. In the reheating phase, slabs are heated in a pusher type furnace what we are having. The fourth furnace which has been proposed will be the walking beam type in plastic plant.
to a temperature of 1150 to 1300 degrees centigrade. And what we are achieving in the pusher type furnace are the skid marks, possibility of emptying the furnace in case of mill breakdown. In the next stage, after the slab is being heated to the desired temperature, the rolling, depending on the product mix and required output, it will generally have one or two reversing stands. It's having rice plant is having two reversing stands, the roughing and the finishing stands. Both are four high reversing stands. The first is either the first is four high, both are four high. The high pressure water spray for these are the hydraulic descaler. The descaler we are having 160 bar pressure. Modern plate mills are characterized by high stiffness, determined by large backup roll diet, large housing areas, and housing weights. This is the complete layout of a furnace, charging system, furnace, and the mill only, not the finishing section, where we have a descaler, then the roughing stand, where the width making is being done. We are having transversal as well as longitudinal rolling at variety plant. Initially, from the slab, we are doing the width making, and then finally to the thickness, and roughing stand and the finishing stand. This is the absolute material flow of the Village steel plant. We are getting slab from continuous casting and the reheating furnace from the depilers, the reheating furnace, then the descaler, then we have got a vertical edger to get the top coat shape, then the roughing stand, then the finishing stand, and accelerated cooling system, and leveler, inspection beds, and the finishing section is having side trimming chairs and crosser chairs. And finally, after the inspections, we are filing it to the dispatch sections. The target industries for our products will be boiler and pressure vessels, construct, infrastructure and constructions, heavy machineries, automobiles, and shipbuilding. In the construction industry, what the demands are mainly improved strength, enhanced toughness, enhanced impact strength at 0 degree, and improve corrosion resistance and improve weldability. These are the special rolling technologies, techniques what we are doing. We are temperature control rolling. We have a separate normalizing heat treatment process, isothermal heating of slabs, and controlled cooling. Existing spray cooling system, what we are having is laminar cooling situated just after the finishing stand. We have 11 cooling banks. Depending upon the rate of cooling what we desire, we open alternate banks or as per desired, the rate of cooling what we are desiring. 11 cooling banks are there, 4 terminal laminar flow types and top headers, post spray type bottom headers. Total quantity of water is 5,000 liter cube per hour and roll table speed is 0.2 meters per second.
कितना लंबा खींचेगा
These are the just a model diagram of the
व्हाट्सएप नहीं
same.
भेजो अकाउंट नंबर
Later on, I will show you the super insulated cooling.
मत नहीं हो
These
रहा
are the spray bags, but for the super insulated cooling, we are making a tunnel kind of a cooling arrangement. The cooling for the cooling arrangement for the primary, there are four primary variables. It depends upon the cooling rate, depends upon the grade of steel what we are going to use, the thickness of the plate. The thinner the section, the faster we can take it out and the transformation will be fast. Finishing temperature after rolling, that is also an important factor. And the final temperature of the final temperature what we are going to achieve after cooling. And the secondary variables are the quantity of water depends upon the number of cooling banks which will be in operation and the duration of cooling will be dependent upon the roll table speed. the super extended cooling, what we will be getting. This is a diagram from the Malvik system. This will be a tunnel kind of arrangement on the roll table. It will be completely enclosed and spray back will be from the all sides. And this is the TTV diagram what I was showing. As we miss the nose of the thing, and what we intend is that we should get a completely vanity structure to get the desired toughness. That's all. Thank you.
Any questions from the audience?
Audience, with audience. With audience or camera.
Thank you, sir, for giving insights from a old mill and upgrading to the new mill. So, Malpig you implemented or
Probably will be ending up with the Bentley.
Okay. We have Malpig system in our plate.
Okay, right.
Thank
you,
you.
brother.
16. So, here. So, this HSLA sweet plate attribute, what is the UK's ratio you have?
Since we were always going for the mild steels, 250 IS 20620 250. Now the market is demanding the base quality which to be high tensile 350 now. So we'll be achieving somewhere around 400 450.
Yes, ratio was as you are adding the nitrogen. Is strengthening. So how it is behaving versus the UK's
Basically, sometimes for thinner sections we'll be using vanadium. Because niobium will be giving problem in the solid solution. It will be precipitating for thinner sections. It is normally used for pigs where 12 over pure.
Your question on why is the UTH ratio, they maintain around 0.95. Like he said, the current requirement is going from 350 is the base level. People are asking at 650. 650 and DMR, there are many defense requirements. Actually, Indian government is lot of into make in India defense segment. So there are huge requirement in terms of ballistic materials, offshore, again, wind facilities. So these plates require high ISO so combinations, right?
We are having same height and all. For that we have achieved at least 550 here.
Okay. Thank you.
Right, thank you.
Sir. Our next presentation is from SAIL-ISP by Mr. Ritesh Kumar. Ritesh Kumar from SAIL-ISP.
Good evening, sirs. Myself, Ritesh Kumar from Medicine 2 Department, SAIL-ISP. So, first of all, here I am to discuss about the preventive measures that we took for safe workflow track in placing it. So, before that, I will go for this. So, before specification, our mill is 2250 with 3 million ton capacity slab weight and coil weight is 2.94. We have automation level in furnace and mill and level 3 automation in material system management system and at SAP level we have level 4 management. Level 4. Coming to the product input, we have slab with thickness from 200 mm to 300 mm with length 5 to 11 meters with coil from 1.6 to 25.4 with width of 725 to 2050. We have two furnace of 300 tons capacity each Then we have an hydraulic scale breaker. You have scale free rolling with an 240 bar pressure. Then we have a 4 high roughing wheel stand with automatic width control. There is a short stroke during the fight, and when the tail is off in the roughing wheel stand, so as to get the head and tail in a dog mode to prevent the fishtail and fishhead. Thereafter, we have a 7 4 high tender mill finishing stands with maximum load force of F1 to F4 50 meganewton and 40 meganewton for F5 and F7. We have a 1 to 4 pair cross with mill stabilizer and workload shifting from 5 to 7. Thereafter, we have a 12 bank arrangement for laminar pulley. Thereafter, we have a 2 down coilers with there is an automatic polishing of pinch rolls. And with wrapper roll, we have a quick response system to prevent the slip marks in the coils. That's the introductory part. Then I will directly shift to the presentation there. So, last year we have faced the falling of workload. Case one is there, the bottom work roll retracted without taking the top roll assembly. The second case is that there is a slot where the top work roll sits on the bottom work roll. The top work roll didn't properly down at the root made on the bottom work roll. So once it came out from the chalk point, it fell down. That incident took around 4 hours 45 minutes. That was a huge production loss. And this is the idle work road retract where the top work roll exactly sits on the bottom work roll and it comes out. Generally, there is no manual intervention or steps or auto, so this process can't be controlled if there is such kind of situation. In a workload retract, we have a push puller cylinder that goes forward to the wheel using a latch with the bottom workload and pulls it out and baseline goes down. After that, top workload sits on the bottom workload. So that it keeps on the reverse command and comes out of the wheel. So this is the flow chart. Forward command is always there till the target reaches the 7500. Then at 7500, bottom work roll and clamps. Then reverse command starts for the retract. For each stands, we have a different target. These are stand 5 finishing where the incident actually took. So what that target is 7110. If that target is achieved, the top work roll gets down, top top gets unclamps and it comes out. So I will go through the DMAP solution. Then first of all, I will define the problem that I have already defined. Then the measuring what could be the reason. Then root cause analysis and what we have done to control it. So for each analysis, I have further defined, ascertain the facts, developing the bio analysis, identifying the gaps in the system. This is the first picture is ideal workload with the latch I was talking about, the bottom workload engages the top workload. That is the holding point that takes the bottom workload out of the main housing. So in measure we have guessed the probable causes the traverse direct cylinder position error. Maybe there could be a temposonic position error could also be due to the temposonic reading feedback of the last cylinder. Then there could also be air leakage in the cylinder, push puller cylinder leakage that due to the wrong position value. Work roll pullback command would have been delayed and the bottom work roll came out. could be a operational mistake and could also be a mechanical obstruction. So data we have analyzed that from the Mika test. So first one the top due to the false top workload down position there was an error. Due to which second was there was an error in that and it continuously hold that value. That's why the cylinder was coming continuously coming to the back position. And the third one is the top worker down position not in the group. The first thing we got that the push puller position was on the target value, but top in the latch there was a gap between the bottom work and the latch of the push puller. So we have took a decision to change the rail of the bottom work tool has rail which moves on the rail. So maybe there would have been diameter flat or false diameter would have been false. That's why it came back. So, after identifying the gas in the system incident, it should result in the thought of beginning the workload means the pusher was not holding his position. So there was a kind of means it was not position was not stable. So we have the thought of giving the workload down command at a moment when the reading is stable. Then we have decreased the tolerance value as the push puller command is always on a reverse hand. So we have decreased the tolerance of the lower limit. And then we have for manual confirmation, there was a communication gap between the pulpit as all processes in auto mode. So nobody could assess whether the top control has down in the slot. So we have in the next solution part we have added workmen there to physically confirm it and then so for the solution side the pneumatic cylinder was changed along with the tempo cylinder. Then there was a leakage in push puller cylinder, so we have changed the push puller. We have modified their the logic as all the process was in auto mode. So we have additionally given manual confirmation switch. The manual confirmation we used to get from the person who is down at the side who confirm that top is actually sitting on the bottom and there it is there it is the picture second picture and an extra stopper made in the top of the bottom workload to prevent the falling of workload. This actually means that even if such case can come at any time. So that is kind of the master thing we have did that even if the top doesn't sit on the bottom, my workload will never get fallen, provided that there is a stopper. So by adding a stopper, we have completely prevented the falling part of the road. So we have minimized our roll change delay, injury of equipment and workmen prevented. Roll falling is completely prevented. Production loss is prevented, and the cost serving for that delay has caused actually 4 hours and 40 minutes. That is a substantial production loss of 2094 and approximation. I think it's around 8 to 9 crores. So the completely falling of workload has been prevented by this readiness property. Thank you. Any questions from the participants? Yes, please.
Now you have done this modification of all these plants.
No, sir, it has came with rigorous observation that we were facing such problems quite often. But the two major incidents that Vernon came out That was like 30 minutes delay. Then we were managing such problems by manually doing. After means like 2 to 3 days or a week, we have added a stopper in one of the standings FI. Then we have completely replaced 5, 6, 7. All finishing stands were in between at the stopper and at bottom of floor.
Without any manual intervention, there is no automatic sensor because your need is a complete automatic.
Yes, sir.
You are made it semi automatic.
No, there is no means just we have walkie system. Just we put on the light and just check whether the roll has set on that bottom of the job. And just communicate in the walkie, and then there we have added in HMI manual information. Once pulpit operator gets the message from down there, he clicks that, and from there itself the process starts in automatic.
ओके चलो सर सर मेरा क्वेश्चन है कि जैसा आप बता रहे हैं उसमें क्या टॉपिंग पिन पे है टॉप बॉटम रोल
Could you please repeat the question?
आपका जो सिस्टम है
हाँ
बॉटम और टॉप एक के ऊपर एक है रोल है प्लेस है
हाँ
तो क्या टॉपिंग पिन नहीं है मेल फीमेल होगा टॉपिंग पिन से टॉप में टॉपिंग पिन रहता है और बॉटम में जनरली होल रहता है ताकि वो पोजीशन पे आ जाए
yes yes there is.
दे दी है फिर उसके बाद क्या स्टॉपर का जरूरत है अभी तक हम लोग भी इस तरह का कॉन्सेप्ट यूज करते हैं लेकिन जो आप बोल रहे हैं कि रोल मान लीजिए जैसे मिल से आउट कर रहे हैं टॉप आ गया बॉटम में या बॉटम आ गया टॉप आ गया ये केस जनरली तभी होता है जब बेसिक साइड से लॉक नट में कुछ प्रॉब्लम हो कुछ इशू लेकिन जनरली तो ऐसा होता नहीं है
नहीं ऐसा सिचुएशन फेस किया ना अगर टेम्पोसोनिक रीडिंग हमें गलत शो कर देगा तो वो तो किसी भी पोजीशन पे आके रुक सकता है. स्लॉट टॉपिंग पिन जो आप बता रहे हैं वो आगे भी रुक सकता है पीछे भी रुक सकता है. और अगर उसे उसे वो डाउन कमांड ले लिया तो ठीक है. अगर वो कम्प्लीटली पुश पुलर का हमारा रिवर्स कमांड रहा तो वो तो बाहर आएगा. If the roll is down to the bottom, it will take the top along with bottom and top will come, and once the top का clearance निकल जाएगा तो वो तो गिर जाएगा.
तो होल में एक सेंसर लगा देते हैं जब तक राइट एंड फीडबैक पिन का तो आगे ही नहीं आएगा
होल में किस टाइप का सेंसर वो तो मतलब रोल निकल पुल आउट होने के बाद फिर वो ग्राइंडिंग के लिए जाता है फिर टेक द सेंसर आउट इट विल मेक द प्रोसेस टीडियस.
नहीं आप पिन में सेंसर यूज नहीं कर सकते हैं लेकिन जो होल है फीमेल पार्ट है आप उसमें यूज कर सकते हैं ताकि आपका जो फीडबैक सिस्टम बेसिकली फीडबैक के कारण आपको दिक्कत हो
राइट.
आप एक बार फिजिकली देख के सोच सकते हैं
Okay, we will do, but this is what the most convenient and easy that we have thought of immediately.
Yeah, thanks, Ritesh, for well explaining a good problem case or solving case. You can also discuss with other hospitals because this type of case normally doesn't happen. But still, you can take up this inputs. Yes, thank you. Thank you.
Next presentation is on waste management of incoming regenerated exit by Abhijit Anand from SAIL-ISP.
Okay, good evening all the delegates of RMOC. I am Abhijit Anand from Bokaro Steel Plant and I'm glad to share my work at this forum. So this will be the overview of my presentation. The first there will be the title, then the process involved in the cold room mill, then the picking process, the role of acid circulation. Then we'll discuss our problem and then we'll see how we came to the solution and then the implementation part and then few checks of implementation on site and the analysis and then we will conclude the presentation. So the title of my project was Waste Management of Incoming Regenerated Acid slash Fresh Acid in Inline 1 of CRM1 So first of all, I think we should know what is waste management. So waste management is nothing but the procedure of action required to manage waste from its inception to its final disposal. So once any product reaches its primary use, it's enter a waste hierarchy cycle. So this is a waste hierarchy cycle, which comprises of 5 stages, in which the first 3 stages are preferred one and the last two are least preferred. So my work is also related to the first stage of waste hierarchy. The first stage, which is review, it tells us about the efforts which are done to reduce the toxicity or and as well as the volume of waste generated. The second stage, reuse, encourages us about to what find the alternative use or you can say the secondary use of the waste product. The third is recycle, in which involves the processing of waste into a new material. So these are the processes involved in the cold roll mill technique, which we use for removing the surface impurities like rust, steel, dirt. The second is cold rolling for achieve the precise thickness. The third is annealing, which soften the metal and relieve the internal stress produced after cold roll. The fourth one is temporary for improving the surface finish. Sugar technical activity of the seed. So this is the process flow of CRM. That was a fast through painting for the surface treatment. Then cold rolling diamond with the 4 high stand then. Then it is annealing, wood annealing, or you can say the batch annealing. And then it is temper skin casting, which is a single stand, single high, two high. So, so this is the process steel pickling, which is a metal surface treatment process to remove the impurities like dust, oxide, steel, dust, anything. And the rule of acid circulations become an important parameter to judge the efficiency of picking process. So three things are very important in acid circulation. The first one is the flow and circulation, which ensures the you can say the replacement of which ensures the maximum reaction between metal strip and acid. Then second is the heat exchange. The optimal temperature for picking is around 80 to 85. The heat exchange system is needed for maintaining that temperature. And the third is monitoring and control. The automatic system is to monitor to control the flow rate, temperature, all those things. So this is the basic schematic of my acid circulation unit. The next level one and two. So we have three overhead tanks, three different tanks in which the liquid are stored. The heat exchangers for heating the filter walls, motors, the cascading pipelines through which the acid and recirculation tanks are delivered. And then the recovery unit which the vesicle liquor are converted to the regenerated acid. So this is the filling mode. When we start the line, we simply push the filling mode. Uh, for it on the filling mode, it from recirculation tank, go to the filling tank where the actual contact between AC and metal strips occur. So as you can see, the filling box is open. The drain as well and the recirculation box are closed. The second is drain mode whenever we have to when we know that we have to down the line, so we press the drain mode. Exit from picking tank simply comes down to the recirculation tank. And this is the recirculation mode, and we know that there is a down for 2 hours, 3 hours, or 4 hours. So we simply quit off the drain mode also. So it's the thing running in recirculation tanks so that the temperature can be maintained and we can start the line on time. So what was the problem we were facing? So to maintain the active concentration in plants, so when people plant seed, the level of plant becomes high and it instantly goes down with gravitational cascading to the subsequent times. So the level of gradually increases after cascading of acid, but it takes around one and more than 1 hour, right? Because of because it is driven by gradient And second, the cascading pipeline was of 100 diameter. So but what happens sometimes means just after taking this, some emergency comes, just like means skid breakage happens or side cracking of sheet in loopers or any equipment failure happen. So we need to just stop. We need to stop the line because overfitting of sheet or metal skid will occur. So, but what we do? This will lead to the overflow condition in the circulation tank 3. As you can see, after taking place in tank 3, the level of tank 3 is more than what it is in tank 2 and tank 1. As you can see. And if we rain in that condition, see what will happen. If we rain in that condition, the topmost level in tank 3 achieves earlier than what it is in tank 2, and the overflow of the acid will occur. So before coming with solution or anything, we just see the repercussions of acid spillover, environment harms, the contamination of soil, water bodies, which will lead to or result to the long-term ecological damage, the health risk, the acid exposure to us or our neighbors, the economic cost for cleaning up or simply neutralizing it. Corrosion of infrastructure affects the payments of motor costs beside the tap. And the last one is legal and the compliance issue. As you know, nowadays these things are quite I think prominent that if we do anything like that, their hefty fines are upon us. So we discussed this problem with our peers, and the solution came up was very simple. The solution came that make the RT3 level and same as before taking RA. Means before taking RA, how much level it should be same as that. The overflow or the spillover condition will not occur. As you can see, after taking the RA, if the level of recirculation tank 3 is high. If we somehow do that to the next step, what are shown in there, spill over if you the flow will not happen. So, uh, but how? How we can send? We cannot send back the exit from RT3 to ARP. Why? Because of the technical requirements. Because in RT3 the iron content is around 18 grams per liter, I think. And for AC3 generation, the optimum iron content needed is around 120. So we cannot send it back to ARP. And traditional cascading takes time, as I mentioned before, 1.5 hours to 2 hours. So, what was the option? So, post cascading is one option. So, how to do the post cascading? So, installation of motors, all these things will be a costly affair. So, what we did, the solution we put up was, you can say, very minimum drive. So solution we connected the pipe of RT3 to the RT2 recirculation tank, and then we again connected the filling pipe of the recirculation tank to the drain pipe of recirculation tank 1. And then we send the WPL to ARP from recirculation tank 1. And in stage 4, when the WPL sent to ARP equals the RA taken, we drain the tanks. So as you can see, we have joined that filling pipeline of recirculation tank 3 to the drain pipe of recirculation tank 2 and filling pipeline of recirculation tank 2 to recirculation tank 1. So as you can see, the level of the tank 3 is coming down and it just comes down in 5 to 7 minutes. And when the level reaches at what is in recirculation tank 2 and 1, you can simply drain. So without spill over, we are overcome the situation of spill. So these were some of the tricks of implementation on site. We have simply connected a pipeline from filling pipeline of RT3 to the drain pipeline of RT2. And these were the results. These results show that the factors which simply the ones the acid consumption in taken line. This is how we calculate the acid consumption in pectin line. So as you can see here in the FY 2021, 2021 and 2 and 2022 and 23, as you can see, it is more than 5 kg per ton of acid consumption. But as you can see in 23 and 24, it came down to below 4. So the one of the important factors for more consumption was this air spillover. So we overcome that problem, and we can simply see it in a graph or result that is been very effective. And one of all the parameters of this, if any spillover occurs, we have to neutralize before sending into any water body. So as you can see, the caustic soda consumption, it also has gone down. So these are the technical parameters with what we have to maintain in tank 3, tank 2, tank 1. The WPL specification, you can see the optimal and optimum WPL specification for our production, very content 120. So this is the analysis part. Let's whatever rates we have to what relates to FA. So F some form. So FA own cost, FA transportation cost, FA preparation cost. This FA is at 25 as own temperature. So again to go to the picking temperature, we have to invest some energy. Then for transporting that FA to the direct place to ARP, we have to put some uh, money. So these are the tangible costs we can see. And there is a small analysis. If 20, if we take 20 meter cube of RN, as what we do is for processing 500 tons of steel in pickling line, we take around 20 meter cube of RN. So if steel goes up 3 times a day, 20 to 50 cube of RN will be placed. From that calculation, you can see that 0.225 kg per ton of steel produced the waste will be there. So we can overcome this. I've also made the standing operating procedure for this, and this was pretty much accepted in our department. These are the conclusions since effect consumption and picking as a direct relationship to the environmental, social, and governance consideration. As you know that this ESG is quite vibrant now. It's a global framework for sustainability report of a company. Now the days of when investors are not seeing the financial report, they are I think seeing more than financial report like sustainability report of a company. And when it comes when in like directly reflect the environmental trend, social responsibility and government practices. By prioritizing these measures, our company can achieve the goal. So thank you. Thank you. I think I've explained it well.
Yeah, thank you, Anand. And you do presentation in detail and all the concerning as well. Thank you.
Our next presentation by Mr. N.K. Singh from SAIL-ISP.
Good evening, everyone. I'm Mani Martin from RTR Training and RTR Training. I will be giving presentation on optimization of cooling bed efficiency by implementation of innovative post cooling system at treatment of Rockilla Steel Plant. This is the layout the new technique at Rockilla Steel Plant where this system has been implemented. This is a 4.3 meter wide uh, by single stand reverting mill of 1 million ton capacity. There is reheating furnace. The slab from steel melting shop is primary from caster tree from active plate mill. Then there is a primary scaler. Then there is a finishing mill where the roughing and finishing process are done. Then we have accelerated cooling system for TMCP, hot leveler for the leveling of plates at around 500 to 600 degrees centigrade. Then there is a cooling bed. After the cooling bed, there is an inspection bed, and after the inspection bed, there is an ultrasonic testing machine. Online audit. The new technique is basically come with the plates with demand of plates with high ultrasonic testing. The the plates of the of new plate mill are highly demanded because they are tested ultrasonically. Mostly in the range of 240 mm plates. But the bottom line is that the temperature of the plates actually bend. If the temperature of the plates is higher than 80 degrees centigrade, then the pores of USP it gets damaged. So the plates are generally poured over the cooling bed, and we have to stop the rolling at the finishing mode. And due to this, last year there was a mere stoppage of about 27 hours. To address this stoppage, we have come with a solution of automatic phone storage system introduced before the following USC. The main benefits the investors were improve the productivity of online USC and anything like reduce folding time at cooling rate, improve service periods of higher unit. We have uh, we have taken a target to reduce the temperature of the plates by 40 degrees centigrade with using a water flow cooling rate of 10 degrees centigrade per hour. We installed this cooling system between the cooling bed and inspection at connecting unit in inspection unit and the this is a design of the force cooling system. The main targets as we discussed that higher thickness of the plates require USC tested 10 to 40 mm. The plate length considered taken for this work is 6 to 12 meter, and the speed of the roller table was 1 to 2 meter per second. That is the main feature of the force cooling system. You can see that we installed a structure for the top headers. And then when we cut, they are pretty going to the floor. Facing the bottom header. There was we installed a water tank in pumps with a supply water with 200 liters per hour and 4 to 5 liters by 4 to 5 bar. Then we installed a training filter of filtration level up to 50 micron with capacity of 150 meter cube. We have ensured a minimum flow line so that if the pump is on and there is no requirement of force filling, then it will complete to the requirement. So we have then there is a pattern, we have placed the parameters to measure the temperature of the plates after the force filling. Then we have placed the wipers after the police so that the plate water will be not there after the plate. So we're using a water. And lastly, we have installed a slurry tank. It's slurry pump just below the this system. This is a header design of top header and bottom header. In this structure, we have made just between the cooling bed and inspection bed. As I discussed, that top headers with this structure, we mount the top headers, thus covering all the width of the plate, and between the two rollers, we have we put down the plates. We insert the bottom headers. This is a scheme of postal system. The first water supply unit is come. It goes to a plain water tank. It is of capacity of 500 K. Then is the wall. If the which is connected to the level sensor high and low. If the water level is low, then the wall will on. And water is on. It gets high, then it is low. After the plate derivation is typically paper. It is used to ensure that the roll is not froze in block. Then there are two centrifugal pumps. One is by standby. Cases of capacity of 200 meter cubes per hour. Then there is a one which is connected between the system, the main system, where the top headers and bottom headers are installed. This other one is installed to ensure that when the pump is on, the lady drop off and then to go it the plate it will fall and the water go back to the tank. You can see the top headers and bottom headers. The plates there is a plate metal detector. On detects the plate, the top and bottom header starts on, and after the plate speed is 1 to 2 meter per second. And to ensure that the plates of all the length that would be is at least 80 minutes. The water is on up to 2 minutes. And after the clearing part, the water is get accumulated in the slurry tank. And from the slurry tank, they will install a slurry pump. And from the slurry pump, it goes to the receiving system of the plant. Yeah, that's all. This is a picture of only where the system is installed. This is the you can see the straight headers. On the second thing, there is a gap between the rollers where the bottom headers is installed. This is the pumping pump tank. We have installed the fire meter. Then after the post conversation, and we measure the temperature. Initial temperature was nearly 145 to 180, 185, and the final temperature just literally force you can see the temperature, where the temperature of 50 degree. 50 degree. However, when it goes main inspection, near the USPs, it goes below the 80 degrees and go. Yeah. So this is the benefits. Trials were conducted the system in technical reduction rate in which it leads to the reduction of 70% reduction in delays, and it also reduces the ultrasonic probe consumption by 50%. This all modification leads to the financial benefits of 4.5 crores. We use for different networks. And then you can see I have a and the communications when the rain. Yes, you don't need to have a separation rate. So there is the so we have also worked using this solution. Yes, yes. So is there any problem talking insurance? No, no. Because we are given this latest components, this models, so right, owning cases. We are not we are not informed. Yeah, okay. So coolness perfect. Yes, sir. Design temperature, I all of my what you get here. So because we are targeting another project this time. Yes, that's what I feel also we have. You are well. Aagi hoga provided thank you.
Yeah, I have one question.
Yes.
Was there any impact on shape of after the cooling period?
No, actually, water is wiped out. They are wiped, and also
So in terms of shape. track has any change? If
No,
it's,
no,
the blade is coming at high temperature and suddenly
no, because we can see the message. The temperature is 100, 200, it has 200. And if there is no test of temperature of plane is below 200. But before online class, you are taking it carries negative stress.
so other thing you said only 70%. Go to the next slide. So why not 100% when you're able to achieve? You have to have only 80% plus achieving. Why it is only 70%?
There are some places with higher thickness. They are more inclusive. So, we could not, they are very, very close.
Is this in-house design or
Really in-house? Completely in-house. Yes.
good? Very good system. Good, Kaizen.
Thank you.
Thank you.
Thank you.
One last presentation by Mr. Ravi Kumar from JSPL Ahmedabad.
गुड इवनिंग ऑल मैं एस वन नाम से तो हमारी मिल काफी नई है जस्ट एक साल पहले ही मतलब हम लोगों ने 23 दिसंबर में फर्स्ट कॉल निकाला था एंड तो ये हमारे टेक्नोलॉजिकल पार्टनर्स और ये हमारा लेआउट है विद 3 RHF एक सिंगल स्टैंड अपना सिंगल स्टैंड R1 है R2 है ये दोनों 2 है R1 2 है R2 4 है सेवन स्टैंड अपना रिच वॉल सेवन स्टैंड फेसिंग मिल है लाइन 3 डाउन कॉलर्स इसमें हमारे कुछ नए इक्विपमेंट्स लेटेस्ट इक्विपमेंट्स हैं जैसे कि ट्रांसफर बार कूलिंग सिस्टम HI बॉक्स आई थिंक मोस्ट ऑफ द एडजस्टमेंट्स में ये है कॉइल बॉक्स एज हीटर ड्रम्स हियर सेकेंडरी बी स्केलर F1 एज है तो F1 एज है और एज हीटर एंड ट्रांसफर बार कूलिंग तो अभी हम लोगों ने ट्रांसफर बार कूलिंग को 8 mm एंड एवं यूज करते हैं जो कि हमारा टेम्परेचर को इन्फॉर्म करता है and F1 measure for uniform width dimension width here उसके लिए है and edge heater अभी हमारा अंडर कमीशनिंग है तो एज हीटर आने के बाद 1 mm तक रोल करने के लिए आप होंगे अभी हम कमर्शियल 1.2 mm का प्रोडक्शन हमारा दिसंबर 23 से जनवरी 25 तक का ये प्रोडक्शन है और उसके हिसाब से हमने इस मंथ में 1.6 एंड बिलो जो परसेंट रोल किया है जैसा कि जनवरी में हमारा 19% है इस हमने 1.6 से बिलो में रोल किया है एंड द नेक्स्ट प्रोडक्शन 1,64,000 के आसपास में जो इसमें हमने पब्लिश किया था तो ये हमारे हाइलाइट्स हैं और इस में जो इस मंच पर आकर के हमें जो आपके आइडियाज मिले काफी नहीं मिले तो आगे हम लोगों को काफी चैलेंजेस मिलेंगे और इन आइडियाज को हम लोग इम्प्लीमेंट करेंगे थैंक यू
I have some questions.
Oh yes sir
क्या फिट में बनाते हैं आप लोग
अभी हम लोगों ने 1.2 मेथड के एवं तक है इनको 50 किया है
मशीन मिल से ट्रांसफर बार कितना लेते हैं 1.2 के लिए
33 to 34 है लेग हम 4 to 12 मीटर तक भी लेते हैं
ये जो हीटर में कितना टेम्परेचर
ये हीटर अभी कमीशनिंग नहीं है बट एज पर विलियम्स फ्लैट 20 डिग्री तक हम टेम्परेचर रेंज कर सकते हैं ये डिपेंड करेगा ट्रांसफॉर्मर की स्पीड एंड थिकनेस
1.2 का क्या मैक्सिमम प्रोड्यूस है नहीं
250 yeah
Sir, what is the plan? Do you call box for all sections or thinner gauges के लिए सिर्फ call box यूज करते
नो हम लोग जनरली कॉल बॉक्स यूज करते हैं या तो ट्रांसफॉर्मर हमारा काफी ज्यादा लंबा है इसके लिए अप्रॉक्स 70 मीटर से अब हम कॉल बॉक्स को यूज कर लेते हैं 70 मीटर से बिलो ट्रांसफॉर्मर हम लोग कॉल बॉक्स यूज नहीं करते क्रिटिकल ग्रेड्स जैसे हम 1.2 एंड सीलिंग यूज करते हैं 6 एंड बिलो कॉल बॉक्स मस्ट हम लोग यूज करते हैं
ट्रांसफॉर्मर कूलिंग वाला कब यूज करेंगे
ट्रांसफॉर्मर कूलिंग भी अभी कमीशनिंग में है मोस्टली हम लोग इसको अभी एपीआई वगैरह के लिए यूज कर रहे हैं क्योंकि हमको एटम एंट्री में टेम्परेचर काफी कम चाहिए इसके लिए
आप लोग का you have this hot lighting slabs
हाँ 70%
अभी हो रहा है
हो रहा
मतलब what is the temperature of the slabs
है 450 to below 450 माइल
ना 450 मतलब आपका कास्टर से डायरेक्टली
बिल्कुल कास्टर
उसमें 450 आ जाता है
अराउंड 450
मतलब ये सब रूलर टेबल से डायरेक्टली कनेक्टेड विद द फाइनेंस चार्जिंग रूलर टेबल और व्हाट इज द
नो कास्टर ओवर टेबल से डायरेक्टली और
आपका कितना कास्टर है
भी सिंगल कास्टर है फोर स्ट्रैंड
दोनों स्टैंड तो ये दोनों स्टैंड से तो दोनों तो कनेक्टेड मतलब इज देयर अ ट्रांसफर व्हाट इज द मैकेनिज्म
ट्रांसफर ऑल
बीच में एक ट्रांसफर टर्निंग है उससे 70% यू आर डूइंग हॉट चार्जिंग उसमें आप कॉफी चिप कैसे मेंटेन करते हैं
पॉसिबल नहीं हो पाता कभी कभी हम एनुअल ही ज्यादातर देख सकते हैं तो कुछ ओल्ड चार्जिंग हमारा स्लैब रहता है पहले से तो हम कॉपी कर लेते हैं कुछ ओल्ड स्लैब डाल
इसमें शेप या प्रोफाइल में कुछ इफेक्ट नहीं आता है व्हेन यू आर नॉट एबल टू मेंटेन दिस कॉफी शेप
नहीं कॉफिन मतलब हम या तो पैरेलल शेड्यूलिंग करते हैं या फिर कॉफिन में करते हैं अगर हमारे पास ओल्ड स्लैब्स
नहीं आप 70 वीडियो से 70% का हॉट चार्जिंग है तो उसमें तो कास्टर में क्या यू मतलब ऑनलाइन विच चेकिंग कर रहा है
बीच चेंजिंग भी करते हैं सर और बीच में हमारा कुछ टेबल स्टार्ट करने के ऊपर स्लैब्स भी ओल्ड स्लैब्स डालते
You are right. We are having issues with sale because compensate is maintaining कर पा रहे हैं. We are it's because अभी it's a new mill and is running at only one third of its operating.
That's new mill, that's why we
अभी जुलाई अगस्त के बाद but after that we'll have mill cases, two tin cases, which can be have this file hot slab transfer. So yes, four slabs.
अच्छा what is the even for the old slabs what is the mechanism by using crane to chugging or
Sorry.
you understand it as well what is the top shear है what is the maximum thickness of transformer that it can cut
48 mm.
So you will be rolling 25 what is the maximum thickness
20 mm.
20 mm. So why you have selected only 48 mm? If you are planning for API and other grades,
That's it.
why you are only limited it to 48 mm?
The Coxier maximum cut capacity.
He is asking why thicker,
Why not
choose the
why, even if you are making 20 mm,
Say API, you will require around 50 mm.
No, sir. We are not able to cut 60
Why? That is my question. Why you have limited the capacity of the crop share to 48 mm? Since you are going up to 20 mm, at least second say.
No, no, I don't have it. Yes, yes. It should be ideally 60. Because if you want to have API, plastic has API as well as Martin said steel also. So
That means this API, XAPI and all those things will be limited to 16 mm only.
we have to check. Your product for the year? 20, yeah. The API.
Okay, 16
16 30.
Then API will be restricted to 16 mm.
We are supplying API through plating also. Thicker. So thicker we are doing there, thinner we will do. Maybe that is the reason why they are.
And after the coiler, you have this evacuation line. You must be having a sample inspection, physical inspection as well as sample cutting.
Yes.
Up to what thick you can cut samples.
So usually we are able to cut 16
And what about roll above 16 mm also?
No.
You plan to roll above 16 mm up to 20 mm. So what is your plan for cutting of samples for say 20 mm?
Actually, the OEM has contacted or to increase the capacity of CFR. But we are doing manually.
Now we are doing it manually. You have both. Can you
Already pending. And it's just offline.
Okay, sir. We'll have the discussion offline. It's a new mill. All the best facilities have been integrated into this. So people have a lot of queries. Thank you. Thank you, Ravi.
Now, next presentation is from Team SAIL-ISP by D. Pradhan, SK Day, and S. Kumar.
from the wall? Uh, we at ISP, as you have heard in the morning, we are planning to go for a 4.0 metric ton crude steel capacity brownfield expansion, and we are going for a flat. So basically, we are going for a 4 million ton hot shipment. So it's a new journey. It will be a new journey for us, and that was the reason that we are very curious to hear from you, from the flat. You are the experts. You have been in this domain for quite a long time. So we would like to it's only on the tendering stage. So there are many questions in our mind. We have got some answers from our audience. But being the practical users, mm, we would like to hear from you the real difficulties because the OEMs they always tell a very rosy pictures. So we really don't we cannot go by them because party X will say that theirs is the best, party Y will come, no, ours is the best. So you are the best judge. So my presentation will be a little different. It will be, I would like to have a more sort of questions session just not like to show you what we are going to have because you are already having those things. But rather I would like to hear from you suggestions that well you are going wrong here. You can go in this way. Should be the best way forward for you. We still have scope for changes. Which from both direction. This presentation has been prepared under the guidance of Surendra Kumar Saab. He has worked in Hot Mill, Bokaro.
He has a very wide experience. He has worked in Orchid Mill, he has worked in Universal Rail Mill, and now he's in charge. He has worked in Universal Structural Mill at ISP, and now he's in charge of wire rod and bar mill. And I have my colleague Deepankar, he's from the Pune side. And my little background is that I have been in RDCS, I was in RDCS and I was in Bokaro. So I have a little idea of flat rolling also. So that's only a little idea. Uh, then I will go on with this. So as I said, it is a 4.08 MPPA crucial expansion project. So we will be having a single blast furnace. Right now we are operating with a single blast furnace. This will also be a single blast furnace operation. We will be having centered batteries, sinter plant, pellet plant, and 4.38 GPA blast furnace, followed by three 165 ton BF converters and three single stand clusters. This will be single stand clusters, three individual clusters, and followed by a four 50 PF sheet well. We do have plans in phase two to have a cold rolling mill 1.5 MTA, and it will be only after we are able to stabilize our shipping production. So this is the major technological parameters. Our input slab thickness will be 210, 230, and 250. And width will be 900, it will be 2100, 2100, not 2050. Width of input slab will be 2100. And input length will be 6 to 11.5 meters. Maximum output is 1.2 to 25.4. It's a standard price range. 900 to 2050 with a specific coverage of 23 kg per mm max. Envisaged yield is 98%. We'll be having two reheating furnaces of 110 ton capacity, but we will have space provision for a hard furnace future. We'll be having one roughing, four head roughing, and seven finishing stands, and followed by three down colors. The mill, with the provision of an extra furnace, extra second roughing, we will be having provision for a second roughing also. And depending on the product mix, will be able to roll 5 to 5.5 MPPA. I think, this is a standard configuration of hot treatment that is being offered by most of the OEM. As I've said, this is the configuration. Two RHF with a provision for R1. We will having a provision for R1, 2i. We will be right now having one reversing roughing, 4i, followed by seven finishing stands, and then round colors. So the product mix is and envisage is the entire almost the entirety of the whole is there, including auto machines. That will be the first venture. You can say really we as a sale we are not into this dual phase and advanced asset sale. We'd like to enter these segments also. And normal grades like low, medium, high carbon, structural steel, uh, cylinder grades, pressure vessels, and definitely API grades also. Our land or our product mix will contribute 25% less than 2.5 mm, and less than 2.5 to 12 mm, it will be around two-thirds of it, that is 67%, and more than 12 mm, it will be 7%. Similarly, our major chunk will be at 1200 to 1800 range. That also will be two-thirds of the entire production. This is the proposed layout. Again, I would like to have comments on this during the later stage, maybe in the evening or during the dinner stage. I would like to have your comments on this. And this is the layout. We had some discussions regarding If the green boxes that you are seeing, those are basically the coil storage bays, and the red line is the rolling line. And if you see, the roll stock has been put in between the coil storage and the rolling line, and the ECR is on the other side of the rolling. Uh, we were deliberating whether we should have the roll stock on the other side and ECR on the basically interchange of the roll stock and the ECR. But for the time being, we are waiting for the even the OEM to come up with a proposal. This is what we are having. We will be having two storage bays for the slabs. We will be having provisions for hot charging also. All the three clusters will be connected directly. And yes, this is something we have been discussing. We have been trying uh, regarding the maximum amount of hot charging that we can do because product mix has been proposed that I have shown here with two furnaces. That product mix we can only achieve if we have 30% hot charging. So we are also apprehensive that how we will be able to achieve. Otherwise, we may not be able to achieve 4 million ton with two furnaces and one wrapping. So this is the reading furnace design parameters. As I have already told, 410 tons per hour furnace capacity. The furnace has been designed with 100% coal charging. Reference lab will be 230 by 1280, 10.5. Input slab, I've already mentioned, it's directly written 2100. Normal phone charging to charging machines. In Bokaro, from people from Bokaro or Sidmil, we have a different, the slab push-ups are there. So we were deliberating whether to, because I have visited even JSW Dolby also. So the charging mechanism we are little apprehensive whether we will able to maintain the charging using the cranes. But we are going with the cranes. Will be discharging will be to discharging machine. Hot charging we have kept 500 to 750 will be maintaining for the promotion for hot charging. Discharge temperature maximum we have kept at 1280. Another parameters like uniformity of temperature, charging rows, we are going for single charging rows. Fluid dark take will be down take. We have gone for mixed gas or alternative gas. Combination is having similar calorific value. So we are maintaining a calorific value of 2200 plus minus 100 kilocalorie per nanometer cube. So even if you are going for natural gas in future or anything, we will be maintaining this calorific value. So we are going with a scale loss of 0.6% and other parameters. This skin temperature is one aspect. We have kept our skin temperature at 60-degree temperature, research temperature max 100 degree, but some of the OEMs are saying that it is, they were asking for a higher temperature. So you may comment your experience on this also. These are the other major equipments. We have not gone that JSL is talking about transfer cooling and AGTR. We are not going for that right now. We will be having space for future provision. But other than that, almost everything we have kept. We will not be having any transfer heating system. So this year basically the slab years I have already told the slab years the slabs will be transferred from the casa slab year to the transfer class and we will be having two parallel bays in and the slabs will be picked up by overhead BOT and then kept on the charging roller tube. We have planned for slab year management system. So we have even Rautela is having this Slaviat management system. So we would like to have some information on the Slaviat management system and the integration of the system with the Casta Slaviat management system. Uh, and how it is connected with MES or cluster-based Flaviat management system directly sending data to multiple Flaviat system, or the information is arriving through MES system, because we will be having MES system also. So this information, we would, if anybody can provide, will be helpful. Sir, these are the charging and discharging. I think this is a standard question. Nothing much to talk about. Only we had some talks in when we visited Raukala or in Parsi Mill. We had some talks about bench slab getting stuck in a study table. So whether other plants are also having this type of problem or not, we, we can have an idea. We have uh, we have also a slab weighing system will be there, but how effective is that, or how useful will that, how long, because online weighing system is normally doesn't, the slab has to wait there and then then it has to be paid. And if we are having two furnaces, when furnace will be a constraint, so how effective will this slab weighing system, we need to see. So other things are more or less common. Uh, Descaler. Descaler is very important for our flat product, definitely. We will be having two pair of segmented type of descaler headers, and we have asked for a minimum system pressure of 240 bar and minimum water pressure of 200 bars at the nozzles. But I really don't know how we'll be able to measure that water pressure at the nozzles. Definitely we can measure the system pressure at 240 bar. And one point was this hydraulically or electromechanically operated sideways before the entry of the descaler. I think JSL and other mills can say, because even SM, these OEMs were saying that this facility is not normally given in the new mills. So this is the four high roughing stand, and it will be having a capability to reduce weight up to 100 mm. We are not planned for any slab sizing players, and all other features that can be there in a roughing mill, we are going for it. And let us see. These are generic type of features that is written. So let us see. Let us hear from the OEMs what they will really offer to us. Crop share, I was talking about crop share. Since my product range will be 25, we have gone up to 76 mm. So that's a challenge. Let us see. And we have proposed for in-situ blade changing facilities also for the crop share. Coming to the finishing stand, again, as I mentioned, it will be a seven number of finishing stand, and the mill stands will be either equipped with roll, walking, bending, and shifting, or pair cross roll, depending on the OEM finally comes up. And all other features of the all the latest features that are normally there. We have gone for this RBL worldwide for the fast six brand. Quick roll changing will be there, and we had seen some what we can we had a discussion with with Uncle, and they were saying that they cannot make new stand dummy. It's finishing stand, any of the stand they cannot make it dummy. So we have made specifically written this point. So definitely will be the fume suppression system and all those things will be there. So measuring valves is one area is very critical for the hot strip mill. Though all gauges have been mentioned. Today in one of the lectures And inspection system definitely online inspection system that Sai was also talking that we need to work on it to for the system to really develop and work. So it is not that something you get hold of the system and the system will give you output. So your experience, particularly the new males, your experience on his gauges, whether we should go their combi gauges and all those things. So whatever experiences you can share will be really helpful for us. Then we have the run-off solar cable and ESP cooling system. Speed cooling system we are created to design to achieve up to 200 degrees and of cooling temperature considering dual cells and other grades. We will be having age masking also for speed flatness and other things. We are having three numbers of ground color. Two numbers will be retractable type and third color will be a fixed type. And so basically, what we have thought that given the product range, we have kept one of the down colors uh, for the entire product range that is for the thicker gauges, and the other down colors will be restricted up to 1.216 mm. Basically, all the three will be capable to coil up to 16 mm, and one down color will be specifically for higher thickness. I think this speed catcher and all those things are very common things. So that coming to the this coil conveying system, here is one. Will every down color will be having a speaker curve, and that speaker curve will be putting the pulse on the pulse conveyor system, and their pellet type coil conveying system will be there. This is the offline inspection sample cutting. We are here for offline inspection as well as for sample cutting. We have asked for a dedicated facility for cutting of thicker gauges of hot-rolled coil. We'll be having a circumferential radial stacking machines followed by conveying system and yeah. Okay. We are coming to the end only, and then followed by the automatic coil marking machines. So these are the equipments in the roll shop, which will be an integral package, a part of the statement package. We will be having two combi grinders and three walk grinding machines. We are having a function for a second operator also. We'll be having a cut to length line, and it will be from 4 to 25 mm only. Okay, that's it. That's it from my side, but that's not the end. I will like to interact with all of you and get all the inputs that you can share with me. Thank you.
Thank you, thank you.
I don't think anybody will be having any questions for me. I will be having questions for you. Have I? No, no, no. It's only till now it's in the tendering stage. We have prepared the technical specification and it has been tendered out. That layout was been proposed by a consultant. That's not the final. No, it's not. We have said that you give us the final layout. This layout is just an indicative to give them idea, but how much idea we have. So we have clearly mentioned it is an indicative layout. This is based on their design experience, they can suggest different layout also based on the further discussions. Okay. Okay. So we are open for that. We are open for different layouts also. But the idea was to give the audience an idea of how much area we have in keeping the overall because we have we have already a running plant. There are some restrictions. So area availability is also very restricted. So keeping those things to give him an idea that this much area we are having. Out of it, if we can propose something else, it is well accepted for us. Okay.
What about just one question?
Yeah.
What about the corridors? You are not considering the corridors?
No, we have not considered for the farmers.
Any specific area?
Specifically, it depends. Basically, as I was asking, that depends on the thickness, how much quantity of 1.2 and those sections will be rolling. So it will depend on that. And we have thought of rather than going for a call box, we may go for a shorter length slab and adjust that. Thank you.
Thank you.
Expense is from university by one single on
Good evening, everybody. This is the chair. We are from NMC Steel Limited, Jabalpur. It's in Chhattisgarh state. You can say we are the one of the youngest integrated steel unit. That also this will be ceremony. So in earlier communications, they have asked two questions. Then definitely that NSL Jabalpur will help you in any way. For the development of level there, we had problems with the movement of growth for it. So for presentations, we cover 7 and 8 points. It's about NSL and journey so far. Technically, the out of flexible things are going features what we have produced since financial year 2024-25 and particularly the green and metal loss. Then what now we have produced in budget and then two challenges we are showing here and then the accomplishment during this 1.5 year. So geographic location is the Chhattisgarh state it's near the Jabalpur. It's 50 kilometer far from Jabalpur. It's called Nagarnath. This is our process layout where we have a 4,500 metric ton glass furnace where we cook on two batteries 67 centimeter height and one central image. This is also there, but yet to commission. Then we have SMS in SMS hot metal recirculation system. Here 175 ton to LRF 175 ton metal and things like caster having about 5 meter radius and slide reduction system, EMBR and dynamic software assembly. After that, actually, we have a two-panel furnace and single way. We'll discuss in detail. So, journey so far, in June 23, actually, we have first whole trial of the meal, actually. And we have purchased a slide from Burnpur. Then we have heated and then commissioned the full meal in June 23. And first blow in blast furnace of August 23. In August 21, we have was commissions, and 24 August actually we have produced first foil. Then on 7 April 24, we have achieved about 7 million ton of output. And in about 360 days, actually, we have achieved 1 million ton steel.
Till now, we have produced minimum thickness of 1.6 within a 4 month of company. So this is our technical layout of I will majorly focus on caster and meal. So caster has some beauties also. Like we have cycle pressing system, which is a H2 kind of balance model. Then we have its dynamic software reduction. About 38 meter of slab length we are taking up. Yes, we have a 240 meter of channel length, in which 150 meter is the static and 45 meter is the shuttle car, which moves in between the both the tunnel, and 45 meter is the common zone. So our slab output is about 90 and 70 and 55 we are doing instead of 50. And slab width is 900 to 1650. Steam speed is 3 meter per minute to 7 meter per minute. We have a thick buffer with 4 high unit in the 4 freezer with 4 high unit. So this on an average actually 1.2 lakh per month we are producing, and this year maybe 50% of total production target we will achieve. Our yield is about on an average 98.6%. But the loss in the scale actually we are using about 0.7, 0.6 to 0.7. So total now we have produced about 7 standard various steel grades covering about 18 grades actually, and totally that has been supplied to market. And still we are supplying and continuously we are improving in developing new grades. So basically the best standpoint of thing actually we have produced 600 LA, which is microalloy steel, and having a strength of 610 ETS. So this is good achievement that these actually future development we need to do it regarding to API code and PSK 46 and polymer grades. And no doubt actually IF also we need to develop as we are also equipped with RHOP. Through RHOP we will produce these these are our future. Currently, NSL is having a IMS system, integrated management system, covering a core standard and under anyway is under progress. And recently we have enacted C certificates already, and soon we will get C certificate in next month. These we have covered for the C. Total structure we are focusing now actually, and that future we will go for the vessels. So few challenges I am here actually presenting. Initially during the hot trial of the meal, actually we have faced some challenges, and it's designed for the input of hot slab. So we have purchased some cold slab from Raurkela, and then we have reiterated. So temperature was a concern actually, homogeneous temperature. So there we get a major hiccups, and then at the last actually we succeeded in hot trial. Second one major challenge in July 24 actually we have it was that our arm was totally failure. So during that period again we had challenged how we can continue the meal actually only one after was remaining. So our technical team actually they have and through the engineering support actually we have conquered that thing also, and we continue our operations without any stoppage of plan. The third thing was a challenge we have faced in developing the new grade. Like now, I have already told standard LA. So in that particular grade, actually, few months requirement was there actually somehow, but we are not achieving this video. Then we have many variables there actually. To control those variables, yes, we need to work hard actually. Then ultimately we achieve in fourth trial actually we produce this consistently standard delay. Then surface quality is still concern for us. You know, some lecture people say us we have actually we have a lecture system on lecture knowledge. What steel surface is a concern for us. Although we are maintaining the 320 bar of the scalar one, we have a specific two scalars. Before upper one scalar is before upper, one scalar is before this. Both two scalar we are operating at 330 bar and about 300 bar. Still our surface bar with other of second. So this is a cause of concern for us actually. Still we are struggling to say that the surface quality. So there is a one only like one we are maybe somebody can help us or directly or indirectly. I'm sure. So these are the key accomplishment in summary actually I am presenting here is that we are the one of the licensing for IS 184 whole sheet actually, which is essentially introduced by the BIS. Then we have received within a short span of time actually several BIS licenses and develop those grades and supply to market also. Then high strength adjustment we have developed 1.6 mm thickness product with a 1250 weight. We make the highest frequency for a grade we have produced. Then under certifications, yes, you know, so we have get certifications and see is under progress. Safety and quality. This commissioning story says that a zero accident during the commissioning actually nothing, nothing in IMS, no accident we have faced during this commissioning. And quality point of view, yes. We have one more wonderful tools actually recently January we have commissioned is the online inspection system that is going to supply with the Facet. It's a wonderful tool, I would say. It's needed some efforts to classify the defects and sort it out and they get it statistical data how much defects it's CT is covering. So this is wonderful. We are also experiencing now actually it's a wonderful good top and bottom surface quality will display statistical like display is it will give you measure thousands of defects in front of you. But it's your call actually how you will classify in better way and take a decision on your street. But yes, for our steel person, it's the much needed thing I would say for the steel person. And thank you for listening patiently for us. We are new. Definitely we are showing and slowly we will grow. And your second is required for us. And any inputs, positive inputs, always welcome. Thank you very much. Thank you.
Any question? Sir, talk about descaler pressure of 300 bars.
Yes, sir. So many people say that how it is, but yes, it is. Yeah. Yeah.
It is a 300, 400 bar pressure in primary scale and secondary is 380. Now we are operating at 350 and 300. Still we are facing surface quality issues in low carbon space.
This R1 failure, what was the reason? Was manufacturing, it was a manufacturing defect or what?
Actually, we have used R1 right from beginning to 6 months. After inspection, we have found some gear is damaged, gear teeth is damaged. So Delhi proposed us to stop the R1 because in our mill R1 is high reduction. We are giving 64% in R1. So bypassing R1 will not benefit us. But Delhi has to propose us to stop the mill. So we stop the mill. We are running with 40% sometime, but we stop almost. Then we bypass because it will take 6 months to develop that gear.
So my question was it a manufacturing defect or is what was the design fault?
It is under observation.
It is not clear.
It is not clear.
Only one suggestion, you are working on descaler project for CSC product. So to move into the community panel. That's it. The solution rise in the atmosphere and temperature. We had in our CSP
but we had completely come out of that, and he's afraid to automotive space.
Yeah, correct, sir. You have been put in right way. Actually, we are actually operating at COG. So COG are calibrated to have portfolio on here. And that also with the manual actually. So controlling the conversion is little bit difficult. Maybe the generation of scale is more, and that particular person is not able to know that. It may be one of the best reasons there. There is not. Okay. Thanks. Yeah. Thank you.
Thank you for giving good insights in the new mill.
Yeah. Thank you.
However, we had the market pricing of this product is cheapest in the country. The entire 1.6 market below this where you are the cheapest.
So this is the marketing strategy of industry actually everybody do.
Thank you.
Now the last presentation, which one of our technology supplier, generally, by Narasimha A and A. Bhatta.
Good evening. Good evening. I'm Rasulhan, representing Daniel, and with me is my colleague.
Abhishek Badra, representing the Navy in the product sales.
Okay, so it was the right tone set for Daniel, for the previous speaker having given most of my job, making it easy to speak about the new Daniel mill which they're operating. Of course, you also mentioned few challenges. But something more would like to present to you. Now you would be wondering why Abhishek has mentioned a long dimension of flat. We actually had to give you a typical presentation both on the flat and long, the particular technology that we have for flat and long. We'll see details of it. So the technology that we are talking about is direct casting and rolling. This is a little different than what we call for thin slab casting and rolling in flat. On top, I mentioned quality, strip production, Daniel universal endless, which is typical for flat rolling, with direct casting and rolling. Well, I'd like to ask my friend Abhishek, how about in your long rolling?
Yeah, it's called MIDA or minimal dynamic, or sometimes it is also called QLP, like QSP comparison with QLP quality long products. And it's the same concept which our ex-chairman has envisaged of the Tinsler casting rolling route when he was meeting some of his industry friends in USA early 1990s. And from there, the concept was replicated to the long also.
So, with this brief introduction, you can feel that Ganley as a group has a technology which is direct casting and rolling, as of course it will be sustainable and economical both in the flat as well as in the long. Now, this is a real video of our plant Shaogang Zhengtang in China, which was the very first plant of QSP2A. I mentioned QSP, which is quality reproduction, Danieli Universal Endless. So this is a plant which was a joint vision by our customer Shaogang Zhengtang, who collaborated with us. And in 2019, this plant saw the light. It is a 3+5 configuration where you can roll in all three modes. Why do say QSP QA? This is Danieli Universal Endless. And this mill can take all the three modes like coil to coil, slab, semi-endless and also in endless. And this plant has more than 90% in thinner units, which I'll show some details in the next slides. This plant was having a capacity of 2.1, but it's still operating at 2.3, much more than what it is supposed to be. Then, well, on the long side, what do you have about?
So the concept has been replicated. What happens in conventional cooling when you have a gas heating furnace, and you cut and roll the billet into the rolling mill. So in Mira, what happens? There is no heating furnace at all.
The concept of breaking furnace is already worked out. You get a compact mill, and the benefits that you get is up to 350 kilowatt hour turning per equivalent energy that you can save in comparison to a conventional mill of long product. The scope 1 carbon dioxide emission can be reduced to 43 kg per ton. You can get up to plus 4% yield in the mill because there is no heating furnace, no scale loss. A continuous flow of cast is getting rolled. So cropping and choppings are also minimized. Altogether, all these things benefits together. In comparison to a conventional heating furnace based milling, you get a capex advantage, OPEX advantage of 50 USD per ton. That's all about the Mila or the, let's say, endless rolling plant in long cost.
Well, the point that we noted down here on the scope 1 CO2 emissions, let's see what happens to the flat, which we call QSP unit. In case of QSP unit, it's the genuinely competitive, intelligent, green metal plant with zero CO2 direct emissions. And I'm glad that there is a customer in India with whom we are talking about this. And all the more the customers are also, my friends sitting here, and I'm glad to mention that when we talk of direct CO2 emissions, there is always a provision of changing the tunnel furnace from a gas fired to electrical tunnel furnace. So you can directly also have electrical tunnel furnace, or you can still have a provision of having gas fired burners of natural gas. Natural gas can be completely converted to hydrogen. You can replace the gas burners and put the electrical tunnel furnace also. So there is a full flexibility. I'm saying this because the current situation is little dicey with respect to the natural gas availability in India. There is a uncertainty about the hydrogen, what will be the cost of it. But then when you first plant now, it is to be for next 30, 35 years. So with this flexibility of internal furnace, where you can think of now as natural gas burners, upgrade to hydrogen, remove the burners, put the electrical tunnel furnaces, all this flexibility is possible. And we have also one customer in Europe where we have already got a very engineering agreement and where we'll be trying to apply this. At the same time, with our Indian customers also, we are talking on the side. Then staying on the flat direct casting and rolling, what you see on the screen are the three modes of operation. Well, this QSP on the left hand side is a queen, there is a caster, then follows internal furnace, then follows the hot strip mill. You'll appreciate that the hot strip mill that we talk about is split. We define the first 2 to 3 stands as rougher, followed by certain induction heaters in between, and then there is finishing mill, followed by the laminar cooling. And the high speed shear just before the down coiler pinch roll takes care of endless to arc the coils. And this is the typical equipment which I would like to mention. High throughput and high quality casting, the tunnel furnace with its shutter. The shutter implies when you're trying to go for two strand casters, the shutter helps to mobilize the slabs from the line number 2 to line number 1 and also helps in emergency evacuation of slabs in case of any emergency in the downstream. Then there is a descaling point, 3-point descaler. Yes, there was some point previously also mentioned, but on this side, if you see, there has been a lot of evolution, which I will speak about. Then on the far right, you'll see a wide thickness range, a thickness range of 0.7 to 25.4 mm. One mill which can take care from your needs of 0.7 mm to 25.4 mm, capable because there are various modes of operating. For the ultra thin, you can go with endless. In case of certain grades where there is a requirement of high temperature before finishing mill or certain tight tolerances like non-grain oriented or grain oriented, you'll see you still choose a semi-endless mode and of course coil to coil. Around long side unshaped means.
So I would like to elaborate the few key equipments of what a long product endless plant computer has. So at the very beginning in the upstream you have digital. Digital is a very powerful technology in terms of electric arc furnace with our special modular transformer concept called Q1. So the best case digital has very two aspects and important aspects. One is the endless track tracking system. You heat the furnace, you take that heat and you reheat the scraps from external energy to the scrap. And also this system is variable density of scrap. Scrap is a volatile market. It's like a share market, and people suffer because of the scrap price increase or decrease. So goes without saying, by choosing this endless scrap charging system, you don't have to dependency on the market fluctuation of the scrap. Digital is synonymous to Q1. Q1 is a modular converter transformer system, IGBT based, which can be connected to the weak link and renewable energy resources as the power source. Let's say I will give you an example. Let's say you have a 60 ton heat size of arc furnace and you have a 56 MVA of transformer. If there is something goes wrong to the transformer, your plant or the arc furnace shuts down. Not with Q1. In Q1, that same 56 MVA can be converted to 4 modules of, let's say, or 6 modules of some 16 MVA or 15 MVA or 14 MVA. So even if you are facing problem with one module, you can still run the plant with the balance of the units. Octocaster. No one ever thought that octagonal casting, octagonal sections can also be cast. Why was this needed? Because the idea of the Mila was to produce up to 1 million ton with single strand of caster, and we saw that with square sections, the interstitial pressures are creating huge surface tension and accordingly bulging. So we were looking for a section which can cast the product without the bulging, and we found that in between square rounds and octagons. Octagon is the section which is the most stable section inside the mold, and it was patented in 2018. Octagonal casting speed can reach up to 9.5 meter per minute. It's been patented and shown in one of our media plants at CMC, Oklahoma, USA. Rolling seminar, so cannot I talk about the rolling mill? You have an energy saving compact rolling and finishing stands with several features. It has the features of short cooling bed, not the very long cooling bed of long products. You can have long cooling bed, short cooling beds of 30 meters depending on your product and finishing speed without cold cutting shear. So all these features together, you have a tremendous advantage in terms of compact layout, civil structural cost saving, less yield because the strand of the caster is one. That means less equipment, less consumables, and overall savings in the OPEX.
Okay, well, let's move to the next aspect that the enemy has in its midst. Well, what you see at the center is a mobile phone, the latest mobile phone, and what you see around it are those kind of gadgets which have gone obsolete just because of one mobile. Long ago, we had this dial telephone, which is no more used. We had the camera, we had separate cameras, which are no more, not so much in use. Then the flashlight, the alarm clock, the cassette player, the digital player, the hard copy maps, and then prints. All that what we had used to carry in our pockets, are now into one mobile. So that's what I say, multiple features into one. So talking about the multiple features into one, the QSP doing. The first, to produce any grade. HSLA, weather resistant, dual phase, LCMC, low carbon, medium carbon, API, electric speed, and I take a note here, IF also is possible through the QSP doing. Later in the evening, when we meet over the pool, I can explain to those who are curious how IF can also be done. Because since it's a bigger subject, it needs a little bit of more deliberation. So I kept it intentionally not showing this so that we have a time to talk about it. Then the three operating modes. Which are the three operating modes? One, coil to coil mode, which everyone known about it, the semi-endless and the endless. Well, I can say that there is a good amount of knowledge and idea about the endless. But people try to question, okay, semi-endless is nothing but in between you have tried to put a sandwich. But later I can explain to you when semi-endless becomes your real power. It is like you are on one side coil to coil, which has, of course, certain benefits to an extent. Then you have the endless, which is beneficial for your ultra thin gauges. But then semi-endless is the one which helps you to navigate between that range of say 1.4 to 2.5 to 3 mm. In semi-endless, okay, let me speak about you take a longer slab and you try to make small parts out of it. How does it help? Let's talk about non-grain oriented or grain oriented electrical steel, which require a very superior flatness and control over thickness. So it's not possible in coil to coil because it requires high temperature, and in coil to coil getting the geometrical tolerances is difficult. While on endless it's not possible because it needs a very slow casting speed, and when it has a low casting speed you don't get the mass flow to have the endless. So in between it's semi-endless. You take a longer slab which is as good as your tunnel furnace. Then once the longer slab goes to the finishing unit and has control on the down coiler, it acts just like a semi-endless, kind of endless feature. But the important thing is, in such scenario, since the mill is already endless, there are certain gauges after the finish, after the segment which communicate to each other. That is feed forward and feed backward, which maintains the healthy and flat profile that is required generated from the rough mill. And so you can produce this electrical steel. So let's see what more. The third of it is the spiral, which says 0.7 mm to 25.4 mm. We have commissioned a plant in China, which was Likum Iron and Steel. The first coil was produced last year, April. And this plant is the world's highest productive direct casting and rolling plant with 4.6 MTPA. We have two strands there, followed by a roughing train, as I explained. And then that plant is capable to produce the endless, semi-endless, and coil to coil with a range of 0.8 mm to 25.4 mm also. And recently we have that casted a slab of 145 mm. And so that was the reason I mentioned direct casting and not thin slab casting. Thin slab casting is a concept, is a concept which is of past. How did thin slab casting really started? With 1980, late 1980s or early 90s, the slab thickness was around 40 to 60 mm. But now with the evolution, with the technology and innovation, we'd like to show you over the next slides, we are able to cast up to 145 and have design up to 160. Why we go for a thicker slabs? To have control on your casting, and then when you have a thicker slab, you have much more reduction in your bed. Well, Abhishek, you like to speak about the media?
So media also does not have any limitation in terms of flexibility. You can roll rolling grades of up to high carbon in the grades and all kinds of long products. Bar, straight rebars in straight length, wear rods, smooth or wear rod in coils, spoolers, which is rebar in coil. One particular section I would like to mention over here, merchant products. Mila has produced that as well in one of our plants in CMC Arizona 2, which is called merchant products line section producers produce that. It's a long, small campaign products because of the marketing and selling requirement. So you need really small campaign times. So the question comes, how can you produce that kind of product in sectional products in endless loading? That is been achieved with certain accommodations, the concept of two cooling belts in one of our plants. So yes, or as my colleague Mr. Narasimhan said, Vida QLP or Vida can also produce various products with lots of flexibility in the long side.
Let's move to the next slides. Now this is about flat quality strip mill or the direct casting and rolling. Over the years, starting from 1985, now the 2025, you can see how the slab thickness has improved up to 160. We have a design of 160 and we have produced 145 mm and UCO. And we are going to produce also 130 mm from another plant in New Corvus, Virginia. The next of the capacity is the throughput. So we have demonstrated consistent throughput of 7 to 8 and also have a design of 0.5. This is with respect to the throughput. Then this is the interesting bit which I tried to mention about when I said you iron and steel. Over the years, how we have increased the capacity per strand in terms of direct casting and rolling. Now we can also with a specific product mix talk about 3 MTPA per strand or also 4 MTPA per strand, which of course will not give you a diversity of your product mix. You have to limit your product mix to a certain, and then it's possible. All this is possible because of the high speed casting that we are talking of, and the thicker mold giving us the possibility to use flat mold. Once you use the flat mold, you can have thicker slabs, and thicker slabs you can install the styler, which are the features which are coming from the conventional slab castings. So the best of it, of course, is the conventional hot strip mill, and what we are able to adopt from the hot strip mill, the premium features of the caster, the split rolling facility coming from rougher and finisher, which helps you to have a thermomechanical rolling. Is that all which is incorporated in TSCR, rather direct casting and rolling, keeping the length of the base or the length of the footprint very short enough.
On the long side, if you see the media evaluation, we had our first plant commissioned in 2007. It's in CMC. And then the first spooler line, the rebar coil line, was commissioned at Sobel Signor at Greece. First octocaster, 2015, at CMC second plant. Within Pinggan, China, it's called Green Mila. Two casting strands connected to two separate mills to achieve a capacity of 1.3 to 1.4 million ton. Each casting strand has reached a throughput of 105 up to 111 tons per hour. It's a world record. First merchant mill, as I was talking about, CMC Arizona 2, lots of products including the depots that has been commissioned last year. We also have our first media coming, having the high carbon grade to be rolled at Basundhara's Group, Bangladesh. And PSG, Pacific Steel Group, it's a plant to be located at Mojave Desert, California. It will be the first plant in the world to be run on 40% basis renewable energy, solar. So that's about the media evolution.
Well, let's go to the next slide. Yeah, coming back to the flat, the QSP. This is the evolution of QSP. The first generation. Okay, while I believe you have seen how the generation 1 and generation 2 happened. The generation 1 was one rocket stand with certain gap in between, and then there were finishing frames. Generation 2 is two ruffers with certain heat holding devices after the ruffer and the finishing bed. So this configuration, what you see is the tunnel furnace before the rougher, two roughing stands, then a longer gap with some heat holding devices, and then the finishing train. This was generation 2, 2007 in QSP. So with this generation, you can the references what I can talk about is the plant, the first CSCR in the world, which could produce API grades was OMK Russia, was the dynamic plant, which was based on this. And the generation number 3 in 2011. What we did, we reduced the gap between the rougher and the finishing in order to have a better OPEX and CAPEX control. Then from generation 3 to generation 4, 2016, QSP2A, that was when we introduced the endless and the three operating modes, which organized in as our first reference. Here you would appreciate that the rubber is becoming three stands, and then the finishing mill is having five stands. In between, we remove the heat holding devices and introduce induction heaters, which are more compact and more efficient with ethanol furnace. And then, of course, since it is endless, we need to have a high speed shear before the boiler. From generation 4 to generation number 5, QSP Due Plus. We can install four ruffers with the induction heaters in between and top of five finishing trains and a tunnel furnace suitable one in order to give you the capacities of more than 4.5 or 5 motors possible. Well, the worldwide differences, the ones which are blue, I think here it looks all same, are of QSP, and the ones, let me read it out, Shogang, Newport, West Virginia are the plants where there is endless capability. So we call it QSP today.
As far as the media is concerned, we have 27 references worldwide. Out of that, 14 are in operation, 13 is under commissioning. Out of these 27 references, Jaira Ishwat in Kurnool, our first media of 350,000 tons per year, has been commissioned last week, and 750,000 tons per year of media, which is under construction at Tata Steel, Ludhiana. It will be commissioned by the later half of this year. So that's about the media running plants successfully worldwide.
Well, it was great pleasure for us to hear the people who actually operate the plants and to hear from them some nice words about our company, I mean, about our technology generally, and of course also a few things which are the challenges. We normally interact with the project teams, but at the same time, we was very happy to hear about the operational maintenance team talking about them. And continuing this, we believe will have chance to engage with most of you since there are various discussions that we are having with Tata, with the team of Tata, JSW, the team of AMS, with the team of SAIL. Thank you.
And thank you so much for allowing long in the dedicated session for flat. Thank you so much. I appreciate it.
Yes.
Yeah, my question is to the facts. In QSP 2 plus, so finally you have three down coilers. Am I right? How many down coilers?
See, how many downpullers do we have? Depends on the capacity.
Yeah.
If you talk of 2 million say per strand, then
Because when you are going for an endless mode, so I don't know, the one down coiler is not sufficient. I just want to understand.
yes, this question already you have from Tata.
Yes.
Already we had this question from your team and we have answered that. Let me again put it to you. So when I say the beauty of this technology is to have three operating modes. If you have only endless, you're right, you should be going for three. Because an endless operation needs minimum two down coilers. And then in case of any emergency, when one down coiler is down, you should keep the third one. Why in case of QSP here, I speak about two is sufficient. Why? Let's say we're going through in English. If something happens, say one of the coilers is down, but the second coiler, which will be lighter up here, you will switch over to coil mode. And what is limiting you in coil is strip thickness less than 1 point. But of course, less than 1 point will be a small share. It will be a periodic loss of your right. But then from 1.2 to 2.5 can also be in coiling. Always coil to coil moves. Then you'll have one coiler, and with one coil, it's 2 MTPA capacity. But in your case, 2.5 with two coilers. One coiler will easily give you 1.5 to 1 coils. So that's you may not have to stop down your production. You still have an option of going to coil, and in coil, you still can scale it up to 1.4, 1.5.
You just to clarify one more. So thickness, how you want to take care of the thickness. So 1.2, 0.5 can be to switch down in endless mode.
Yes. I would say, normally speaking, 1.2 and below has to be mandatorily through the endless route. Then above 6, we recommend to go to coil. Why up to 6 One is the limitation of the high speed shear, which parts. Second, at above 6 whenever you are in endless, there is a challenge of having a mass flow from the caster side, and also the thickness is more. Putting more heat by the injection heater does not make your process economic. So that's the ideal range, that's 6. So 1.5 to 6 is 1, which you can hold it coil to coil.
And one more question is, what about the descaling pressure which you suggest?
330 bar. So we have 3 point descalers. One is run before the pendulum, that is 50 bar. Then there is one descaler before the rotator. Then there is one descaler before the finishing ring. Now the descaler can also be attached with a transfer bar cooling system, as it was also mentioned. Transfer bar cooling is something required for grades required temperature less than 90 so it's a triple system, it anti mechanical, but then there are certain grades of hot, high strength steel, I would say EN10149, which goes to your cold rolling for forming and it has a strength of more than 500. Even those require the kind of thermomechanical.
And what about these lab? That is what you can.
Yes, slab thickness, as I mentioned, from the design point of view, we can have up to 160. We have demonstrated up to 145. Now, based on your output, that is, you require a 2 MTPA, 2.5 MTPA, what are your strands, what is the product mix, we can define the thickness of the slab. Okay, and then there's like, if you talk of penetrating steel, we still have some references where penetrating steel are being rolled, Algoma in Canada, and also pure tungsten. So penetrating is requires a thicker mold.
Yes.
Because there is, a tendency of break out from that. So it requires a thicker mold. When it requires a thicker mold, we have a probability of putting some styles in it. So we start with it. If the customer demands penetrating steel of certain amount, then we talk about the thicker mold. So there is also flexibility of keeping a thicker mold for penetrating use and going to the thinner ones or thinner slab thickness. But typically, and also if you talk of ultra low carbon or IFC, you should have a thicker mold. So we talk of 110, 130. All depends on your, the volume that you're talking about, 1.5.
I mean, higher you can say that we can able to produce. What about the casting speed of the
Casting speed, as I mentioned, with medium carbon, for instance, which comes to my mind, we have demonstrated 6 MPM, 6 meters per minute. And also with low carbon, a consistent 5.5 is possible. So that's how we are able to bring in this high throughput of even 4.5 with two masters.
what about higher casting speed? Higher casting speed.
IF casting speed, this ultra low carbon again requires low speeds.
Thank you. One question from my side here. Back. Here.
Sorry.
Any of your supplier has supplied IF to automotive sales using this technology?
Yeah, I would say this is the first. The company Newport, West Virginia, which is under construction, will be ready by 2026 later next year. We have an agreement that we jointly will develop this. So on technologically, we have convinced them why IFC. I can tell you, in case of IFC, this is like calcium free casting. So one feature that we have added is the cell is having a automatic, we have put a robot, so we can have a quick change, which will enhance longer sequences. The second is the mode will be wider enough. So when the mode is wider enough, you can have the styling facility and you can have a keyboard taking. Then on the lower side, of the segments, there are a few more features that will prevent any kind of bulging. In case all this fails, there is still a provision of having an offline staffing system. So after the tunnel furnace, this is what is also a possibility you have to. The slack can be taken out and the staff put it back to tunnel furnace. You can keep floor induction heaters, heat it up. So challenge remains only on the casting. So this we have demonstrated and Yukon has agreed to implement that. And this will be the first plant which will really produce life. Yeah, this one, CRGO, that is grain oriented and non-grain oriented. The non-grain oriented, we have demonstrated one in China, Ben 60, I don't know. So there we have demonstrated one non-grain oriented. Grain oriented, we have technology. Still, this electrical steel also distinguishing, slowly is getting up. We will be glad to jointly work with any of the customer. As I said to you, the main thing, grain oriented and non-grain oriented, has more to do with the downstream rather than only hot roll events. In hot roll, what we have to ensure is it has to have a proper climate because these go as a core for the transformers and we should not have the losses. Feed forward and backward dimension. We keep also the multifunction gate after the rush. And then the functional will speak to that. And with the connection heater, the scan manometer after that, and also ensure how much temperature we have to maintain. So normally more than 920 degrees centigrade is required. So with the injection heaters, you can raise the temperature. You can maintain the effort.
Last question now. What is the defect rate you are getting in this products?
I would, it's good enough. Let me see the ranges and everything. Okay, but I would give an example of Shawang's and tank. I would ask few slides which have been because of time. The Shawang's tank is a plant in the present scenario which is producing 2.3 consistently, and more than 90% is the thinner gauge. In the current scenario where Chinese market is really down, and they have also substituted the cold rolling. So how they substituted? They have substituted the panels They have somebody, something by directly moving to galvanizing line or directly moving to the petrol and oil line. So they have done the substitution and have. I can share more details about your bank.
This is definitely going to happen. If it is quality, it is good. Cold rolling has to be a struggle.
Yes.
Yeah, any other questions?
In case of QSD, how will you identify the defects at the slabs? Do you have any slab inspection system?
Yeah, slab inspection, yes, it is possible to put a inspection gauge before the pendulum shear.
Okay, because you're telling about the defects, where defects can come from the rolling and casting. So you have to inspect it. So that is coming from the casting or to so I think it should be there as slab inspection system.
Yes, you're right. So when I spoke about the IFA, the customer with which we are doing developing new called Virginia, we have provision of putting up a slab inspection before the pendulum shear.
Or not basically, is it will be machine learning based or
I cannot give us more details on it because this is a development with the customer you got. Okay, and there are some agreements to it. What I can tell you is that certainly it's very important as it's a priority that we have to have a from this land. And when you talk of higher rates, you really have to know it. So we have this provision of putting a inspection gauge before the pendulum. And as later on, the farmers can also give back the away to the staff. And
Now let me.
thank you very much. I can say
It's time to conduct the session. So I like to invite Sri M. Balaji to give some insights on it.
Yeah, good evening and it's a great meeting. Thank you. We started with quality issues in the first time. Nice. What's going impact on BSC and we got good insights in the creation. So we can how we have to get to the BC market and being effective into the new product development. And then we had two shop floor, you can say Kaizens, and where people have tried to get into the role for the product. And then see what's number one. This is what we are because sustainability and sustainability we say to reuse. And we start this portfolio system of rich this and I'm guessing that state has explained on this. And we started with second interviews where on the latest news. Yes, ESP has put up their new facility, followed by the new plant which is going to come from SAIL-ISP planning part, and then the new CSP which has come up with having some problems of surface quality and their failures in Jagdalpur. And finally, this is a good eye-opening session who are thinking of investing. I think it's more of a disruptive. We are talking of artificial intelligence and machine learning. But this technology, if it really comes, it's a difficult scenario for cold rolling mills. Because we heard that a lot of cold rolling mill market has been wiped out in China because of this product, especially 0.7 to 1.9. However, Indians are not yet ready in investing, but Tata Steel, I think it's in talk with one of the million junction, endless story. So, with this, I think the session have comes from the day. Thank you.
Now it's time to facilitate all the presenters of this session by our session chairman, sir. I am calling presenters one by one. Please come on stage and correct your memento as a token of appreciation. Mr. Sunil Mitra, same BSP. Mr. Ritesh Kumar, SAIL-RSP. Mr. Harjit Anand, SAIL BSL. Mr. M.K. Singh, SAIL RDCIs. Mr. Ravi Kumar, JSPL Angul. Mr. SK, SAIL-ISP. Mr. Bhagwan Singh and A. Gawande, NMDC Steel. And the last one, Mr. Narasimham A and A. Bhadra from Daniel. Now I would like to invite our CM WRM Sri Shailendra Kumar sir to facilitate our session chair. End of the session and thank you for your cooperation.
Uh, we have a cultural program right now. When you come outside this auditorium, right hand side, there's the pool. Said that we have this cultural program covered by English. So all of you are invited to join the 10 minutes. You have a small break, and all of you are requested to join there. Please use you can since it's going on, you can use this side of our right here. Yes, yes, you can keep it here. And tomorrow we plan to start our sessions by 8:45. So we have been around 9. The announcements will be there. So we please be there by 8:45 so that you can start by 8:45 sharp. Okay.
हाँ हाँ इसका समय तेरा लगेगा अभी उसके पास अब गलती हम कल भी है हाँ तो जस्ट चार के फास्ट तो फिर क्या तो मना वही ना फिर ना है ना
You can keep your whatever this family in Arabic, have your dinner. When going back, you please pick it up. Okay. So don't keep it here because we will be having people coming for cleaning and all those purposes. So you can keep it here. So at 9 o'clock, 10 o'clock, whenever you are leaving, at that time please take it.
जब से पूछ के हाँ क्या वो खत्म हो गया अपने किनके में जाएंगे तो यहाँ बेटा पास में के तो हमारा घर में तो छोड़ कोई 8 करते करते 8 बज जाएगा ना कौन बेटी अरे अजय दा क्या भाई खत्म हो गया तो बाद